Hello, everyone. How are you today? Hope everyone is off to a good Wednesday/Thursday, depending on where you are. We're going to try something a little different today. So I've been talking to people and been trying to figure out, like, how do I get some little snippets of intro to Sudoku variant stuff into the stream? And so I've sort of settled internally on a format I want to try, at least for a few streams. We'll see how it goes. So this is the format that I'm going to go with. I'm going to pick a constraint. Today, that constraint is Kropki Pairs, which I'll define for you in a second. And I'm going to do 3 gas puzzles with that constraint. So what is a gas puzzle? If you've never seen a gas puzzle before, there's one posted every day on the Cracking the Cryptic Discord. And they're meant to be quick puzzles. So they're meant for people to speed run a lot of the time. I'm not going to speed run them. I'm going to go slow and try and explain all the different steps that go through them. And then after I do the 3 gas puzzles with that constraint, I'm going to find a puzzle that is 2 or 3 stars and do that puzzle with that constraint and sort of talk about what we've learned. So I'll try and sort of teach you the things to look at when you're looking at a Kropki Pairs puzzle, and then we'll do some puzzles and so you can see it done. And then after we've done that, I expect that's going to take an hour-ish. We'll see. After we've done that, then we'll hop in and we'll do the most voted on puzzle, which I'm looking forward to because it has renban in it and other reasons. But we have a most voted on puzzle from the bucket, which is a Derektionary ambiguity puzzle that should be great. And then we'll go on and we'll sort of stream as usual. But I want to have these, and I want to have them at the beginning to sort of welcome new people. And I want to have them sort of be clippable so that people can go back and be like, okay, what is it I'm supposed to know about Kropki? And then know what they're supposed to do. Okay. So you'll see these dots, and I'm starting with Kropki because you'll see these dots sort of scattered in their own puzzles, but also in lots of other puzzles. So it's pretty common to have a puzzle that will have some variant, but then it'll have a few of these dots, a few black dots, a few white dots, or whatever. Naverio says that he believes this will take more than an hour. We'll see. Well, we've got plenty of time today, so I'm going to take however long it takes. So white dots, whenever you see them, they essentially always mean that these 2 digits are consecutive. So they mean, for example, I should turn the number pad on. It'll take a lot longer if I don't turn the number pad on, I'll tell you that much. So these could be a 6 and a 7. This could be an 8 and a 7. Well, that doesn't work. It could be an 8 and a 9, for example, and then this could be a 7 and a 6. So we've got this sort of pattern going on that's what white dots mean. Black dots mean that there is a ratio of 1 to 2 between the 2 things. So one of them is double the other. So this could be a 4 and a 2, for example, or an 8 and a 4. Or you can imagine what all the other variations are for one is double the other. And again, you don't know, it's not like there's no left to right preference. It could be 8 to 4 or 4 to 8. Either way, it does not matter. All right. Now, every puzzle we're going to be doing today is what is properly called a Kropki Pairs puzzle, as opposed to a Kropki puzzle. These are called Kropki dots frequently, although that's a bit silly because Kropki actually is the Polish word for dots. That's why they're called Kropki, if you're curious. But when someone says that there is a Kropki puzzle, what they theoretically should mean, although this is pretty uncommon these days, but what they theoretically should mean is that actually, in addition to everything I just said, there's also what's called a negative constraint, meaning that I could not put an 8 next to a 4 without a black dot between them. But that's not what's going on here. In all the puzzles today, they're just what's called a Kropki Pairs puzzle, which just means some dots are given, but not necessarily all of them. And so you'll see that that's phrased in the directions as there are no negative constraints. And so a negative constraint is when you say that actually all possible clues of a certain type are given. That's not the case here. Okay, so I've attempted to prepare a visual because I've tried to sort of draw this picture in the air lots of times. First of all, I'll say black dots are better than white dots in terms of information they're given. And so this little picture you can have in your head of how black dots are related. So this has every digit 1 through 9, and every digit or every possible black dot relationship is given. And an awful lot of the deductions that we're going to show just follow from looking at this picture. And so I want to point out a couple things in this picture. One, there's only two threads. There's this 1, 2, 4, 8 thread, which I'm pointing at the wrong side. There's this 1, 2, 4, 8 thread, and there's this 3, 6 thread. And then there's this 5, 7, and 9 that don't play well with anyone. So any digit that's on a black dot can't be a 5, 7, 9 at all. But I want to show you something that's really nice, which is anytime you see 3 Kropki dots like this, 3 cells that are connected by black dots, that's going to tell you a huge amount of information, because it tells you there's 3 digits on the sheet somewhere that are connected. And you'll notice there's only one place that can happen, which is in this thread, the 1, 2, 4, 8. And in fact, actually, there's only 2 combinations of 3 digits that this could be at all. Namely, it could be 1, 2, 4, or it could be 2, 4, 8. Those are the only ways that you can get 3 dots connected like this. And so that tells you a whole bunch of things just from that. So these digits have to be from 1, 2, 4, 8. But better, and Andrew's already telling me the gotcha, and fortunately I picked a puzzle that has the gotcha that I can explain in a second. I'm not going to do bet cells during the tutorial. I'll do bet cells once we get to the next puzzle. But I'm going to try and keep the tutorial piece as clean as possible. We'll see how that goes. All right. Oh, there was definitely a similar sheet of paper for white dots. Don't you worry. So the middle digit. The middle digit is always a 2 or a 4. And so you can actually get rid of this 1 and 8. And actually, there's always both a 2 and a 4 included in these digits. And so the way we indicate that is by these corner marks. And so the center marks here mean I know whatever digit goes in this cell at the end of the day, it's always a 1, 2, 4, or 8. Yeah, people in chat, make up your own bet cell and bet. There you go. If you're excited for a bet cell, you can make up a bet cell and then you can bet on it. But I promise there'll be a bet cell once we finish this puzzle. So that tells me all of that, and it also tells me that the 2 and 4 within this box are in these, which is why they're corner marked. All right. So now Andrew pointed out an immediate, easy way to misstep with this piece of logic that I've just pointed out, which is these dots. And so you might be inclined to think I could do exactly the same thing with these 3 dots that we did with these 3 dots. Or 3 cells, I suppose. It's 2 dots, but 3 cells. But you can't, and the reason why you can't is that these 2 digits don't have to be different. So the punchline here really was this 3, 6 black dot was not on the table because I could not put 3 digits here. But I actually can use the 3, 6 dot here because I could go 3, 6, 3. Because I am not breaking anything when I do this. This is a super, super easy mistake to make, is to apply this piece of logic that I showed you in yellow over here in one of these places where it doesn't apply. And if you go back through the stream archives, you can find plenty of instances of me missing this. And I can think of at least once where Simon on Cracking the Cryptic got confused by missing this. It's super easy, but make sure you're only applying this piece of logic when you have 3 dots that see each other. Okay. But there's several places in this puzzle where we can apply what I'm going to call the yellow logic, and I'm just going to highlight them all for you. Oops. And then I'm going to lose my highlighting, which would be very unfortunate. Okay, so all of these places are strings where we can apply exactly the same logic. So all of these digits, they're all from 1, 2, 4, 8. And in all instances, the middle digit is going to have to be a 2 or 4. Note, if I tried to put a 1 in the middle, you can think about what that would do. If I tried to put a 1 in the middle, then that would put 2 2s next to it, because 2 is the only thing that connects to 1. Okay, so we've got all of that labeled. So that's the very first thing I would look for in any Kropki puzzle, is do I have any instances where I can apply this trick? Because quite often you will. Okay, now, this sheet of paper does keep on giving, because let's look at box 7. I have 3 of 1, 2, 4, 8 here. Okay, so again, going back to my picture, 3 of 1, 2, 4, 8 in this box, in box 7, are here. So what's this dot? Well, this dot absolutely cannot be from 1, 2, 4, 8, because only 1 or 8 is left over from here. And so the only things that can go here are 3 and... Sorry, I'm trying to point at this. The only things that can go here are 3 and 6. That is all that is left. So this is a 3, 6 going up here. Exactly the same thing happens over here. Because again, I've used 3 of my 1, 2, 4, 8 over here. So I get a 3, 6 up here. And let's see, is that might be all that I get for now. So now we should talk about white dots. And so Josh, I think, jokingly asked if I had a drawing for white dots, but of course I have a drawing for white dots. And now this drawing shows you all the possible white dot connections. But all the possible white dot connections, I've drawn this graph in a way that's probably not what you pictured. And I've drawn it in such a way to make evident the fact that the white dot graph, that is this diagram that I have here, it's bipartite. And now you don't have to really know what bipartite means, but secretly, most of the time in a Sudoku puzzle when you get to color, it's because there's an underlying graph that's bipartite. And so what does that mean here? It means that there's this group on the left, the odd numbers, and this group on the right, the even numbers. And every zig and zag connects an odd number and an even number. Which means that when I connect from here, this cell is even. Automatically, this cell is going to be odd. And this cell is going to therefore have to be even again. Okay, which tells me what digit this is. Namely, it tells me that this digit is a 6. Because 6 is even, and 3 is not. So this digit is a 6, is the punchline of that. And this digit's odd. In fact, you could, if you wanted, fill in that it's 1, 3, or 5, and I bet we'll know which it is in a second. By the way, Zach is off taking notes to the side, because he's always been interested in the Sudoku stuff. So until the end of this, we're not going to... sorry, I will try not to look away from the mic, Tristan tells me. Oh, I realize why. I keep looking away from the mic because I didn't pop out the chat because I was used to playing Outer Wilds. Whoop. There we go. All right. 1/2 second for me. Because I did not set this up. And Tristan is right. It will make the world better if I do this. Okay. There we go. All right. So we'll have to wait for a moment to get Zach's digit dances. But we have this. No, so if you're curious what happens, when I do Sudoku, I typically put the chat on top of the Sudoku grid. So you all in my grid that I'm looking at are where I am on your grid. But when we stream video games, which we've been doing lately, by the way, if you're interested in seeing Tristan and I play the Outer Wilds, we did that recently, and it was fun. Then you could do that. But if I'm playing Outer Wilds, that's full screen, so I have to put the chat over on the laptop, which is on a separate screen, and then everything is all weird and blah, blah, blah. Okay. So let's fill in what that gives us. So this is a 6, so this is a 3. And now this 6 is connected by a white dot to something that then connects to a 2 or a 4. And so the only option there is that this is a 5 and a 4. And now I can write down what these digits are. So they are the 2 digits that connect to 4, which are 2 and 8. And so now this digit cannot be 4, because there's a 4 in the row. And there's also this 2-8 pair, meaning that this can't be 2 or 8, because if it was 2 or 8, it would put too many 2 or 8s in the row. So now this cell is down to one option, which is to say it's a 1. And so once this is a 1, that then forces that this is a 2 and this is a 4. And once this is a 1 now, this 1 is on a white dot relationship with this. Well, 1 and 8 are, and this is your fact of the day, 1 and 8 are not consecutive. So this has got to be a 2. That's an 8. And now this 4 over here I see is on a white dot with this digit, which means that this digit is a 3 or a 5, except it can't be a 3. So this is a 5. And we get to do lots more stuff, because now this 4 looks up here and gives me a 2. This 4 looks up here and gives me a 2. So these digits are not 2, and they're not 8 either, because 2 and 8 aren't adjacent. This digit here is not a 1 or a 2 by the column, but it is black dotted with 2, so it has to be a 4. It can't be an 8, so that's a 1. This digit can't be a 2 or a 4. Now, one thing that you will also notice about this is there's only 1, 1, or 8 in any string of 3 black dots that actually see each other. Again, I'm excluding this one over here from discussion. But because of my piece of the chart here, there's either a 1 or there's an 8. I can't include both a 1 and an 8. And so as soon as this cell is a 1 or 8, it actually tells me that this cell's not a 1 or 8. It's the other 2, 4. So I get that. I just say that because it's useful. I think it's probably not what you would see if you were looking at this, because this digit's a 1 or an 8. A thing that's really useful also to notice about the white dot picture that you're going to see used a lot is that anytime you have a 1 or a 9 on a white dot, that's super interesting, because 1 and 9 only connect to one digit. 1 only connects to 2, 9 only connects to 8. And so you should ask yourself, if you are about to put a 1 on a white dot, you should ask yourself, hey, can this really be a 1? Because if this was a 1, the consequence of that is it would immediately put a 2 here. And I see 2 separate problems with that. One is that there's already a 2 in the column, and the other is that there's already a 2 in the box. So this super can't be a 1. It's got to be an 8, 4, 2, like that. And so we've got all of our thing here. Okay, this will therefore be a 7 or 9 because it connects to 8. All right. Now there's something interesting about this cell, which is that this cell sees in its column 1, 2, 4, and 8, and it sees in its column 1, 2, and 4, and it sees in its box 8. So this cell, if I just look at what this cell is allowed to be, it's not allowed to be anything from this string, which means it can only be one of these two. It has no other options. So this is 3, 6, and therefore this is 3, 6 because it connects to it. But I actually know the order because this 3 looks up here and tells me that's going to be a 6 and a 3. And this is going to be a 5 and a 7. And so we have that additional piece of information that we can fill in. Okay, let's look at this cell. Anytime something is on a white dot, you should fill it in. So for example, I should have noticed a long time ago, but I didn't, that this 3 is next to a 1 or a 4, but it's got to be a 4 and a 1 going there. No choices for that. So we have that. I want to fill in this one. This has got to be a 1 or a 3. Now, for a very similar reason, this can't be a 1. If you're just showing up, I'm trying opening with a sort of like intro to Kropki. So I'm going to do a few easier Kropki puzzles, and then we'll get to the normal insanity that is this stream. So this is a 1 or a 3, but if it's a 1, then this cell has to be a 2, which is already in the row. So this can't be a 1. So this is a 3. And therefore, this is the only digit that black dots with 3, namely 6. Which means these are the 2 digits that play nicely with 6, namely the 2 that are consecutive. So this is a 5-7 pair. And so we get all of that going on right away. All right. Now what do we have going on? Now 3 is placed in this box. So what's going to very often happen in these puzzles is you're going to have lots of Sudoku stuff on 3s and 6s and 2s and 4s. In this instance, 3 is ruled out of all of these cells by the row, and it's ruled out of these cells by the columns. And so 3 is now placed right in the center here, which is nice. I also can ask myself a similar question about 3 in this box. And so 3 in this box, if you just look at it, well, it's, spoiler, 3 is not 1, 2, or 4. 3 can't go here because there's a 3 in the column. But actually, if you look at it, I can't put 3 on this white dot at all either. And that's a thing you should pay attention to. Because 3 is only adjacent to 2 and 4, but 2 and 4 are already gone in the box. So if I put a 3 on this white dot, I have broken the puzzle. So I can't put a 3 on this white dot either. And so none of those are 3. That's not 3, that's not 3. So that is a 3. And now we can sort of bounce down to this box. That's a 3, just by Sudoku. And if I now come over here in this box, 3 is, I guess, in one of these 2 spots. I'll go ahead and do that. Gas chaos construction when? Yes. There was a while ago where Clover, who's one of the regular constructors of the gas puzzles, was asking who would the scariest gas guest setter be, and it was definitely, for me, it was definitely today's gas guest setter is either totally normal cat or glipperal. I think those are the most terrifying of potential gas guest setters. So this 3 goes ahead and puts a 6 over here, puts a 3 there. That means that there is a 3 in one of these 2 cells. Gas Little Killer by Glipperal. Oh no, oh no. Alrighty, hey Omega, how are you? Alrighty, so I like to start just filling in digits once I have 5 things, just so I don't miss anything. So this is a 5, 7, 8, 9. These aren't 5, so these are from 7, 8, 9. Let's see. These digits are 1, 2, 3, 4, 5, 6, 7, 9. 1, 7, 9. If you look closely, these can't be 1, so in fact that's the 1. I'm doing well. I am having fun doing this this lovely little gas puzzle. So now these digits, if I look, I've got the 7 and 9 in the column. So these are from 2, 4, 5, and then we've got 6, 7, 8, 9 down there. This one's not 2, this one's not 4. But here's a neat thing about that. This is a 2, 4, 5 triple. So the 5 is definitely in here. So this can't be a 5 in the box. And so that's a 7, which then actually goes and does more damage because it comes over here and means that's a 5. So now that's a 7. That 5 bounces back and means that's a 2. So this isn't a 2. Now I've got here 7, 6, 5 blank. So this had better be a 4. Or bad things are happening. That 4 sees over here and makes that a 5 and a 4. These aren't 7. I'm going to go ahead and update while I am noticing it. This is 2 or 8, but I don't think it's resolved yet. These 3 digits over here are 1. We've got a 2, 3, 4. We need a 5. No, we don't need a 5. We've got a 2, 3, 4, 5, 6, 7. These are 8 and 9 is what these are. This one is not 1. Somehow, strangely, I think we don't know anything about the rest of this. I'm about to, though, because up here, what do I need? In row 1, I need a 1. Well, in row 1, I need a 1. I've got a 2, 3, 4. I need a 5. I've got a 6, 7. I need an 8 and a 9. This isn't a 1. Neither of these can be 8. That one's not a 5 either. So now, actually, if you look at this and ask, where does 5 go in row 1? You now actually get that this cell has to be the 5. Because another way to say that, if you want, is that this is a 1, 8, 9 triple. So that's a 5 in order to make this work. Let's see. So this column now only has a few things left in it. So let's fill those in. So we've got 1, 2, 3, 4, 5. We need 6, 7, 8, 9. This isn't 7 or 8. It is 6 or 9. This isn't 6. In fact, actually, when I see that this digit is 7, 8, or 9, it makes me very suspicious. Because this digit's very high, and a thing is, if you're consecutive with a digit that's very high, that means this digit's also very high. So this digit's also going to have to be a 6, 7, 8, or 9. Because if I'm adjacent to a 7, 8, or 9, this has to be a 6, 7, 8, or 9. Except this digit's not 6 or 8, because it sees a 6 in the row and an 8 in the column. But now once this is 7 or 9, this can't be 7 or 9, because 7 and 9 are not consecutive. So this is actually an 8. And that's going to do yet more damage, because I now have a 7-9 pair in this column, so this can't be a 7 or a 9 anymore. It's a 1, meaning that's not a 1. That's an 8-9 pair in the box, so this is now a 1. Let's see. So these, of course, aren't 8 anymore. I now have a 7-9 pair in the row, so this isn't a 7 or a 9, so it's a 5. So this is not a 5. This is certainly not an 8 anymore. That's not an 8 anymore. It's also not a 6. Gives me a 7-9 pair in this row, which is not super interesting, I suppose. This black dot has got to be very interesting, in particular this digit. So this digit here, actually, if you look at it, it sees 1, 2, 4, and it sees 3, 6. So again, sort of go through your mental checklist. That's all but one black dot digit. So in fact, that means that this digit has to be an 8. 8 is the only black dot digit that can go in this cell. Every other one has been eliminated. And that's something you'll see a lot in these sorts of puzzles as well. So that makes that a 4. Now, this is the dot we talked about earlier as being able to make sort of a crucial mistake, which is that if you sort of do this without thinking, you might go ahead and fill in a 2 here. But if you do fill in a 2 here, there's a pretty serious issue, which is that these two are the same digit. So this actually can't be a 2. This is an 8. So in fact, the problem that Andrew immediately highlighted when we started talking about these did actually come to fruition. All right, so that 8 down there sees up that that's a 2. This digit now has to be a 1 or a 3 because it's next to a 2. Well, it's not a 3 for a bunch of different reasons, so it's a 1. And that's super convenient because it now makes this a 2. This is now a 4 for lots of reasons. Take your pick of which reason you like. And now this 1, 2, 4 here has again forced this black dot to be 3, 6. Because, again, once I've used 3 of 1, 2, 4, 8 in the box, I can't use a 4th of 1, 2, 4, 8 on another black dot. So this has to be 3, 6. But I already know the 3 in this box is in one of these two cells by my pencil marks, so that's the 3 and that's the 6. So then by my pencil marks down here, the 3 could only go in one of these two cells, but we now know which one. It goes there. So we have all of that. Let's fill in these digits. We need a 1. We've got 2, 3, 4, 5, 6, 7. We need an 8 and a 9. These aren't the 8. So that's the 8, giving me a 1, 9 pair in the row, meaning that that's the 6. Meaning this digit here is a 7 or a 9 to finish off this box. This 1 sees up, making that a 9 and a 1. These 3 here are 2. We've got 3, 4, 5, 6, 7, 8, 9. 2, 5, 9. So this now, just by Sudoku, this is a 9. This is not a 5 or a 9, so it's a 2, and so that's a 5. This digit is a 7 or a 9 by the row. So now this box only has one digit left because it's got a 7, 9 pair in it. You're going to see, by the way, quite often exactly what's happening here will happen, which is that you have lots of 5s, 7s, and 9s sort of floating around in the grid. And, oh, nope. Nope, I did that wrong. Thank you. There's not a 7-9 pair here. Thank you, Jaleb. So this is much better, in fact, than what I was going to say. I'll finish what I was going to say, and then I'll do it right, which is that often you'll have lots of 5, 7, 9s floating around to disambiguate at the end, because 5, 7s, and 9s are completely agnostic to black dots. And since black dots are more powerful than white dots, often what will happen is you'll sort of lock in all the 1, 2, 4, 8, 6, 3 sorts of digits, and then the 5, 7, 9s have to get sorted out at the end of the day by white dot stuff. Okay, now let me do this correctly. This 9 sees this digit is a 7, and that digit's a 9, and this digit's a 7. And so this is a 9. Okay. Better. Thank you, Jaleb, for catching that. Got 1, 2, 3, 4, 5, and this digit's a 6. And so you've got 1, 2, 3, 4, 5, 6, 7, 8, and this is a 9. Let's see. Let's finish this row. It still needs a 1. Let's see. This box still needs a 6 and 7. So that's a 6 and that's a 7. There's a 9 in this box. So that's a 7 and a 9 and a 7. That 7 looks over and sees that that's a 9 and 8 and a 7. 8 looks up, gives me a 9 and an 8. These digits on this white dot are a 5 and a 6. 6 has to go there, and the 5 goes there. Nicholas won his bet cell. That is delightful. 1, 2, 3, 4. Okay, so we need a 5 in this column. It has to go there. 6, and so then we need a 7, so the 7's going to go there. And so then we've got 1, 2, 3, 4, 5, 6, 7, 8, and 9. And now we've got 1, 2, 3, 4, 5, 6, 7, and we need an 8. That is the puzzle. All right, so I think that is most of the techniques that you're going to see over and over again in Kropki puzzles. Okay, now I did want to actually sort of reset the puzzle and point out something that a lot of people in chat were saying that's a more advanced technique that I noticed when I first looked at the grid and assumed would not come up because it's a gas puzzle. But there's something you could notice when you first look at this grid that might raise your alert level if you're doing a more advanced puzzle, which is that I've got these two things that both have to be from 1, 2, 4, 8. So that means they both have a 2 and a 4 on them. And the question is really always going to be, when you think about this, are these two the same or are they different? And now in our solved grid, it turned out they were the same collection of digits. But quite often what will happen in a puzzle where you have a setup like this is it'll turn out, because of the information up here, it's not possible that these are the same set of digits. And here's the reason why, and this is what lots of people in chat were talking about. If these are the same set of digits, so, well, then where do those digits go in this box? Well, then they go there, which is what ended up happening. They went exactly there. And then actually, if you knew that that was what happened, that actually then tells you, well, I need to have a 1 and a 2 in here, and it's going to go 1, 2, 4, and you can sort of do that. And that's what's called roping. And so if you were seeing people talking about that in chat, that was what they were noticing. You will... I think that would be a very common break-in for a, 3-star Kropki puzzle, would be to note that kind of thing. All right, so let's do a couple more of these. And so we're gonna look at a couple more sort of gas level Kropki puzzles, and then we're going to look at the slightly harder kuraban Kropki puzzle. So let's again sort of immediately ask ourselves about strings of 3 black dots that see each other. And so we get lots of those, which is very generous. So the middle one is always a 2 or a 4. And we have this given digit doing work right away, because this 2 in the box tells me that this 2 or 4 is not a 2. So this is a 4. And now this digit is in a black dot relationship with 4, but it's not a 2. So this digit's an 8, and that's a 2. So we get to use our fancy givens. Now here there's something really cute going on. Could this center digit ever be a 2? And the answer is this center digit could never be a 2, because what happens if this center digit's a 2? Well, then these digits are the 2 digits that Kropki a 2, which is 1 and 4, and these 2 digits are the ones that white Kropki a 2, which are 1 and 3. Except you'll notice that what just happened in that universe is that we put 2 1s in the box. And we should not put 2 1s in the same box of a Sudoku if we want the answer correct. So this actually, for reasons that are cute, can't be a 2. It has to be a 4. And the exact same argument applies here, and the exact same argument applies here, because of this little constellation shape that we have here. So these digits are a 2 and an 8, and I'm noticing for the first time we have a given 8 in the south of the grid. So the given 8 actually tells me that this is an 8 and a 2. These are a 2 and an 8. We have a 2 up there, so that's the 2 and that's the 8. And we can go ahead and fill in all of these things. These are all a 3-5 pair, which is cool. Okay, so that is sort of lots of stuff happening at once. All right. So we've got all of that. So let's fill in other things, like this has to be a 1 or a 3. And let's fill in the rest of the digits in this box. So the rest of the digits in this box... and the reason why I'm doing this is because I'm particularly looking at what's going to happen with this white dot. I don't know yet, but it looks sus. So I need a 1. Got 2, 3, 4, 5. We need a 6, a 7. And we've got an 8, and we need a 9. Okay, so I want to immediately ask myself what this digit can be. If this is a 1... then this becomes a 2, which does not work because there's 1 in the column. If this is a 9, then this becomes an 8, which does not work because there's 1 in the column. So this digit's a 6 or a 7, which means this digit's adjacent either to 6 or 7. So this digit has to be a 5, a 6, or a 7. Notably, it cannot be an 8 because there is already an 8 in the row. By the way, I should fill in that this is a 7 or a 9. So we have that. Okay. This looks like there's something almost going on. Yeah, there's something going on here. The thing that's going on here is that this collection of digits will never work if I don't include a 6. And so there's a bunch of different ways to think about that, but the way I'll encourage you to think about it is every white dot, because of the sort of the bipartite magic graph I showed you earlier, every white dot has an even digit on it. We've completely pencil marked these 2 cells, and the only even digit that can possibly exist on this white dot is a 6. And so one of these 2 digits is a 6. I'm going to be slightly naughty, and I'm going to pencil mark this across boxes. So normally corner marks would mean one of these 2 digits in this box is a 6. In this instance, I've highlighted this in green to remind myself that it is it's the green cells that I'm saying one of them is a 6. So that has a couple consequences. One is that that's not a 6. And the other is that this black dot has become a little spicier. Because this black dot now can't have a 6 on it. So it can't have a 3 on it. We've cut off the 3-6 branch. It also can't have an 8 on it. So this dot is from 1 to 4 only. This one's not a 4. In other news, this one's not a 1 either. Because if this were a 1, that would be a 2, and that's no good because there's a 2 there. So this digit, in fact, is a 2. This digit's a 4, therefore. Or sorry. Hold your horses. This digit's a 1 or a 4. I don't know which. This digit's a 1 or a 3, but it's not a 3 because the column has a 3-5 pair in it. So this digit's a 1. So that digit is a 4. That was correct that time. So we have all of that sort of filling its way in. And now this cell is interesting again. Because now this cell is in the 1, 2, 4, 8 strand, right? It's got a 2, 4 in the middle. So these digits are all from 1, 2, 4, 8. But this one can't be 1, 2, or 4. So this digit is an 8. And that's great, because as soon as it's an 8, it lets me fill in the entire rest of the thing. That's a 4, that's a 2. And then we get another 3, 5. I like that this puzzle has a very clear theme, which is these magical 3, 5 hoobly-hoos are very cool. Okay, I should fill in what these digits are, by the way. I don't know why I never did. These are 2 or 8. And it's great that I've filled those in, because now I see that this 8 actually gave me the 2 and the 8. And so we have that going on. And so now I'm going to fill in the rest of these digits. And again, I'm doing that because I see that 2 of these are on dots that are likely to be very constrained. So the digits left in this box are 1. We've got 2, 3, 4, 5. We need a 6, a 7, and a 9. Okay, this digit, let's start with that. It can't really be a 1, because that would put a 2 here, and there's already a 2 in the column. I think, actually, it can be any of these other things, if I squint at it. At least, now you... Oh! Not if I fill in this. This is a 3-5 pair. That will help me a lot. Because this 4 is only adjacent to 3 and 5 in the column. I just never filled it in, despite talking at length about how there is this 3-5 pattern. Okay, so maybe that doesn't actually immediately do me any good. Let's look over at this dot. So there are 2 things I see immediately it is not. It is not 7 or 9, because 7 and 9, remember, are in their own little magical Kropki bubbles. They don't black dot with anything. So this digit is a 2 if that's a 1, and it's a 3 if that's a 6, is what I am seeing. I am looking at just Sudoku stuff. So where is 4 in box 6? So 4 in box 6 is over in this column. It's there or it's there. And now that's exciting because both of these 4s are on black dots. And it's even more exciting because this 4 is broken. This 4 can't actually... this 4 can't be the 4, because then this would need to be a 2 or an 8, and it can super be neither of them. So in fact, we actually get that this is the 4. And so now this is a 2 or an 8, but it's not a 2, so this is an 8. So we get that. Okay, so this digit I now want to try and force. And the reason for that is because I see it sees lots of 2, 4, 8s. It sees all of 2, 4, and 8. So if this cell wants to be one of the 1, 2, 4, 8 gang, then what digit does it have to be? It has to be a 1. But that doesn't work, because then this is a 2. So in fact, these are a 3-6 pair. For sure. I now want to use something ridiculous. But I probably shouldn't. But I think... Okay, so I'm going to anyway, even though I'm sure this is not the intended thing, but I think it's cool enough that I'll go over it. In this pair, one of these 2 is a 3. In this pair, one of these 2 is a 3. So what that means is I need to have a 3 in one of these 2 cells. Because what if neither of these is a 3? Well, then both of these are 3s. And that's a problem because I've put 2 3s in a box. So actually that gives me sort of a... Oops. That gives me a 3-corner mark here and a 3-corner mark here. And those do me 2 really cool things. So one is... it tells me this can't be 3 anymore. Because again, if this were 3, that would tell me these aren't 3, and now both of these are 3 in the same box. That's not great. So that's a 2, and that's a 1. These 3s also look over here, giving me a 5 and a 3. That 3 looks over here and gives me a 5 and a 3. And so that gives me some more joy out of these things. Let's see. So this isn't a 1. Actually, neither of these is a 1 anymore. They're 6, 7, or 9. Let's see. I'm being told that row 4, column 7 is given. Well, we have now gotten it. I now see the way that we could have gotten this that was much simpler than the way I did. Which is that there was a 3-5 pair looking at this cell that I had pencil marked as 2 or 3. Which is, very close. Hey, Nordy, how are you? So it's now being pointed out that I have placed 8 2s in the grid. And so anytime I've placed 8 2s, it should be within my power to place the last one. So the last one has to go here. It's the only place sudokologically that it can go. And so this digit has to be a 1 or a 4. I don't think I yet know which. There's a 3-5 pair in this column while we're pointing out 3-5 pairs. The 3-5 pair in this column looks at this cell and makes this cell a 1. Also, the 3 in the box looks at that cell and makes that cell a 1. Whichever way you want to do it. And let's go ahead and fill in the rest of these digits. So we've got 1, 2, 3, 4. We need a 5 and a 6 and a 7 and a 9. And now let's cross-examine this cell. This can't be a 9, because if this was a 9, this would need to be an 8, and it can't be. And so if this is a 5, this would have to be a 6. If this was a 6, this would have to be a 7, because it can't be a 5. And if this is a 7, this cell would have to be a 6. So in fact, this cell is always a 6 or a 7. And we've actually repeated exactly the same pattern that we had over in green over here. We've repeated it up here. These are from 5, 6, 7. And so because I need an even number, one of them has to be a 6. And so we can strike out those 6s from those two cells. And then we can examine what's going on in this column. Here's one thing that's going on in this column. I've pencil marked a lot of cells, and I've only pencil marked a 4 here. Well, that can't be a 4. So this has to be a 4, just for the column. There's nowhere else. How many 4s do I have? I now have, 4 is placed here, just by Sudoku, because I've got 4 4s looking into the box. So that's a 4. So this is a 2 or an 8, except it's not a 2 by the row, so it's an 8. So this is a 7 or a 9. What's going on in the rest of this column, actually? We've got 1, 2, 3, 4, 5. We need a 6. We need a 7 and a 9. Okay, so these are from 6, 7, 9. I don't think I immediately get to rule out any of those, unfortunately. But hey, it's good to know. Let's see. Where else should we look? I probably should look at this cell also, maybe, possibly. No, I should look at 8. Where does 8 go in this box? That's a good place. 8 and 8, look into this, placing an 8 here. Oops, placing an 8 there. Which means this isn't a 6 anymore, because 6 and 8 are not adjacent. How am I doing on 8s? I seem to have 9 8s, which is sort of the worst possible answer. I was hoping I would get to place an extra 8, but I did not get to place an extra 8. Let's see. This 5 is looking up here, saying that's not a 5, while we are penciling these things in. Let's see. Oh, did you think I was still on the previous puzzle? It's not quite going that. It's not going that slowly. I'm on the second puzzle already. I mean, I feel like 15 minutes for a gas puzzle with heavy amounts of explanation isn't too bad. Because I think we're almost done this one. There's a 3-5 pair looking up here, so that's not a 5. Well, you know, probably paying attention to work is a profitable thing to do, even if Sudoku is more fun than work. Let's fill in these digits. So we need a 1, we've got a 2, 3, 4, 5, we need a 6, 7, 8, and 9. Yeah, but this one has these this cute little plus theme, so I wouldn't quite say this is quite the same puzzle. These aren't 1. This can't be a 9 because it would make this an 8. Are we going to get exactly the same pattern again? We're going to get exactly the same pattern again. This digit is a 6 or a 7, meaning that this digit is a 5, 6, or 7. And so I can do the same trick. Again, one of these has to be a 6. So this digit's not a 6 and that digit's not a 6. So yet more magic. Let's see. Let's look at 1s. 1 is a smart digit to look at, because I've not yet examined 1s. But there's going to be a lot of 1 placeage, I suspect, because 1 now, if I look in box 9, 1 goes here. Let's hope for more 1 placeage. I know one of these two is a 1. That doesn't quite tell me anything. Yeah, okay. So I know one of these two is a 1, just by Sudoku. Those aren't 1. That's not 1. These aren't 1. So one of these two is a 1. And so now I ask, where does the 1 go in box 6? And now the 1 in box 6. Now, because the 1 in row 5 is over here, this has to be the 1 that's in box 6. That's not a 1. So now this is the 1 in box 3. So now I need a 1 in box 2, and the 1 in box 2 now has to go here. And now do I have all the 1s? Not quite, almost. Very nearly almost. I know that's not a 1 anymore. And that not being a 1 anymore is huge, because now there's a 7-9 pair down here. And so now that there's a 7-9 pair in this row, that tells me this digit can't be a 7. It's a 6. And this digit can't be a 7. It's a 5. And that's going to give me my 3 and my 5. And so that is going to percolate, I believe, maybe, possibly, in some fashion. Maybe not. Maybe it will do absolutely nothing. That's also possible. Well, I know this isn't a 6. Let's fill that in. This is a 1, 7, or a 9. Sure. Oh, same in row 1. Beautiful. Okay, yeah, same in row 1. We've got a 7-9 pair here. And so we get this 6, meaning this is a 5 now, because it can't be a 6 or a 7, so it's a 5. That is cute. So this isn't a 6. So now this has to be the other 7 or 9 for this column, because the column needs 2 7 or 9s. That's the only place the other one can go. Let's see. Look back over here and look at this column. And so chat is suggesting a very wise observation, which is that in this column, I have not pencil marked a 3 anywhere. And so this has to be the 3. So that's a 1. So we get that. Let's see. Oh, this 5 gives me a 3 and a 5. That's something else I should probably have noticed. So this 5 now comes over here, means that's not a 5. This is a 6, 7. That's going to do a lot, because that's going to give me a 9 here, which is going to give me a 7 here. These two aren't 9 anymore. That one's not 9 anymore. It's also not 7, owing to the 6, 7 pair, so that's actually a 5. So I've got a 6, 7, 9 triple in row 3, which means that this digit is given. So this digit has to be a 3. It's the only digit left in the row. So this is a 6, 7, or 9 as well. I don't know that I really want to pencil mark that, but here I go. I'm pencil marking it anyway. Let's see. This 1 looks down here and gives me a 7 and a 1. And the 7 down there gives me a 9 and a 7. 7 gives me a 9. That gives me a 7 here. This isn't a 9 anymore. Let's see. Let's squint carefully. So I need a 9 in one of these two cells, which is, I guess, not surprising, because I know that these are a 6, 7, or 9 to finish off the box. This is a 6, 7, or 9 to finish off the column. What digit am I missing from this? It's not a 6, 7, or 9. I'm missing a 3. Yeah, one of these two is a 3, but I don't think I know which one yet. That's disappointing. I'm being encouraged to look at 5 doku. Ah, yes, 5 doku. 5 doku is correct. This 5 looks here and makes that a 3, which is going to resolve everything, I presume, because that's a 3, and so now that's a 6, and that's a 3. That's not a 6 anymore, so now this is the 6. This 6 looks over and makes that a 7 and that a 6. Makes that a 9. Makes that a 6. That's a 7. So that 7 looks over and makes that a 9. So this isn't a 9. That's not a 9. What are these two digits? We've got 1, 2, 3, 4. We need a 5, which needs to go there. And we've got 6, 7, 8, and we need a 9, which now goes there. This column now is done. We've got 1, 2, 3, 4, 5, and we need a 6. This column is done. We've got 1, 2, 3, 4, 5, 6, 7, 8. We need a 9. So that's a 9. This 7 looks over and makes that a 6, and that a 7, and that a 6. This row needs a 9 still. So that's a 3. And that's a 7, and that's a 9. This digit is now not a 6 or a 9, so it's a 7. And we finish the puzzle. Very nice puzzle. I liked the little plus theming. Alrighty, so let's do one more Kropki gas puzzle, and then we'll do Kuraban's Kropki puzzle, and then we'll do the voted on Derektionary puzzle. So Derektionary is on deck after the Kropki stuff. All right, so here's our next Kropki journey. So if you have been paying attention to how often this pattern has been helpful, it's been a lot. Oh, there's one more even. These are all our digits where I know they're 1, 2, 4, 8. And I know the center cells of all of them are 2 or 4. So they're not 1 or 8. This dot has to be 3, 6. 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 And all of these are 3, 6 because they're a black dot that sees 3 of 1, 2, 4, and 8. And so, again, by our little diagram, the only way a black dot that sees 3 of 1, 2, 4, and 8 can possibly work is for it to be 3, 6. So we've got lots of stuff going on here. Now what should we do with our lives? So this column I need to fill in these white dots, and I need to do that very carefully, because remember, every one of these yellow things has both a 2 and a 4 on it. And so there is no 2 or 4 here. So what digits could possibly be in this string? Well, naively a 1 could be, but there's no 1 in these strings, because if there's a 1, there'd need to be a 2. That's not going to work. So there's no 1. There's no 2. There's no 3 in here. There's no 4, because there's a 4 up here. There's no 5, because actually 5 isn't connected to 4 or to 6. There's no 6, because there's a 6 in the column. So in fact, actually, these are just immediately a 7, 8, 9 triple. That's the only possible string of 3 digits. And now when I see this pair, I can resolve a whole bunch of stuff. Because the only of 7, 8, 9 that's adjacent to a 3 or a 6 is a 7, and so that's a 6, and that's a 3. It's an 8 and a 9. So the 3 now is only connected to 2 and 4, except I know that these aren't 8 anymore. So once I see that, then the 1, 2, 4 triple here, what goes in the middle of a 1, 2, 4 triple of black dots? Well, the digit that goes in the middle of a 1, 2, 4 triple of black dots is 2. Sorry, is 2. There we go. So this is a 1, 4 pair. 3 is not next to 1, so that's a 4. Wow, that was bad. So that's a 4. Take 3, and that's a 1. And this digit we now know, 1, 2, 3, 4. This is a 5. And now let's look sudokologically at the rest of what's going on in the universe. Because that 4 now bounces over here and tells me that that's a 2. So this is now a 1 or a 4, but it's not a 1, so it's a 4. Therefore, that's a 1, because 4, 2 has to then chain on to 1. 4 isn't next to 6. 4 is next to 3, so that's a 6. That 3 now looks over here and gives me a 6 and a 3. Let's see. I know this isn't a 4 or an 8 or a 2. And so not being a 4, 8, or 2 is very helpful. It just makes this a 1 immediately. So that's a 1, 2, and 4. Okay. What about this 6? What's going here? Well, it's not a 5, because there's a 5 in the row already. So that means this is a 7. And then once I have gone from 6 to 7, then the rest is forced. So that's an 8, 9. That's a 5. Now here, now there's a 5 in the row, so this 6 can't connect to a 5. It's got to go 7, 8, 9. And that's a 5. So things are happening. We like it when things are happening. This 6 looks up and makes that a 3 and a 6. These are not 8. Now, here's an instance where I can actually show that this can't be 5 for a different reason. I've got this sort of Z swish of white dots, which means as soon as I pick what this value is, it's going to force all of them. So this is a 5 or a 7. But if it were a 5, I have to think one step ahead. If this is a 5, now this is a 4. But that's a problem, because this is a 1, 2, 4 triple. So that doesn't work. So actually, this is a common thing, and so this is very, very equivalent or very similar to renban logic, which I assure you there will be a renban day at a later date. Those of you who know me will not be surprised. This can't be a 5 because it would break this dot. So in fact, this is a 7, 8, and 9. So once we've got that, well, we now know that these are, so we now know that that's a 5. Let's see. So that is not an 8. That's not an 8. So now this is a 1, 2, 4 triple. And so we can do the same sort of trick about thinking about what's going to happen. If this is a 3, then this would have to be a 2 or a 4. Except I've got 1, 2, 4 in the box already. So this can't be a 3. In fact, this is a 6 and a 3. And now we can do the same trick. Actually, we can do it even easier. There's already a 5 in the row, so this can't be a 5. So it has to be a 7, 8, and 9. And that's a 5 to finish off the box. It is a 2 that goes in the middle of a 1, 2, 4. Similarly, over here, I should have said this a long time ago. It is a 2 that goes in the middle of 1, 2, 4. So none of those are 2. And so let's look at more Sudoku. So there's a 5 missing in this column. So that's got to be the 5. This I know isn't a 1. Now, I can never actually put a 3 on this white dot. Because remember, this is going to be a little bit different. But remember, this trio, it always has a 2 and a 4 on it. And so because it always has a 2 and a 4 on it, I can never put a 3 on a white dot in this box. So this has to be a 6. And so now that's a 3. And so that's a 7, 8, 9. And so these are not 8, so that's not 8. So that's a 1. And so then now this is a 2 and a 4. Chad is pointing out that I actually know how this works out, because that's a 4 and a 1. I should pay attention. That's a 1 and a 4. Actually, exactly the same pattern was over there. So now I should look at these cells over here, probably. Actually, let's just fill in. Let's fill in these. I want to start up there. Let's start up here. So we're missing a 2, a 3, and a 4 in the row. So this digit is not a 3 or a 4, so this digit's a 2. So these aren't 2. Those are a 3, 4 pair. Here I'm missing a 1, 2, 3, 4, a 5, a 6 is what I'm missing. So this isn't a 6. That's not a 1. That's not a 5. Useless, all of you. This is a 1, 2, 3, 4, 5, 6. This is a 7, 8, 9. So that one's a 7. These aren't 7. All good. Let's see. Okay, how about down here? We've got 1, 2. We need a 3. We've got a 4, 5. We need a 6 and a 7. These are 3, 6, 7. So that one's the 3. These aren't 3. That might be useful in just a second. This one is, we've got a 1 we need. We've got 2, 3, 4. We need a 5. We've got 6, 7. We need an 8. So this one's an 8. These aren't 8. They're 1 or 5. This one is, these are 2, 4, and 9. That one's not a 2. That one's not a 4 or 9. So that one is a 2. So that one's not a 2. Okay. So let's now try and use this to press some Sudoku over into this box. Let's see. So I've got 8 is pressed into one of these two cells. That seems useful. Not super useful, admittedly. I'm going to be doing these tutorial days either, I think, weekly or streamly, depending on how popular they are. But at least once a week is the plan. Because I think these will be very useful to point back to point people back to. 2 in this box goes here. Have no real choices about that. Let's see. What about 3s? 3 in this box goes none of these places. Not there. Sadly, I don't know if... I know one of these two is a 3, but I don't know which one. I mean, we're going to be doing this for, an hour and a half, and then we're going to be doing our usual range of difficulties of puzzles. So don't worry, if you really crave very difficult puzzles, there will be plenty of difficult puzzles today. Let's see. We need a 1. We've got 2, 3. We need a 4, 5. We've got 6, 7, 8. We need a 9. Okay, let's just write this in. So this is not 4. This is not 1. Just to think about that. This column, let's fill in this column. So this column, we need a 1. We've got a 2. We need a 3, 4. We've got a 5. We need a 6, and we've got a 7, 8, 9. Okay, maybe this cell will do it. That's not a 3 or a 4. So that gives us a 1, 6 pair in the column. So this isn't 1 or 6. It is 3 or 4. I don't know which one yet, though. My ability to fill every cell except the useful ones is astonishing. I'm glad I can impress. I do feel like I'm getting very unlucky with this one, but maybe I'm just not being sufficiently observant. But let's see. 7 in box 7. Okay. Yes. 7 in box 7 seems very helpful because 7 in box 7 is here. And so 7 in box 7 means that these digits are from 6, 7, 8. And there's not a 6 in them. So these digits are 7, 8. And that's going to do everything. Let's pencil mark all the clues except the ones... Well, it didn't look like these were going to be useful. I actually don't think pencil marking these would have been useful. I really needed to just look and find that 7 was being forced here, which I should have looked at because 7 doesn't go in a black dot at all, and that would have given it to me. Anyway, this is now all going to unravel very quickly because that 8 is going to give me a 7 here, an 8 here. That 7 is going to give me a 6 here and a 7 here. Now this black dot can't be 1, 2, 4, or 8, so it's got to be 3, 6, and we know the order. So that's a 1 and a 5 and a 1. The 3 gives me a 4 here. That 4 gives me a 3 there. The 1 gives me a 6. That's a 4. This is not 1. This is not 4. This is a 5, 9 pair. So that makes that a 4 and that a 9 over there. Let's see. This 6 gives me a 5 and a 1. The 5 gives me a 9 and a 5. The 9 gives me an 8 and a 9. And then we are done this puzzle. Alrighty. Gas puzzles are fun. I really enjoy the gas puzzles, by the way. If you don't do the gas puzzles, by the way, I really recommend that you give them a try. They're very snappy, and they have this sort of like video gamey feel to them, where they're not really trying to do something like super fancy. They're really trying to sort of get you into this flow state where just the deductions just sort of topple one after the other like dominoes, and it's so satisfying. All right. So my goal for all of these is to pull up a 2 or 3 star puzzle at the end. And so this is a 3-star kuraban puzzle. So we're going to look at this. And so this is going to be a little bit harder than the gas puzzles, probably. By the way, to all of you in chat, there is a vast shortage of 2 or 3 star puzzles that only use one constraint by people who I know. So if you are interested in making a puzzle for stream that could be used in one of these tutorials, I really recommend try and make a 2 or 3 star puzzle that uses only one constraint. Because if you do that, then I will very likely do it. So post it on LMD, make sure it gets rated 2 or 3 stars, preferably 2 stars, but 2 or 3 stars, only one constraint, and I will use it for a future tutorial series on whatever the constraint is. So anyway, so if you want to both get your puzzle featured and decide what constraint I do a tutorial series about, that is a great way to do it. I did my best digging to find them, but I did not find a lot. All right. So here's an advanced trick right off the bat. So here's a trick we've not seen in the gas puzzles. I mean, maybe it was there and I just didn't see it, but this is a trick you'll see in sort of fancier Kropki puzzles. Again, you can look at the little sheet. There are 6 yellow cells here on black dots. And there are only 6 digits that I can place on black dots. And so what that means is these digits have to be the others. These are 5, 7, 9. And so very often in Kropki puzzles, you'll see either a row, a column, or a box, or maybe more, where there are a total of 6 digits that appear on black dots. And whenever that happens, you know that everything else is a 5, 7, or 9. So I'm going to just highlight everything that's on a black dot and just scan to see if that happens anywhere else in this puzzle. I do, by our earlier argument, know that that's a 2 or a 4, and that there's a 2 or a 4 elsewhere here. Okay. We have here, we have some interesting stuff going on here, actually. So So here's a very interesting arrangement of stuff. Set a fun 2-star renban puzzle, I'd be delighted. So here, these are both odd. So by the magic of the white diagram that I sort of emphasized about the sort of parity coloring business, these two digits are odd, so both of these are even. So what are they? Well, they can't be 3, 6, because 3 and 6, spoiler, not both even. So they're either 2, 4 or 4, 8. But actually, and this is another trick that shows up a lot, these are not 2, 4. And the reason why these aren't 2, 4 is that I need to make 2 more black dots in this box. How am I going to do that if I make this 2, 4? Well, if I make this 2, 4, I'm going to need to make one of these black dots 1, 8. That's going to go very badly. And so actually, because of parity, these need to be 4 and 8. And so if these are 4 and 8, that's going to give me a whole lot of stuff. So one thing that it's going to give me is this. This can't be a 4, because if this was a 4, these would be double 5. So this is in fact an 8. So that's a 4. These are 7, 9. And this is a 5. Now, as was pointed out in chat, this was not the only place where that black dot trick that we opened with started, because in column 2, we also get that trick. In column 2, there are 6 yellow cells. There are 6 cells that are on black dots. Those are all from 1, 2, 4, 8, 3, 6. So these cells have to be 5, 7, 9. And therefore, these cells have to be 4, 6, or 8. And this one I know is not an 8. Fantastic. Okay. I probably also know what this digit is if I really squint. Because we have a 4 connecting to a 5 here, so this has to be the 6. So that's the 3. These are a 1, 2 pair. Looking that direction. Aha! This 4, 8 looks at this black dot. So remember, this string of 3 black dots always needs a 4 on it. That 4 can only go here. And now I can't use an 8 here. Because there's an 8 in the column. So I can't go 4, 8. I mean, there's lots of reasons I can't go 4, 8. I have to go 4, 2, 1. Like that. And so we get more goodies to start with. Okay, there is a 4 up here somewhere, I am noticing. I'm just scanning to see if there's any Sudoku stuff that I'm capable of noticing. I don't see it yet. Good point, good point. Yeah, Kuraban, no bet sell until we finish the intro to Kropki, which will be after this. But I'm trying to make the sort of like the intro to Kropki bit snippable so that someone can come back and watch it later. And so I'm trying to make it as condensed and information dense as possible. So yeah, this 2-4 looking at this is also huge. Again, sort of, I keep saying this. Everything comes down to this picture, which of course, like you will visualize this picture very quickly. But the lack of ability to put a 2 or a 4 here actually rules out 1 and 8 as well. So this has to be a 3 or a 6. Sorry, this has to be a 3 and a 6. To be more clear. So this digit's not a 6. This is a 4 or an 8. So that's pretty cool. So now this white dot suddenly is interesting. Because this white dot can't have a 1 on it. Even though there's no 1 marked in the row, this white dot can't have a 1 on it because then it would have a 2, and that's not going to work. It can't have a 2, it can't have a 3, it can't have a 4, it can't have a 5 on it either, because if it had a 5 on it, it would need a 4 or a 6, both of which are gone. Can't have a 6. So this digit's actually from 7, 8, 9, and needs to have an 8. Anytime you have a bunch of digits in any puzzle looking at a white dot, you should take a minute to think if that white dot is actually way more restricted than it looks. And so this is an instance where that's true. The other way you could think about this, by the way, is, again, this white dot needs to have an even digit on it, but 2, 4, and 6 are gone, so the even digit has to be an 8. Whichever way works for you is a good thing to do. Hey, David, thank you for the $8 donation for Tutorial Day. Thank you. I'm hoping people like this tradition. I'm hoping that this becomes something that is popular and helps get new people involved, as well as hopefully being interesting for the usuals. All right, so we've got that's from 1, 2, 4, 8. Let's see. Okay. This dot. This dot sees a 6, so it's not 3, 6. So it's from 1, 2, 4, 8. But it also sees a 4. So it also doesn't have 4 or 8 on it. And so this has to be a 1, 2. So that is neat. Hey, see you again in a bit, Tony. Alrighty, so here's another interesting observation. I have a 4, 6, 8 triple in column 3. I'm not sure if this is what Naverio wanted or not. But this digit sees 4, 6, 8 in the column, and it sees 2 in the box. So this sees every even digit. So this digit is odd. If this digit is odd, what is it? Well, it's not a 1. It's not a 5, 7, or 9. So in fact, actually, this is a very weird naked single. This is a 3, meaning that's a 6. So that's a 3, and that's a 6. That's a 4, and that's a 5. Just because of that observation. And so now that's an 8. That's not a 5, of course. That's not a 5. In fact, this is a 6. 6 only goes next to 7. 7 comes down here and puts a 9 here. So we get lots of very cool stuff. So this dot now needs to have a 2 on it. So this is from 1 to 4, and it always has a 2. Because it doesn't have an 8 or a 3, 6. This cell, by the way, is not 4. This cell also isn't a 1, by the way, because if this cell was a 1, that would force that cell to be a 2 and that cell to be a 2. So this cell has to be a 2, actually. So now this digit's forced to be a 3, because it can't be a 1. This digit is a 1 or a 4. I don't know which yet. This digit's not a whole lot of things. So first of all, there's a 6 in this box. So this is not a 3, 6. It's a 1, 2, 4, 8 flavor. But this cell, which is from 1, 2, 4, 8, is not 2, 4, or 8. So it's a 1. And as soon as that's a 1, that makes that a 2, which makes that a 1 and that a 2. That 1 comes down here and makes that a 4. So now this, again, this is not 3, 6, because there's a 6 in the box, and it's not 1, 2. So this has to be 4, 8 in some order. And I know the order, actually. So that's an 8 and a 4. And so I get lots of cool stuff. That's not a 4 now. That not being a 4 actually forces a 4 onto this dot, which means that this dot is from 2, 4, 8. That one's not a 2. We don't immediately, I think, get that. Let's fill in the cells that won't matter, just based on current experience. 3, 4, 5, 6, 7, 8, 9. Okay, so this is not a 3 for the record. It's a 5 or a 9. These digits are 7, 8, 9. That one's not 8. It is 7 or 9. In fact, I know, and yeah, everything that's left down here, no, it's not a 5, 7, or 9. It is a, let's see, what's left in this box? We need a 1. We've got a 2, 3, 4. We need a 5. We've got a 6. We need a 7. Okay. 5, 7. Yeah, maybe I don't know anything about that. Which is very sad. Okay, let's look at digits. Looking at digits is often a good idea if we've got a lot of anything. So we've got some 4s, putting 4 over in one of these cells. Let's see, we've got, oh! I actually pencil marked it in a way that would have let me see it, and then I still didn't see it. This 8 looked left, so that's an 8. So now these 3 cells are known. These 3 cells are from 1 to, we've got 3, 4, 5, 6, and then we've got 7, 8, 9. So these are from 1 to 6. And that's great because of this white dot. So this can't be a 1, because then that would put a 2 there, and it can't be a 2. So this is 2 or a 6. If this is a 2, then this is a 3. If this is a 6, then this is a 7. I can go ahead and fill in. Let's see. This is not a 1. That's not a 1. I am being told correctly. So that's a 1, which is cool. Okay, so now where does 1 go in box 9? 1 doesn't go on this white dot, so the 1 goes there. So that's not a 1. So now that's a 1. Continuing up here. So one of these two is a 1. I would love to say that this can't be a 1, but I actually don't see a reason why it can't be, right off the top of my head at least. Let's see, what about 1 in this box? Yes, 1 in this box. This is a good trick to come up to. 1 in this box is in one of these cells. But I actually can't put 1 on this dot, because if I put 1 on this dot, I have to put 2 on it, which at first looks okay, until you squint and realize that that would put a 1, 2 triple in the column. And I can't make 3 different cells from 1 and 2. So actually, 1 is ruled off of this white dot as soon as this cell is pencil marked 1, 2. So no 1 there, no 1 there, no 1 there, no 1 on there. This is the 1. So that's the 1, and that's a 2. So that was cool. If I look at where 2 is going to go in this box, oh, I know where 2 is going in one of those. Just never mind. Don't listen to me. This cell's not a 2 now because there's a 2 looking at it. So this is a 4, 8. So where is 2? Where is 2 in this box? 2 in this box is on this dot, right? Actually, sorry, 2 in this box is just placed. 2 in this box is here. It has no choices. So this is a 3. That's a 1 and a 2. 1, 2, 3, 4. Okay. 9 in this box I know is here in one of these 2 cells. I know 9 is in one of these 2 cells because there's an 8 already pencil marked over here, so I can't put a 9 on here because it would be stranded. I can't put it with an 8. I can't put a second 8 in the box. The reason why I marked that is because these 9s look at this cell, making that cell a 7 and that cell a 9. That 9 now looks over there, makes that a 7, makes that a 5 and a 7. That 7 now looks up and makes that a 9 and a 5. So these aren't 5. That 3 looks left, makes that a 9 and a 3. So now, so these digits can only come from 5, 6, 7. Because again, 2, 4, and 8 are going in the box, so I need an even digit. So there's a 6 on this dot somewhere. That is 3 in the corner. Yeah, this is a delightful puzzle. This is exactly what I'm looking for when I say I'm looking for 2-ish star puzzles that sort of highlight a mechanic while being sort of like more advanced than a gas puzzle, but not so advanced as to become inscrutable. This column I can fill in. It's got 1, 2, 3, 4. I need a 5, 6. Oh, well, never mind. Let's just do it that way. Where is 6 in this column? Well, I've got a 6 up here already. So So I can't put 6 in either of these two cells. So the only place in the column that 6 goes is there, which immediately makes that a 7. This can't be a 9, so that is. Box needs a 5, so that's it. This is a 4 or 8. We have verified what the rules say, that not all dots are shown. So we've got 3 digits here. We need a 3, 4, 5, need a 6, and a 7, and they've got an 8 or a 9. I don't actually know what mechanic is next week yet. It may depend on what I find for this puzzle, for the medium puzzle afterwards. Let's see. This can't be a 3 because this cell can't be a 2 or a 4. Let's see. If this were a 6, this would be a 7. If this were a 7, this would be an 8. So there's always a 7 on here, but I don't really feel like chasing that yet. Let's fill in these 3 digits, and these 2 digits, maybe more importantly. 1, 2, 3, 4, 5. We need a 6 and an 8, and we know the order. That's the 6, that's the 8. What about these 3 digits? These 3 digits are 3, 4, 5, 6, 7, 8, 9. Yeah, so the usual 5, 7, 9 are the cursed digits that show up in these puzzles. Okay. I am noticing now, though, that this 7 actually resolved this bit, and I didn't notice. So this is now an 8-9 pair that's looking at this digit. So this digit's a 5. So this digit's not a 5. So we've got all of that going on. This 9 looks right, so that's a 7 and a 9. Let's fill in these, because these seem very likely to be useful. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I need to find 2 digits out of 4, 5, and 9 that are consecutive. And so hopefully it then makes sense that I cannot possibly put a 9 on this dot. So that's where the 9 goes in the row, making that an 8 and that a 9. So these have got to be from 3, 7, 8. Yes, where does 8 go in this box now? That 8 looks up and rules 8 out of everywhere except here. So that's an 8 and a 7. These aren't 7. They are a 3, 6 pair. Even more not given dots. This is a 3 or a 7 to finish the box. That 8 looks up and makes that a 4, an 8, and a 4. That 4 looks down and makes that a 5 and a 4. Let's go ahead and fill in these rows, because now I'm particularly interested in column 7. 2, 3, 4. Yeah, then we've got 5, 6, 7, 8, 9. This is from 2, 3, 4. It's not 4. That one's not 4 either, so that is 4. These are, let's see, we've got 1, 2, 3, 4, 5, 6, 7, and 8, 9. So this one's not a 7. This is a 5 or a 6. Yeah, this is the one that I knew had a 7 on it, so that didn't help. What about these? 1, 2, 3, 4, 5, 6, 7, 8, 9. That one's not an 8, and that one's not an 8, so that one is an 8. That one is not a 9, so it's a 5 and a 9. The 5 looks down and says that's not a 5. I must be misscanning something in this column. I am misscanning something in this column. That 5 looks there and sees that that's a 6 and a 2 and a 6 and a 7 and a 3 and a 6 and a 3. 6 looks down and sees that that's a 7, so that's a 5. That 3 looks down and says that's a 2, and that's a 3. Great puzzle. So if you're interested in making a like Zeta tutorial series puzzle that highlights one mechanic, you should look at this kuraban puzzle and just try and make something that is this awesome. Now, kuraban, I admit, has a huge head start on everyone else because kuraban has a series of 15 puzzles that highlight exactly one mechanic that are almost all in the 2 to 3 star difficulty. So I will be... I may be choosing kuraban puzzles for a while, although I saw that kuraban I don't think has a renban puzzle yet in that series. So if you want to make a 16th, it's a renban puzzle, that would be delightful. All right. So that is my intro. to Kropki. So I hope you learned something and enjoyed that. I enjoyed the quick puzzles. They're fun to do. I know maybe not quite as interactive for the stream, but I'm hoping that this will really help get some people who are interested in getting into variant Sudoku, help them sort of like get their feet wet, get into the stream a bit, and start to follow some of these things. And I know it's a bit hard to do that when most of the puzzles that we do are sort of a mix of a whole bunch of different things, which I really enjoy those. And yeah, David is right that Cracking the Cryptic just came out with an app that has Kropki and XV. So if you want a whole bunch more Kropki XV puzzles, there you go. You can get the Cracking the Cryptic app. I will say again, I say this all the time, I really wish I could stream the Cracking the Cryptic apps because I think that would be good for everyone involved. But Cracking the Cryptic has chosen that they prefer people not stream their apps, so I won't. But I think the Cracking the Cryptic apps are very good. I can say that, and I promise I'm not sponsored to say that. I think they're good and fun, and so I think if you're trying to get into something, I think they're a good way to sort of get into a new constraint. All right, I'm going to take a real short break, and I'll be right back with, and I've already sort of revealed this. This is the puzzle we're going to be doing when we get back. So if you want to be looking, there are some renban. But there's also some fun ambiguity stuff. So we'll get to it very shortly. Be right back. Alrighty, welcome back. We are back to full nonsense mode now. So if you missed any of the usual Zeta nonsense, don't worry, it's all back. Zach is done taking notes. He is prepared to dance for the first digit that we find in Derektionary's puzzle. So he is waiting in the wings, so to speak. We have officially been given the bet cell of row 8, column 2, which looks to be that cell. Row 8, column 2, place your bets in chat now as to what digit will be in this cell at the end. We already have some contentious betting, some 6s, some 4s. People are feeling it's going to be even. Seems like a lot of people are feeling it's going to be even. So we've got that. We've got Zach already. Let's this. Oh, and Jessica has renewed her membership. Welcome, Jessica. I enjoy your little upgraded windmill, your green name, and all of your other various things. I should mention, by the way, various ways to support us. If you do want to support the stream in whatever fashion, you can always do super chats. That's always an option. But you also have you can become a YouTube member. So the people with the green names, those are the YouTube members. And you can join the Patreon, which is patreon.com/zetamath. There are various benefits. If you become a YouTube member, then you get the Zeta emotes. There's a lovely Zach emote that is just waiting to be spammed when we get our first digit. He's very happy to be represented in a digit, in an emote. And also the voting on what puzzles we do. So I always do the first or the most voted on puzzle out of the list. You get access, so you can just click and vote on all the puzzles you want to see, and then we'll do them. Alrighty, Kuraban, welcome. Thank you, Kuraban. Has become a member now, so Kuraban gets a windmill. Excellent. Alrighty, so let's read the rules to Derektionary's puzzle. Thank you so much, Kuraban. It's great to have new fans. By the way, the titles of the tiers are Fan, Windmill, and Turbine, which is all courtesy of grkles. So grkles magic naming skills named those. All right. So first of all, we have normal Sudoku rules. We have renban. So these purple lines contain a string of consecutive digits in any order. Tristan says that's not true. Maybe I remember the story incorrectly. grkles said windmill, and then Tristan named the others. There we go. Okay, yeah. So grkles came up with windmill. That was the because it was like a giant fan. I recall now. Okay, so these contain a string of consecutive digits, so it could be a 6, an 8, and a 7. The order doesn't matter, they can't repeat, but we need a string of consecutive digits, so something like 6, 7, 8. And then we have an interesting ambiguity rule here, which is that there are two possible ways that cages could work. So one is the normal way. So what's the normal way? The normal way is that this 2-4 here, this 24 would be saying the sum of these digits is 24, so they could be 7, 8, 9, for example. That would be a perfectly acceptable way to fill this out as a killer cage. The thing about killer cages is that, by the way, I realize I'm slightly too big, is that digits can't repeat within a cage. So I could not do 9 and 9 and 6. That is an illegal way to fill in the killer cage, even though sudoku-logically it's allowed. I'm actually surprised that this doesn't immediately yell at me. Do I not have conflict checker? I do have conflict checker on. Usually, oh, it's because Derektionary cleverly made these cosmetic cages. That's why. Derektionary set it up so that it would not yell at me. Okay, but there's another option, which is the, so to speak, look and say option. And so the way you would read that is, instead of reading this as a 25, you would read it as 2 5s. And so that would be saying that inside this cage somewhere are 2 5s. So that somewhere would be there and there, or there and there. This would be, there's 1 7. This would be, there's 2 4s, 1 2, and so on. This is something inspired by the look and say sequence, courtesy of the mathematician John Conway, who was an amazing human being, but who has unfortunately passed away just a couple years ago now. But I was very fortunate to see him give a talk once, and he was amazing. All right. Now, the thing is, which cage is which, we're not told. We have to determine it. But, and so this is the question in all of these puzzles is it an or is it an exclusive or? And in this case, it is an or. So it's perfectly acceptable if this cage has 2 4s and sums to 24. So if this were a 4 and a 4 and a 16, that would be acceptable, at least as far as the look and say rules go. There could be 1 2 in here, and it could sum to 12. That's okay, but at least one of them has to be true. Alrighty. So now we get to stare at this and see what it is that we can do with all of these things. All right, so what is it with the carrot thing? Why the carrots? Why always the carrots? Okay, so let's look at box 1. So here's the thing. I know that box 1 sums to 45. What if this 17 cage sums to 17? Well, what's 45 minus 17? 45 minus 17 is, I'm being told, 28. Now, 28 has an unfortunate property, which is that it is a multiple of 4. And 4-cell renbans actually never sum to a multiple of 4. They always sum to 2 more than a multiple of 4. And so if you want to see why that is, you could write out a sequence of 4 consecutive numbers. And if you write out a sequence of 4 consecutive numbers, I'm going to start at x minus 1, then x plus 1, and then x plus 2. And if you add those together, the plus 1 and minus 1 cancel out, and what you get is 4x plus 2. And 4x plus 2 is 2 more than a multiple of 4. So I know the sum of these is 2 more than a multiple of 4. And because the sum of those is 2 more than a multiple of 4, what that tells me is that this cage can't sum to 17. That would not work. All right, and so what that means is, hey, there's a 7 in this cage somewhere. All right. So there's a 7 in the cage. That tells me that there's no 7 on this renban, and so this renban needs to come from 1, 2, 3, 4, 5, 6. I only have one camera I use, I believe. So one particularity of this is that there's always a 3 and a 4 on this renban. I don't know that that's going to matter even a little bit, but we'll try for now. Let's see. So box 6 also has lots of nonsense going on. So let's do more renban modular arithmetic. So what about 3-cell renbans? 3-cell renbans are always a multiple of 3 in terms of their sum. Again, x minus 1, x plus 1, those add to 3x. So every length 3 renban sums to a multiple of 3. So if this works, so if this 12, if this is a killer cage, so I guess I should mark this somehow. This is a look and say cage, so it's going to get marked in red to say it's not a real killer cage. It's a look and say cage. So if this is a killer cage, then these all sum to a multiple of 3. So this has to be a multiple of 3. And so in that instance, this would be a 3, 6, or 9. Is there a problem with this being a 3, 6, or 9 immediately? I'm not sure. But what I do see is I see something awesome that Carl has spotted. That is gorgeous. That is S-tier setting. Carl has spotted that it is now not possible for this to be a look and say cage. So this is a real killer cage. And the reason why it's not possible for it to be a look and say cage is if it was, it would need to have 2 4s, but that would rule 4 entirely off of this renban. But this renban needs to have a 4. That's gorgeous. Beautiful spot, Carl. Beautiful setting to Derektionary. I should not dox Derektionary by calling him Derek. 24 here is now a real killer cage. And so it needs to be 7, 8, 9. That's the only way that I can make a sum of 24 in 3 different digits. And so now this digit I can go ahead and fill in. That's 6, 7, 8, or 9. Unless it's a 6, this digit is that digit. Interestingly. Okay. So, right. So now there can't be 2 8s in this cage for the same reason. If there were 2 8s in this cage, that would rule 8 out of this cage, but you can't. So this is a real cage. And likewise, there can't be 2 7s in this cage, because that would also rule 7 out of this. So these are both real, which is a bit surprising to me, but it's true. And so 28... So 28. So 28 and 2, there are 2 ways to do. By the way, if you ever want, the CTC app will tell you the ways of doing things if you don't want to think about it. But there's always an 8 and a 9 in here. Oh, and interestingly, okay, so now it's very interesting. I can't put both 8 9s over here, because if I put both 8 9s over here, then I would need to have a renban that had an 8 and a separate renban that had a 9. That's not going to work. But I can't put both 8 9s over here either, because if I put both 8 9s over here, then I've made a 7 8 9 quadruple, and that's not going to work. So actually, exactly one of these 2 cells is an 8 or a 9, and exactly one of these 2 cells is an 8 or a 9. Which is very interesting, and in particular tells me that these are from 1, 2, 3, 4, 5, 6. There are no 8 9s in. There are no 7 8 9s in here. I haven't yet decided what that's going to do for me, but I assume it's going to do something for me, maybe, possibly. Maybe not. I don't know yet. So now this can't have both 8 and 9 in it. In fact, actually, if you look at this column, there's 2 7, 8, 9s in this column already. So this can only have one digit out of 7, 8, 9. So if I follow along, it can't be that, it can't be that, it can't be that. Can't be. Yeah, I just want you to cross out. No, that's not what it... No, can't be that. There we go. Okay. Can't be that either. So we've got these various options. Those 3 that are left. Let's see, people are saying we know what the cage is. I don't know how to say which of those it is yet. Oh, right. Right, I should look at it differently. I should look at it as how many 8s and 9s are there in these 2 columns, rather than looking at it here separately. And the answer is there are 2 8s and 2 9s, but they're already accounted for. So I can't use any 8s or 9s here, so I can't do that or that. Which actually means that I know that this is the 2, 3, 4, 5, 6, 7 option. So let's fill that in. 2, 3, 4, 5, 6, 7. No 1 over here. I know the 7 is over on this side. Sorry, 7 is over on that side. And that means that this isn't a 7. Thank you for pointing that out. I was missing that piece, which was an important piece of the story. Let's see. So this is 2, 3, 4, 5, 6, 7. Okay, so there's no 7 on this renban. So this renban, by the same logic as above, this has to be from 1, 2, 3, 4, 5, 6. There's no digit that's forced to be on it yet, but it's still restricted down to those digits. So the 8 and 9 in this box are over here, for whatever that's worth. Which is very interesting. So this renban can't have a 1 on it or a 2. Because as soon as this renban has a 1 or a 2 on it, it has 2, 3, and 4 on it, and then this doesn't have any options. So this renban is at least larger than that, which means there's a 1 down here. For sure. And now the question is, where does 8 go in box 8? So if 8 goes down here, the puzzle is broken. Because if 8 goes down here, I now have to put a 9 on this renban, and I can't. So 8 definitely goes on the renban. And as soon as 8 definitely goes on the renban, so do 7 and 6. And so there's no 6 here, which means there's also a 6 over here. And so these digits are from 6, 7, 8, 9. Sorry, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. They definitely have a 6, 7, and an 8 in them. And so... right, okay, so good point from Math Pesto. Now 6 isn't on this renban, and so now this renban has a 3 on it, for sure. And so there's no 3 over here. And so there is a 3 over here. I said like that did something, but maybe it doesn't actually do anything. I was excited by it. It was cool. Interestingly, 1 either goes here or 1 goes here. There's only really a few spots for 1. Is there something that goes wrong if this is 1, 2, 3? If this is 1, 2, 3, yeah, I don't see that yet. Let's see, Garion has a point about the 1 in box 6. I'm going to guess that the point about the 1 in box 6 is that I can't have a 1 on either of these. So I did not see Garion's point. Sorry about that, Garion. But if I put a 1 on either of these two length 3 renban, that is going to cause an enormous problem. Because then these are going to be from 1, 2, 3, and in particular, this killer cage digit that I know is at least 4 is now also at most 3, and that's a problem. So one of these cells is a 1, which means that this renban is a 1, 2, 3, 4, 5, 6 renban. Gorgeous. These aren't the 1. And now, it's not possible that this 12 cage is a 12 cage. This 12 cage is a look and say cage. And so, in particular, that's just because 5 plus 6 is not 12. This is an amazingly set puzzle. So there's definitely a 2 inside this cage now. And so there's no 2 over here. So that is cool. And 9, 6, and 7. Yeah, that. Oh, where does 1 go in column 6 is a fascinating question from Carl. I can't put a 1 in a 28 cage. I've outright ruled 1 out of all of these, so in fact, this has to be a 1. Now, actually, where is 2 in column 6? Oh, and that's a digit dance. Sorry, that's a digit dance. Zach has to come out for Carl's 1. Woo-doo! Woo! We get to do the 1 dance. Woo! Woo! Whoop-a-doo! Whoop-a-doo! Doo-ba-doo-ba-doo! Doo-ba-doo! Boop-a-doo! Oops. Boop-a-doo-ba-doo! Boo-doo! Boo! Boo! Thank you, Zach. Much appreciated. Oh. Very nice, Zach. I realize, though, there's a follow-up to this. Where does 2 go in column 6? 2 in column 6, now has to go in this cage. And so 2 is not over here. So these are from 4, 5, 6, 7. And so now I can't put a 5 on this renban. If I put a 5 on this renban, I also put a 4 on it, and this cage now has no fill. So no 5 there. As soon as there's a 5 there, as soon as there's no 5, there's also a 2. And so now I have aligning 2s. There's a 2 in one of these 2 cells. There's a 2 in one of these 3 cells. That's the 2 2s that live in columns 8 and 9. And so there's no 2 in any of those cells. So one of these 2 cells is a 2. And so as soon as one of those 2 cells is a 2, this 12 cage has to be real. Because I can't have 1, 2 in it anymore. Woohoo! So now the 12 cage is real, fascinatingly enough. So the one looking over here doesn't quite do it for me yet. We're getting close. I already have the 2 marked down here. So, sorry, I already have the 3 marked down here. So I should remove 3 as an option from this while I am at it. Let's see. This renban must be interesting, right? It certainly can't have a 1 on it. Can't have a 2 on it either. So the minimum that this renban can have on it is a 3. 3, 4, 5, 6, 7, 8, 9. This seems gratuitous to pencil mark. Oh, no, it's not gratuitous at all. Right. Okay, this is actually huge. There can't be a 1 in here. Because then this would be 1, 2, 3, And that would pair up with this to make a 1, 2, 3, 4 quintuple. That's not going to work. That's too many 1, 2, 3s. Or sorry, too many 1, 2, 3, 4s. So then where is the 1 in row 7? Well, then the 1 in row 7 has to be here. And as soon as the 1 in row 7 is there, that tells me what this is. This is a 1, 2, 3 renban, with the 1 not going there. So that's the 2 or the 3. And so that is very helpful. And so, at least I thought it was going to be very helpful. Okay, can there be a 3 on this renban? If there's a 3 on this renban, that doesn't even work. If there's a 3 on this renban, then this would be from 1, 2, 3, 4, 5. And that would give me a 1, 2, 3, 4, 5 quintuple in the row. That's not going to work. So in fact, I can't put a 3 on this renban either. So I'm going to really, really, really gratuitously pencil mark this and say that this is not a 3. Okay, so now, if I look at this row, these cells form a 4, 5, 6, 7, 8, 9 sextuple, meaning that nothing else in the row is from 4, 5, 6, 7, 8, 9, meaning that this cell isn't 4, 5. So this cell and this cell have the same digit in them. I don't know what that digit is yet, but these two are the same. I don't think I want to mark it yet, but I might someday. I'm annoyed that this cell can be 4. But I think it can be. See, am I supposed to be noticing something very clever about this? Yes, I am. This has been true for a while, but I kept not absorbing it because I don't like thinking about killer cage sums. But Chad is completely right. I know which this is because it doesn't have a 7 in it. There's a 7 here and a 7 here. This has no 7. And so this is a 5, 6, 8, 9 killer cage. Which is not to say that I think that's going to do anything, but it is true that it is a 5, 6, 8, 9 cage, and it's probably going to do something eventually. So the one of these that's an 8 or a 9... Okay, here's another thing I should have done a long, long time ago. It's probably even better, which is to realize that this is a 7, 8, 9 triple, because those are 1, 2, 3, 4, 5, 6. And so if those are 7, 8, 9, then this is from 6, 7, 8, 9 at least. Which is interesting. Oh, yeah. Yeah, people are completely right. This is a 4, 5, 6, 7, 8, 9 sextuple. So that means nothing else in this column can be 4, 5, 6, 7, 8, 9. So that means this isn't 4, 5, 6, and these are from 1, 2, 3, and that one's not a 1. So these are a 1, 2, 3 triple in the column, which is a good spot. It's being pointed out by Carl that the 4 in the sextuple is down here. And so that actually forces that this is a 4, 6, 7 exactly. In particular, these aren't 4. So these are 2, 3, 5 exactly. And now all kinds of things happen. Namely, I can't have any 5s on this line anymore. Which means that this line is 6, 7, 8, 9. These digits are 1 and 4. that 1-4 looks over, says that's not a 4. These digits are 1, 2, 3, 4. They are a 5, 8, and 9. For whatever that is worth. Right. This renban. Okay, now we come back over here and look at this renban, as Mathpesto points out. If this had a 9 on it, it would be 9, 8, 7, and I would have a 6, 7, 8, 9 quintuple. That's not good. If this renban had an 8 in it, then it would be at least 5, 6, 7, 8, 9 would be what would be on it. But I can't have a 5, 6, 7, 8, 9. Sorry, I said that wrong. If this has an 8 on it, then what's the smallest it could have on it? It would be 6. And so I would still, I'd still end up too small. So this can't have an 8 on it. So now this renban has a 5 and a 6 on it. Once this renban definitely has a 5 and a 6 on it, that's not 6. That's not 6. One of these two is 6. And so if one of these two is 6, this isn't 6. Which now makes this cell definitely 6. Yeah, so now this is a quad, although the way I'm thinking about it is that this is either 4, 5, 6 or 5, 6, 7. It's leaving off the ends. It's either leaving off a 4 or a 7, but the 4 or 7 it leaves off is there. So this is an 8, 9 pair. These are a 6, 7 pair. Those being a 6, 7 pair make that a 4 and that a 7. Means none of these are 7, meaning they're 4, 5, 6. I now kind of am sus of this 25 cage, because we now have 2 digits. No, maybe not. Maybe it's still okay. I was thinking that this was going to be too low. Oh, it is too low. It's too low because now this can't have a 7, 8, or 9 in it. And so if I want to have 2... yeah, so this cage now has... the highest digit that can possibly appear in this cage is now a 6. And I cannot make 4 digits, the highest of which is a 6, sum to 25. So this is fake. Which means it has 2 5s in it, which means there's no 5 there. And means that that there's 2 5s in here, so there's no 5s in here. And if there's no 5s in here, there's no 6s in here either. Means this is a 3, means this is a 1, 2, 3, 4. So this is a 5, 6, 7, 8, 9. These aren't the 5. One of these is the 5. I know one of these two is a 5, which means these two aren't 5. Means one of these two is 5. So this cell can't be a... no. Never mind. I was going to say something that was dumb. Wait, no, I think what I'm going to say is true. One of these two is a 5, so this renban doesn't have a 5 on it. If this renban doesn't... oh, it does have a 5 on it if it's there. This is the 5. Ugh, maybe I'm... sorry, maybe I am overthinking this renban and I don't have to think about it yet. It is possible. Okay. My 13 cage is broken. Because my 13 cage needs a 4, 5, or 6. And I have 4, 5, and 6 all ruled out very cleverly. So so this is a look and say cage. So there's a 3 in there somewhere. Which forces a 3 in here somewhere. Not necessarily a thing. 3, 4, 5, 6, 8. Yeah, that's too many. Wow. There's a 2, 3, 5 triple here, so this isn't the 5, which means this is the 5. That's the thing I should have seen forever ago. I know one of these is a 6 because the column needs a 6. So this isn't a 6. This is an 8 or a 9. This is not a 6. It's an 8 or a 9. One of these two is a 6. So that being a 5 means there's no 5 in here. It means one of these is a 5. So where is 9 in this box? 9 no longer fits on this renban. 9 doesn't fit on that renban. So 9 in this box is here, which means that this renban in its totality has to be 7, 8, 9, which means this digit's a 6. This digit's not a 6. Okay, so now, no matter what, this could have a 6 on it, but it can never have a 7, so there's always a 4 in one of these two cells. So those digits aren't 4, and there's a 4 up here somewhere. And so these are from 3, 4, 6. Those are the only options for this this cell right now. Naverio thinks this is a multiplication cage, that it's actually 2 times 6. That is very possible. That would rule 6 out of here. That would resolve a lot. I'm going to go ahead and fill in this row just because the digits that are left are interesting, if I fill them in correctly. This cell's definitely not a 3. These can't be 4 or 5 because the box already has a 4 or 5 up there. Oh, these digits can't be 6 either because there's a 6 down there. Aha, that's huge. So that 3, 4, 5 looks over here and makes that a 1. These aren't 1 or 3, so they're a 2, 6 pair. So they are a 2, 6 pair. There is a 3, 4. These aren't a 3 because of the 3, 4, 5 triple up here. So we have our roping. We have our 7, 8, 9 roped here, which has probably been true for... I guess that was true immediately as soon as I filled in this, but I wasn't really looking for it. So these aren't 1, 2. So these are 1, 2, and 6. This certainly can't be a 1, because 1 doesn't renban anything in here. This can't be a 4, because 4 doesn't renban anything in here. I know one of these two digits is a 3. One of these two digits is a 3, and one of these two digits is a 5. So that means this is a 3, 5 pair. I cannot fit a 4 there. So that is a 4. And so that's a 6. It's not a 6. This isn't a 6 either. Let's see. So none of these are 6. So one of these two is 6, for whatever that's worth. Renban is a relationship that two digits have with each other. That is my my thought. Let's see. I'm supposed to clean up column 7. Sorry, column 6. What am I missing in column 6? I don't see what I'm missing in column 6 yet, but I'm sure it is driving some of chat crazy. Column 4, I have a 5, 7, 8, 9 quadruple, so these are not 5, 7, 8, 9. These are from 1, 2, 3. 4. Yeah, these are just from 1, 2, 3. Those are the only options. And definitely contain a 3, I already know. Let's see. No 2 here. I know this is a 12 cage. This is probably... Okay, the 12 cage is probably interesting, because the 12 cage doesn't have a 2 in it, so I can rule both of those out. Can the 12 cage possibly be 3, 4, 5? No. The 12 cage can't be 3, 4, 5. Oh, I was about to say that there was not, that this couldn't be 1 because of some complicated reason, but actually this is a 2-3 pair, which is going to mean this also can't have a 2 or a 3 in it, which is going to make this a lot easier. So the 12 cage is forced, if I pay close enough attention. Oh, not quite. No, the 12 cage is either 1, 4, 7 or 1, 5, 6. It definitely has a 1 in it, and the 1 doesn't go here. So this is a 1. These aren't 1. One of these is 1. So these are either 4, 7 or 5, 6. Let's see. If they were 5, 6, would that break that? If they're 5, 6, that would force these to be 4, 7. Oh, that's super weird. 4 and 7 are always forced in here, regardless. 4, 7, 5, 6. Ah, yeah. Where's the other 8, 9? Oh, no, the other 8, 9 could go with a 7 over here. That's part of the issue. This isn't a 1, so that's a 1. Let's see. Scanning. Okay, so there's a very good spot about 4s, which is that I know the 4 in box 8 is in one of these cells. I know the 4 in box 2 is in one of these cells. Those are the only 4s I'm allowed to put in columns 4 and 5. And so because those are the only 2 4s I'm allowed to put in columns 4 and 5, I can't put a 4 in either of these spots, which means that that's a 4. So now these are just a 3, 5 pair. I suppose I also could have just asked where is 4 in this column, and it would have also gotten that if I'd have looked at this 2, 3, 5 triple. But you know, whatever. There's multiple ways to slice an egg. Let's see. I mean, it was a very good observation. I just I liked the virtual pair argument. Let's see. So what I can say, the 9 in this box, the 9 can't be on either of these renban because there's no way there's an 8 here. So the 9 in this box is in one of these 2 cells. So that's not a 9. That's not a 9. Not a 9. That's not a 9 either. Let's see. 2, 3, 5. Almost there. 8, 9. Let's see. Row 2, column 5 is not a 7. Ah, right, because the 7 in the box is there. So this can't be a 7. Good spot. It's funny that I know there's a 7 in this cage and have known that for a long time, and I have absolutely no idea what is going on in this cage. So these are 4, 7, or 5, 6. Does that do me any good? Well, it tells me one of these two is a 3. I guess I kind of already knew that. Either there's a 7 here or there's a 7 here. It's not quite doing the work yet. Okay, so this renban, good spot. I think add 11 and Navaria are both pointing this out. This renban needs a 6. Where is the 6 on this renban? Well, neither of these two cells can be 6. So there's a 6 over here. And as soon as there's a 6 over there, that cell can't be 6. And now, this is a 7, 8, 9 triple, because really these two digits are the same digit. And so once this is a 7, 8, 9 triple in this box, these can't be from 7, 8, 9. These are at most 6. And so these digits are from 2, 3, 4, 5, 6. Meaning I can't possibly put a 9 in either of these things, which is, I think, Navario's point. So that's fancy and cool. Now, what's the lowest I could possibly go? Because I need at least to get to 7. 2 can't get to 7. So these can't have 2 in them. 3 can't get to 7 either. 3, 4, 5, 6. Yeah, 3 can't get to 7 either. So these are from 4, 5, 6 only. And so I guess that only tells me there is a 5 on this renban. It doesn't tell me where it is exactly. I mean, I guess I know this digit's not 5. Almost places 5 in the column, except that this digit could be 5, which is kind of funny. So, that 6 points downward. That gives me a 7 and a 6. The 7 looks up and means that's not a 7. So that's an 8, 9 pair, making that a 7. Does that 7 do anything? I don't know if that 7 does anything. Let's see. Oh, there's a 6 pencil marked in box 1, Sam points out. Yeah, one of these two cells is a 6, so this actually can't be the 6. And so that, in fact, is the 6 for sure. Very good spot. So this isn't a 6. Oh, in fact, this is a 6. Because now the 6 in box 3 is placed here. And so as soon as that's a 6, I now need to place a 9. The 9 in this box can only go here. So this isn't a 9. That makes this a 7, 8 pair. Makes that the 9 and that the 8. That 8 makes that the 9 and that the 8. That 8 makes that the 9. This isn't a 9. Where does 9 go with? 9 goes with 7 on the renban. So this is a 4 or a 5. 4 and 5. 4 would go with 5 here. Because 4 can't go with 3. 5 would go with 4 here. So actually, this is always a 4-5 pair. So this is not 4 or 5. So this is always... Oh, and it's not 6 either, because there's a 6 there. So this is a 7. Needs to go with 8, because I need to put an 8 in the box. This needs to be a 4, because I need to make this add to the right number. So that's a 5. These are not 4. Compliments to the chef on this puzzle, by the way. Excellent. 5, 7 makes this an 8. These not 8. These aren't 7 either, actually. So the 7 in this box goes here. The 5 goes here. That's a 4. This is a 6, 9 pair, meaning this is a 2 or a 3. To finish the row. Uh-oh, I broke it. No, I didn't. No, I didn't. Sorry. This renban. I need to look at the renban. Sorry, I was thinking this was a 2-cell renban suddenly. It's not a 2-cell renban. It's a 4-cell renban. But it can't get to 8 anymore. So it's got to be a 7 here. So this is not a 7. So this can't be a 6 anymore. So it's a 9, and that's an 8, and that's a 6, and that's a 2, which only renban's 3, so that's a 5, and that's a 5, and that's a 4. Places 4 in this box. Places... Oh, I was going to say it places 3 in this box, but I don't think that's true. But it does mean this can't be a 3. Oh, this is a 1 and a 6. We've got a 7 and an 8, making that a 9. That 1 looks down, so these aren't a 1. This did not turn out to secretly be a product cage. The 2 actually gets placed over here. As soon as that's the 2, that's the 3, that's the 1. The 2 looks over. That's a 3 and a 2 and a 3 and a 5 and a 3. This pair is a 2, 4, and a 5. So that's the 5, that's the 2. 2 looks down, 1 and 2. Jaleb, earlier Naverio joked that secretly this was a product cage because it ended up being a product of 2 and 6 was 12. I was just referencing that. The 4 is a 1 and a 4 down there. 6 looks down at that, places that 2 and that 6. That 2 looks down, places that 3 and that 2, which places that 3. These aren't 3 anymore. They're 2 and 5. These digits are from 1, 7, 8, 9. Let's see. These aren't 7. These aren't 8. These aren't 9. These aren't 1, making that an 8. So these aren't 8. So that is 8. That 5 looks down and makes that 9 and 5. 9 and 8 look at this, making it a 7. The 7 and 8 look at this, making it a 9, and that an 8. The 3 looks up, makes that a 4 and a 3. That's not a 1 either. In fact, it is a 9 and a 7. Let's see, the 3 looks over, makes that a 2 and a 3. The 2 looks right, makes that a 5 and a 2. Quick scan of the grid to see if we can find anything else. And this is now a 1. Awesome puzzle. That was great fun. Ooh, congratulations, Medi. Medi won by betting 1. Did anyone else bet 1? I feel like 1 is a pretty good bet. I feel like the bet cell ends up being 1 fairly often. Very fun puzzle. I enjoyed that one a lot. The way it bounced around from here to these was very awesome. And then, of course, then it became a renban puzzle, and, well, we all love renban puzzles. Should have bet 1-1. That's true. Betting 1-1 would have been very on theme. Alrighty. I'm going to take just a short break, and then I'll dig up something else out of the bucket. And then we'll be back with more puzzles. So stay tuned. I will see you all shortly. Oops. Be right back. welcome back, everyone. Next up, we have what is called the 8-color theorem by the Cogito. So this is an ambiguity puzzle, kind of like the previous ambiguity puzzle. I'm very into ambiguity puzzles, by the way. That is a favorite of mine. And so just if you've not done ambiguity puzzles before, well, I mean, I guess you just did one. But an ambiguity puzzle is just a puzzle where there's clues where you don't know which type of clue they are. So, in this instance, what do we have going on? So we've got normal Sudoku rules. Digits can't repeat within these killer cages. And then each gray line is exactly one of the following constraints. So it could be a renban, like we talked about. It could contain a series of consecutive digits in any order. Or, good luck on everyone. Wish Naverio good luck on his exams. Is this the final bit of examining for you, Naverio? Could be a German whisper, which would mean that every pair of digits along it would have to differ by at least 5. So, for example, this could be a 7, with this being a 1, and this being an 8, and this being a 3. That would be a perfectly fine way to fill in a German whisper. Could be a lockout line. So lockout lines have end digits that have to be at least 4 apart. So, for example, 3 and 7 are at least 4 apart. For that matter, so are 3 and 8. And then the digits between those two have to be outside the range between 3 and 8. So these, in this instance, could be 1, 2, or 9. That's how lockout lines work. And lastly, we have between lines, which are like the opposite of lockout lines. If these are a between line, the digits on the inside have to be between the digits on the outside. So in this case, they'd have to be 4, 5, 6, 7 is where they would have to be from. Okay, so we've got all of these as options. Hello?
Can you get the microphone slightly closer to you?
I can try. That is slightly closer to me.
Much
better. Okay. Tristan was saying the sound was bad, so I was figuring it out. Okay. So let's have a look at how on earth we're supposed to start this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so all of these cages, which I'm going to go ahead and highlight in yellow just for aesthetics, they all have every digit in them. So every digit from 1 through 9 appears in each of these cages. So that's interesting. There's definitely some potential shenaniganery going on with these. Oh yeah, what's a good bet, Cogito? Row 8, column 8. There we go, that one. Yeah, so people are looking at sort of whether there's any set stuff we can do, which would be something like saying, okay, there are 4 sets of the digits 1 through 9 in these, And so it could do law of leftovers and say take out those are not that. And so this collection of digits would be 2 sets of the digits 1 through 9. It doesn't immediately seem helpful to me, but I believe it will be. Like, I'm looking at something like this 7 rules out 7 from all of these. So I know there's a 7 in one of those, and there's a 7 in one of those. I'm also trying to figure out if there's any shenaniganery with, like, which cells have to be equivalent between the box. Like, is there any cell on this that's particularly restricted about where it shows up? I do not know. Let's see. Sec puts 8 in row 7, column 1 or 9. Can you elaborate on how you're getting that? Let's see. These cages are annoyingly shaped. Okay, so let's go over Jalib's argument here. So Jalib's argument is this is 4 sets of the digits 1 through 9. And so if I remove these 2, this is 2 sets of the digits 1 through 9. And so I need to fit one more 8 into blue, because there's already an N8 in blue. And so where is that 8 going to go? Well, it's not going to go in any of these cells. So there is exactly one 8 in one of these cells, I think is potentially... and so there's exactly one 8 in one of these cells. And so if there's only one 8 in all of the blue cells, how is that going to work? Well, that means that there needs to be an 8 in one of these rows that's not in those cells. Well, the only place that 8 can go is here and here, right? Because these cells are never 8. So one of these 2 cells, I'm going to mark them in green. One of the green cells is 8, which means these blue cells aren't 8, actually. And so one of the blue cells is 8. Who knows, maybe it's the bet cell. But what we get out of that is that one of these 2 is 8. You don't really have to think about this as set if you don't want to. You can just think about, I need to get 4 8s into all of these cells. How is that going to happen? Or, actually, even better, I need to get 2 8s into these 2 cages, and none of these cells can be 8s. So, how am I going to possibly get 2 8s into these cages? Well, the only way I'm ever going to get 2 8s into these cages is by putting 1 in one of these 2 cells, because I can only possibly put 1 8 there. That's probably a much nicer way that doesn't involve thinking about set, which is always a better way to conceptualize things. Okay, we're going to get rid of that, because we can do exactly the same thing with 6s. One of these 2 cells is a 6. So we're going to make those orange. Okay. And then we're not quite going to be as lucky with the other givens, I don't think. Because the other givens... Okay, what about this 2? Let's think about the 2. How are we going to get 2 2s into these cages? Well, none of those can be 2. Right, okay, so the 2... Oh, and those can't be 2 either. Okay, so this is going to work. The 2, one of them goes there, and one of them goes in one of these 2 cells. So this 2, one of these 2 cells is a 2. Okay, so I'm going to make the 8 green and the 6 orange, because now the 2 actually has to go in one of these 2 cells. So I'll make the 2 blue. One of these 2 is a 2. And now the 4 is going to work the same way. The 4 is going to have to go in one of these, and we're going to get a ring is the point. One of these 2 is a 4. Let's use gray. And so now, the key point is that we have this ring shape sort of percolating around these who's a what's it. And so one of these 2 cells is a 6. So what happens if this isn't a 6? Well, now this is a 6. And so now one of these 2 is a 2. Well, this is a 6, so it can't be a 2. So now this is a 2. But one of these 2 is an 8. Therefore, this is an 8. And now one of these 2 is a 4. And so this is a 4. And so what I just proved, actually, is under the sole assumption that this is not a 6, it's a 4. And what that means is, actually, this becomes a 4-6. It can only be 4 or 6. And exactly the same happens all the way around the ring. This can only be 2 or 6. This can only be 2 or 8. This can only be 4 or 8. And one way to think about this that makes this less opaque and doesn't feel as much like I'm using the sorts of words about negative links that you might or might not like hearing, is that I need, in these 4 cells that I have highlighted now, there needs to be a 4, there needs to be a 6, there needs to be an 8, and there needs to be a 2. Well, that means these cells can only be from 2, 4, 6, 8, because I need all of them. And so that lets us convert corner marks into center marks. That's the whole point. And this is called, like, either an X ring or an XY ring or an XYZW ring, depending on exactly who's talking about it. But another consequence of it is that none of these cells can be 8. None of these cells can be 4, etc. around there. Okay. So, now our other givens get more powerful. Because that 7, where does the 7 go in these 2 cages? Well, it's not going in any of these cells, and we now know it's not going in either of these cells. That's how that helped us. So one of the 7s can go into this box, but the other 7 that doesn't go into this box goes in one of these 2 cells. So one of those 2 is a 7. Okay, and so I'll go ahead and give that a color. That can be yellow. And by the same virtue, I need to get 2 5s into all of these cells. None of these can be 5s. These can't be 5s. And so the upshot is that one of these is a 5. So let's make 5 purple. We'll make these purple. One of those is a 5. Okay. So now the question is, can this really be a 7, I guess? Let's start there. So if this is a 7, and this is a 4 or a 6, what could this be? Annoyingly, it could be a whispers line. I'm looking for a pairing here where it's really clear I can't possibly, can't possibly work. But I'm now concerned that it may not be easy to identify the pairing where this does not work. So I'm like, what can go with a 4 or 6? Well, on a renban, digits that are close to them. On a lockout line, I would need to have an 8 or a 9 at the other end. But see, Derektionary would somewhat like to mark these 2 cells, which is a thing I am open to. So if I make this cell red, one of these 2 is red, even though I have no idea what red is, but one of those 2 is red. And if I make this black, then one of these 2 is black, even though I don't know what black is. So Garian's point is, whichever of these is a 5, it can't be a whisper line, and it also can't be a lockout line, because the 5 in these I do believe red could be green. I specifically, these colors are not intended to be distinct, but very good point, SPQ. I think that is something that I would have missed. So 5, if whichever of these is a 5, it's not a whisper line, and it's not a lockout line, because 5 would need to go with a 1 or a 9, and neither of these cells could be 1 or 9. So whichever of these is a 5, it's either a renban or it's a between line. Let's see, 5 and 2 would leave exactly enough room. 5 and 8 would leave exactly enough room. It certainly could not be 5 and 6 as the ends of a between line. So that is interesting. Let's see. Okay, so Garian has an excellent point. Which is that if I go with 5 and 2 doesn't actually work because of the rules. 5 and 2 would force... so if this is 5 and 2, then it's a between line. And then... okay, this is genius. But that doesn't actually work, because then the things that go on it are 3 and 4, which it makes this a 2, 3, 4, 5, which is a renban. That doesn't work. So I actually can't do 5 here with a 2. I could do 5 with a 6 and make this a renban. Down here, 5 with a 2 would have the same problem. 5 with an 8 also has the same problem. 5 with an 8 forces 6 and 7 if it's a between line, which is also a renban. So actually, I think this 5 can't go with this 2, 8 ever. It's never a whisper. It's never a lockout line. And if it's a renban, then it's also a between line. And if it's a between line, then it's also a renban. So the 5 can't go here. The 5 actually goes here, and we have a digit. So this cell is a 5. Okay, and we can bring in Zach to do our fancy 5 dance. Doop-a-doop. Whoop. Lip. 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 Do lip. Thank you, Zach. Very cool. Okay. So now, that being a 5, okay, so I now can de-blacken that cell. Sorry, not de-blacken, de-purplin. Yeah. And now the yellow here means that that's a 7. So it's not red. Because this isn't yellow. This now can't be a 2 for exactly the same reason. It's a 6. So it's orange. And so that's going to resolve the whole ring. So that's going to go 6, 4, 8, 2. I'm not sure we're going to need colors after this, actually. So 6 is orange. This is gray. This is green. And this is not green. Sorry, not green. Let's see, and SPQ asked the markings in column 3. I don't think we're really going to think about this anymore. I don't think that is going to be the thing to look at the moment. We might get back there, but I think it was correct, but I don't think we need to be thinking about it at the moment. Very cool break-in. So what on earth is going on with this 4 and 7? The 4 and 7... In fact, actually, I'm going to get rid of all the coloring because I want to color these lines. This I know is a renban, and renban are purple. I think this is going to need to be a whisper, but let's check. It's not a lockout line. It can't be a between line, because then this would be a 5-6, and it would also be a renban. It can't be a renban, because it would also be a between line. Right, so this is a whisper line. Okay. And as soon as this is a whisper, that is a 9. And this is a 1 or a 2. So we've got that going for us. I know the 7 in this column is in this cage, for whatever that is worth. It's 5 and 6, so these are from 7, 8, 3, 4. Those are my options there. I know there's a 4 down here somewhere. Let's see. Let's see. Sayori says this one can't be a lockout line. Let's see. If this wants to be a lockout line, this would have to be 4, 3. Can't be 4. It'd have to be 3 or 2. With these being... why can't this be, say, 2 with a 1-9 pair? Okay. So one of these cells is a 7 now. Just to look at... let's just do more Sudoku. 4 in this row goes over here. I think between lines are gray and lockout lines are blue, I think is my my standard coloring, but I am open to negotiation. I know there's a 6 over here somewhere. 4 is placeable in box 2. 4 is not in any of those places. So 4 in box 2 is definitely in one of these 3 cells. But it's not in the cage because... Beautiful. Okay, right. Gorgeous. Okay. 4 is not in any of these cells because there's already a 4 in this cage. But 4 is not in any of these cells because there's already a 4 in this cage in this row because it's not there, so it's over there. So 4 is in one of these 2 cells, but it's not that one because there's already a 4 in the row. Very well spotted. So neither of these can be a 4. And if neither of them can be a 4, neither of them can be a 3 either, because this is a renban. So this is a 5, 6, 7, 8 renban. So that's cool. Very well spotted there. This isn't a 7 anymore. One of these 2 is a 4. I don't know which one. Let's see. Can we possibly repeat that anywhere? Like, no, not... Let's see. Jay with a smart point that lockout lines by definition are at least 4 apart. Between lines also have to be at least 4 apart, because if they're 3 apart, then they're also renbans. So, like, if I made this a 5, then that would force this to be 6, 7, which would make it a renban. So, actually, there's a commonality here. Each constraint appears exactly once. I had missed the line of the rules until now, that each constraint appears exactly once. I had somehow imagined that that was not a thing. So, actually, then, following by Jay's point... this has to be a 6, 7, or 9. And this has to be a 2 or 3. If this were a 1... Oh, no, it could be a 1. It can be a 1 if this is a between line. It can't be a 1 if this is a lockout line, I suppose. Yes, I just did not read that part of the rules, so that was not the best of... this cell can't be a 7. Because where is 7 in this row? 7 in this row is not in any of these cells. It's not there, it's not there. 7 in this row is here. And so because 7's over there, 7's not there. I think that is the argument that that SBQ wanted from before. So this is a 6 or a 9. 6 in column 6 does the same. 6 in column 6, right, is not in any of these places. 6 in column 6 is definitely in one of these cells because it's there. And so this can't be a 6, so this is a 9. Which is great, because it means that this is a between line. So it means that this is a lockout line. If this is a lockout line, it can't have a 1 here. These are from 1, 2, 8, 9. Sorry, 1, 2, 9. This is not a 2. So these are between 2 and 9, which is not so super helpful. I'm gonna be honest. But I'm sure it'll be great later. Let's see. If this was a 2, this would be a 1, 9 pair. Do I see a problem with that? Not immediately, for sure. It is a very boring between line, I agree. At least it's not a 1 and a 9. I'm being told this can't be a 2 if I think about 2 correctly. I have to remember this. This is a 1. I can do that. That I understand. Right. Beautiful spot from chat again. Nordy and Jay all over this. If this was a 9, then no matter what I put here, this would be both a lockout line and a whisper line. That's not going to work. So this has to be a 2. So then that has to be a 3. And so that's a 1. That's very smart. So one of these two is a 2. Oh, and it's not that one. Right. 2 in here goes one of these two, except that's in the same cage as that 2. So this is a 2. Is a 2. Let's try again. There we go. Let's see. So there's a 7 in one of these cells. I should pencil mark that these are from 3, 4, 5, 6, 7, 8, since Sam was so generous as to provide me with a between line, so I should use it. This is not an 8. This is not a 5. 2 in upper left cage. The 2 in the upper left cage is over here. Good. Because the 2 can't go there anymore. So now the 2 is going in one of these places, and it's not going there or there, so the 2 is now going here. Very good spot to Sayori. So now this 2 is up here, so now there's a 2 up there somewhere. Let's see, we can chase 5s. So if I chase 5s in this cage, 5 in this cage can only go here. So if I chase 5s now into this cage, it can only go here, which gets us a 5-7 pair. If I now chase 5s into this cage, then now the 5 is going to go in one of these cells. And so now 5 in this box is not in a cage, because the 5 in this cage is over here, the 5 in this cage is over here, so this is the 5. Cute digit. Two in row 3, I'm being asked to think about. Not there. Not there. Not there. Yeah, 2 in row 3 goes here. Insanely good spot to dog there. And that 2 dislodged a 7 pencil mark, so that's a 7. So that's an 8 and a 7. So that's not a 7. That's not an 8 anymore. That's not a 7 anymore. Still a 4 up here somewhere. No. I was going to say something wrong. Let's fill in this row. That's the smart thing to do. 1, 2, 3, 4, 5, 6, 7, 8. 1, 3, and 8 are the things that are left. That one's definitely not a 1. This one's definitely not an 8. It's a 1 or a 3. So one of these two is an 8. They both see that cell. I guess I'll fill in this column so that I can pencil mark that. 1, 2, 3, 4, 5, 6, 7, 8, 9. This cell's not an 8. This cell's not an 8. And this cell's not an 8 either. Because one of these two is an 8 for the row. This cell sees this cell directly. This cell sees this cell through the cage. So this is never an 8. And so that tells me where the 8 is in the column. It's there. I also could have used this given 3, I now see, but whatever. We did it the cool way. I'm not going to feel too bad about doing it the cool way. Let's see. So I should mark up these cells because I know what they are too. This isn't a 5 because there's a 5-7 pair here. But what else is there in this cage? We actually are going to get a quad. So 1 we still need. We've got 2 and 3. We need a 4. We've got 5. We need a 6. We've got a 7 and an 8, and we need a 9. So these are 1, 4, 6, 9. That's not a 1 or a 9. That's not a 4. So that means I know this quad now. It's not a 1 or a 2. It is a 3, not a 4. We need a 5. Not a 6. We need a 7 and an 8. That one's not a 5 or a 7. It is 3 or 8. That one's not 5 or 8. It is 3 or 7. That one's not 7. There we go. Oh, some of chat pointing out that I can use this given 4 to resolve this. That's pretty cool. So that's a 6, that's a 9, that's a 1, and that's a 4. That was a lot out of that observation. It's not a 9. That's not a 9. Let's see. Can I do a similar trick over here? I don't think so, unfortunately. I know one of these two is a 9 now, for whatever that's worth. So now I know what these 3 digits are. Let's fill in what these 3 digits are. So I need a 1, I've got a 2, I've got a 3, I need a 4, I've got a 5, I need a 6, I've got a 7 and an 8, and I need a 9. No, I don't need a 9. These are just 1, 4, 6. So that's not a 1. And this is a pair now, which is going to give me the center digit. These are, let's see, these are 3, 4, 5, 6, 7, 8, 9. These are a 3, 9 pair. Which means that this digit is known. It is a 1. So that was sweet. So these are not 1 or 4. So 1 and 4 do live in here. I don't know if I want to pencil mark that. Yeah, Wednesdays aren't really a good day for work. I don't feel like. I feel like Wednesdays are more of a like watch the stream sort of day. We need a 3. We got a 4 and a 5. We need a 6. We got a 7. We need an 8 and a 9. So let's look at these one by one. I think unfortunately that can be anything. This can't be a 6 at least, because there's a 6 in the cage. Unfortunately, I think this can be a 3, 8, or a 9. This too. That was a very very unfortunate thing. I guess this is also 3, 8, or 9 to finish off the column. One of these is a 1. Ooh, birthday cake. I would eat birthday cake. 9 in column 1. Ah, good spot. Excellent. 9 in column 1 has to go here because there's a 9 looking at it, even though it is an ugly gray 9. It's still a 9, which resolves the 3 and the 9 over there. It means this isn't a 3 anymore. Let's see. annoyingly, I think that can be a 7. Let's see. 1, 2, 3, 4, 5, 6, 7 is what's left over here. These aren't 6 at the very least. That one's not a 4. Let's see. The 5, 6 in column 3 is resolved. Ah, yes. Okay. Oh, I was going to do it in a very complicated way. But this 6 sees the 5, 6. So that's a 5 and a 6 and a 4. And so this is not a 4 or a 6 anymore. It is only a 3 or a 5. These aren't 5s anymore. These cells are a 2, 3, 4, 5, 6, 7, 8. 2, 3, 7, 8. These aren't 7. These aren't 8. These aren't 2. It's almost useful. These are 2, 3, 4, 5, 6, 7, 8. Okay, so these aren't 5 or 6. They're 2, 3. So these aren't 5 or 6. Sorry. So these aren't 2 or 3. These are 5 and 6, and we know the order. So that's a 5. That's a 6. This isn't a 3 anymore. Sorry, it's not a 3 anymore because it's got a 2, 3 pair looking at it. People are pointing out now 6 is forced in this cage because 6 can't go in a box with a 6. And can't go in this box with a 6 either. So this is a 6. That is very clever. So this is not a 6. Let's see. This 5 looks down here and is going to place itself. So that's a 5. This 4, 7 is going to look up and say that that's not a 7. It is a 3 or an 8 only. So that gives us a 2, 3, 8 triple, which means this is a 7. Where's the 9 in row 4? The 9 in row 4 is definitely over here. And so this can't be a 9, it's an 8. So that's a 3. And that's the 9, as it happens, that we were just talking about. So that's a 7. These aren't 3. That one's not 7. These are a 5, 8 pair. These aren't 4, by the way. They're a 1, 6 pair. I can probably figure out that this digit is an 8 if I squint really hard, which makes that a 3, a 2, an 8, a 2, a 3. Let's see. Okay, let's just fill in this triple. So we need a 1, a 3, a 4. I don't think I get any help on, but then these now need to be, well, they need to include a 2, and the 2 has to go, no, never mind. Invisible given. 1, 2, 3, 4, 5, we need a 6, which has to go there. 7, 8, and 9, which has to go there. So there's a 9 in one of these two cells, I can at least say. Let's see. The top row needs a 1. We've got a 2 and a 3. We need a 4. We've got a 5, a 6, a 7, and 8, and we need a 9. So let's mark it. That can't be 4. That can't be 9. Let's see. Okay, let's fill in these as well. 2, 3, we've got 4, 5, 6, 7, 8, and we need a 9. That's not a 9. It is a 2 or a 3, and it's not a 2, so it's a 3. So that's not a 3, and that's not a 3. Those are a 2-9 pair. There's too many digits here. There's a 2 in the box, so that's a 9 and a 1 and a 3 and a 1. That 1 means that's not a 1. That 3 means that's not a 3. That's a 1-4 pair. Right. That 1 means that's not a 1, so it's a 4. And that's a 9 and a 2. That 4 looks down and makes that a 1, means that's not a 1. It's a 3, 4. Let's see, this isn't a 7 anymore, because there's a 7 in the column. Let's see. This row is missing 3, 5, and 7, I believe. Yep, 3, 5, 7. This one's not a 7, it's a 3 or a 5. It's not a 5 either, so it's a 3, making that a 5, and that a 7, and that a 5. Let's see. That 3 looks up and makes that a 4 and a 3. The 4 looks down, makes that a 6 and a 1 and a 6. We need to fill in this box because we have cells that aren't pencil marked, and it is interesting, or it is always a bad idea to have cells that aren't pencil marked in your grid that you're solving. 1, 2, 3, 4, 5, 6, 7, 8. These aren't 1. These aren't 8. These aren't 7. That one's not 1 either because of the row. So actually that places the 1. Giving us a 4, 7 pair. There's a 4 in the column. So that's a 7. And that's an 8. And that's a 5 and an 8. And the 7 looks over and gives us a 4 and a 7. And then scan the grid for mistakes, and it makes the bet cell a 4. So congratulations to anyone who bet 4. It's a really fascinating puzzle. I admit, looking at the rule set, I was not expecting it to be anything like this, but it was quite interesting. I think I used that at the very end, Sam. I think I used that for the digit 9, but I don't think I noticed it until the very end. Oh no, sunk at the river, the worst. Yeah, I don't know why. This puzzle feels very weird. Not in a bad way. It just feels, I guess it's because it's a combination of the, like, ambiguity stuff with some classic Sudoku techniques is like most of the puzzle, and that's sort of an unusual combination, but a very cool puzzle nonetheless. I was hoping that I would get to use that this line wasn't something, but I don't think there was anything it could possibly have been. Maybe it could have been a between line, or sorry, maybe it could have been a whisper if it tried really hard. Yes, very cool puzzle. I enjoyed that one a lot. Alrighty. Let me go ahead and take just a short break, and we'll be back with another puzzle. I don't know what puzzle yet, but I'll find one, and then we'll be back. See you all shortly. Alrighty, welcome back. Hopefully you didn't have to wait for too long, Malcolm, who showed up exactly as we went to break. So, next up, we have this killer Sudoku puzzle by Jody. So we're going to do this. Uh-oh. Sound? Oh. Because I moved the microphone out of the way, thank you. Yes, if I put the microphone pointing completely away from me into another universe, you will not be able to hear me, that turns out. Take two. Welcome back, everyone. Hopefully you didn't have to wait too long, Malcolm, who was showed up exactly as we finished the previous puzzle. Sorry about that, Malcolm. Yes, it is a directional mic. If I point it at the opposite direction, it will not work. Alrighty, so we have a Jovi killer puzzle, which is going to have two very fast digits, so Zach is going to be very ready for this. The only rules in this puzzle are that you're going to need to make the sum of the digits in the squares equal the digit at the top left, and you can't repeat digits in the squares. This probably could have been one of the puzzles for the tutorial series whenever I get to the tutorial on killers, but I did not write down the difficulty, so I did not want to just pick it for that. Anyway, there's a few... Oh, bet cell. Row 5, column 5 looks bet celly. Oh, we have two Malcolms. I can refer to both Malcolms at once. But the other Malcolm came in immediately as I finished the other puzzle. So 30 and 4 has to be 6, 7, 8, 9. 10 and 4 has to be 1, 2, 3, 4. 1, 2, 3, 4. 29 in 4 has to be 1 less than 30. How do I reduce the total by 1? I have to do that by reducing the 6. And so this is 5, 7, 8, 9. And then the 11, I need to increase the total from 10 to 1 more. So I need to replace the 4 with a 5. And so this is 1, 2, 3, 5. And now, handily, we get this little tool here that tells you that. So if you click on one of these, it will say, ha, those are the only ways to make those sums. And it will just tell it to you free of charge. But that gets us 2 digits for free. So let's fill in the 2 digits. So this is not a 1, 2, 3, or 5. So it is a 4. And this is not a 5, 7, 8, or 9. So it is a 6. So we can bring in Zach for the twin digit dance. He has to play both parts, though, because he does not have his penguin friends with him today. Thank you, Zach. Always appreciated. Alrighty, so these are not 4. These are not 6. And we can go ahead and fill in. These are 1, 2, 3, 4. These are 6, 7, 8, 9. And now I'm already suspicious of this combination of digits. I'm not sure I can do anything with it yet, but I'm suspicious. Because that's 3 low digits that I can't put there. So that means the minimum that these 2 cells can sum to is 6. I guess that's not super restrictive. It's going to be, I think. But I don't think it quite gets me there yet. But we can do a little bit more. So particularly if we pull out the magic summy thingy. So this 13 cage always has a 1 in it. That is an easy thing to scan this for. By the way, you can see the sum hovering over the rules. I don't know if it's obvious to you that you can see it there, but you can see this sum cage thing I'm referring to. There's always got to be a 1 in here, which matches up with the 1 in here. This 26 cage does not always need a 9. Neither does that one, sadly. And this one doesn't always need a 1 either. Yeah, that's a good point. Okay, so how many of 1, 2, 3, 4 have to be in the 15 cage? And so I can answer that question. 2, at least 2 of 1, 2, 3, 4 have to be in the 15 cage. Where do those go in column 3? Well, the only place they can go is here. So these digits have to be from 1, 2, 3, 4. How many 1, 2, 3, 4s, here's a different way to ask that same question. How many 1, 2, 3, 4s can I put into this 15 cage? Well, the answer is 2, right? I can't put 3, because if I put a third one, it would have to join these 2, and that would be a problem. So actually, if I'm doing my little arithmetic here, I can tick off any of these that use more than 2 of 1, 2, 3, 4. And that's because there's no other cells in here in this column that can be 1, 2, 3, 4. And of course, the ones that I put here have to go into this column somewhere, and that somewhere has to not be there. So this cage is actually down to only a handful of options, and we get really stupid facts, like that it always has a 5 in it, and always has a 1 in it. So we can utilize that to our advantage if we like. And so if this cage always has a 5 in it, where does the 5 go in column 3? The 5 in column 3 has to go there. So there's no 5 over there. So that means one of those is a 5. Yeah, the 1 and a 5 make a 15 cage. That makes perfect sense. Let's see. Good point to Judith. Judith notes none of these combinations involve a 4. And remember, these 2 cells are the low digits in here. So there's no 4 here. And there is a 1 in here, because the 1 in this cage forces this to be a 1. So, and then it's just a 2 or a 3 that joins this over here. Now, can we do a similar trick? Yes, we can do a similar trick with the 26 cage. So now I want to look at high digits, but in column 7. Where am I putting the high digits from the 26 cage in column 7? Well, the only place the 6, 7, 8, 9s that show up here can go is these 2. So I can't use more than 2 6, 7, 8, 9s. So I can't use 7, 8, 9. I can't use 6, 8, 9. I can't use 6, 7, 9. I can't use 6, 7, 8. So in fact, this has got to be 4, 5, 8, 9 exactly, we have learned. So it turned out I looked in the wrong place. I should have looked over here first. 4, 5, 8, 9 exactly. These are 8, 9 exactly. To make that work. So that's cool. Okay, so can I do anything fancy with a 13 cage? Ah, okay. Very nice. Okay. Ranks has a beautiful spot, which is, where is 6 in column 7? And the gorgeous thing is, the 6 in column 7 can't go here. It can't go any of these places. So that's a 6. That's really hard to see, but very cool. And so once it has a 6 in it, it is exactly 1, 2, 4, 6. So these cells are 1, 2, 4, 6. Very slick spot. These aren't the 6. These aren't the 4, because there's a 4 over there. Gorgeous setting too, of course. But yeah, that was a not easy spot, I feel like. And so once we make that, then we can use Chris's observation that now the 7 is placed in this column. Namely, the 7 has to go there. Okay, these digits are from 1, 2, 3, 6. And the 3 is definitely up here. Sorry, the 3 is definitely up there, so that's not a 3. So this is a 1, 2, 3, 4, 6 quintuple, isn't it? This is a 1, 2, 3, 4, 6 quintuple, which means that these digits are also from 5, 7, 8, 9. This isn't a 7. So these two digits are these two digits. Ah, okay, gorgeous. Okay. So these are 5, 7, 8, 9 quadruple. So are these. So these two digits and these two digits are the same digits. I thought that was going to immediately tell me something about over here, but I realized that it does not, in fact, actually tell me anything immediately. But those are the same digits. So that at least is something. Where's the 6 in row 1? The 6 in row 1 is not over here. So the 6 in row 1 is in one of these cells, but it's also in one of these cells. So this cell has to be a 6, is the upshot of that. And I should have noticed that when I pencil marked, but I didn't. But anyway, it's noticed now. That has to be a 6. So got the 3 there, got that 1, 2. This cage needs both 1 and 2. There's a 1 and 2 up here. Where does it go in this cage? It has to go here, so this isn't a 4. So this is the 4 for the cage. So that's not a 4. This isn't a 1 or a 2. Oops. It is a 3 or a 4. Darn it. Did you not believe that one, Sam? Let me redo it. There's a 1 or a 2 in here, along with a 3, but all I care about is where does the 1, 2 go in box, or in this 13 cage? And it goes there, so this can't actually be a 4. But then once I do that, then it actually forces this to be a 4. Now this is a 1 or a 2. A 1, 2 pair looks at this. And so I get that arrangement. Let's see. So there's no 4 in this 15 cage. So the 4 is either in the 26 cage, or the 4 is down here. I don't know that that's really an exciting conclusion. I don't feel completely gripped by it, if I'm honest. 4 in column 3. Got it. Okay. I should be looking at this, but I should be looking at it from that perspective. 4 in column 3. Now, rather than in box 7, which is where I was looking at it. 4 in column 3 is now part of the 26 cage, which now rules out most of our combinations. So we now actually know there is a 9 in this cage. And now knowing that, it aligns with the 9 that's up here. I typed 7 instead of 4. That's good. I mean, it's not good, but it's good that you told me. So there's a 9 in this 30 cage. There's a 9 in this 26 cage. So there's not a 9 in any of these, because those are the 2 9s that I get to place in column 3 and 4. So none of these cells are 9. Let's see. If this is 4, 6, 7, 9, does that cause a problem? Because that's 6, 7, and 9 are in both of these, and so 6, 7, and 9 would be ruled out of all of those cells. I don't know that that's actually a problem. Immediately. These two are the same digit. I kind of want to mark that. I'm going to. The 26 cage must have a 4. So it can't have 1, 2, or 3. I agree. Ah, got it. Okay. Right. Screaming Ice Cube has the follow-up. When you look at this cage, the thing I want to notice about these possibilities, or the thing I'm supposed to notice about these possibilities, is they no longer include a 1, 2, or 3. And so now I can ask in column 3, where does the third 1, 2, 3 go? And the third 1, 2, 3 has to go there. This can't be a 1, though, for multiple reasons. See. Sam says something about the 3 in column 6, but I don't see anything about the 3 in column 6 off the top of my head. There's row 2, column 6. Ah, beautiful. Okay. So Carl has a spot, which is that this cell has to go into the 10 cage, because it is one of the digits in the 10 cage, and it can only go here. So these two are the same digit, and in particular, this digit is not a 3, which now means one of these two is a 3. And now I can think about something to do with 3s. Yes, now I can think about 3 in column 7, so I'll get that one of these is a 3, so these aren't 3 in column 7. Yes, I have a 1, 2 pair, in fact, even better. So this is a 3, 5. Those aren't 5. Because the 1, 2 pair actually is there. So that gives me a 3 up here. Because of the 1, 2 pair looking at that cell. So this cell is also green. Based on that information, because this cell is not green, so that one is. Let's see. I kind of want to really gratuitously pencil mark the rest of this column. Is that crazy? 5, 6, 7, 8, 9. But this one I see isn't 6 or 7. It's 5, 8, or 9. Yeah, that was already a good idea, because now I have a 5, 7, 8, 9 quad in this box. So these are not from 5, 7, 8, 9. So they are from 1, 2, In fact, actually, this 1, 2, where does it go in this box? It goes exactly there. So these are not 1, 2, or 5, 7, 8, 9. And so they're the other ones. They are 6 and 3 is what these two are, to finish this off. And so if those are 3 and 6, this is not 3 or 6, it is 4. So these aren't 4. So one of these is 4. These aren't 4. This is a really neat puzzle. One of these is 4. Yeah, where does 7 in this row go now? 7 in this row needs to go over here now. So 7 doesn't go up there. So now, because the purple digits are the same, I actually know... Oh, no, I don't know if that 8, 9 goes there or there. I just know it goes up in one of those cells. Oh, but one of these is purple. Sorry. So there is actually some information. Although I guess it's boring information. That cell's purple. And the other of these is purple, but I don't know much about purple yet. Let's see. Ranks requests a color for the none green 1, 2. Let's make the none green 1, 2 orange. So this is the none green 1, 2. This is the none green 1, 2. Let's see. I know one of these two is green and the other's orange. I know this cell isn't 1 or 2 now. Yeah, so maybe I should be marking candidates for cells that can't be thing. Like this cell being unable to be 1 or 2, does that remove its candidates at all? This cell isn't 7, 8, or 9 because there's a 7, 8, 9 triple in the row. I didn't actually look at my further pencil marks anymore, so maybe it's worth examining slightly if I can do better on any of these. I don't think I can, but it was worth thinking about. Yeah, so orange in box 8. Orange can't go in this 29 case. So orange in box 8 definitely goes in one of these two cells. So this cell isn't orange. So orange in the 15 cage either isn't there, or orange is here. Oh, let's see. Do we know what this is now? I'm trying to figure out how we're getting that this 16 cage works. This always has, I guess, that's a good spot. There's always 2 1, 2, 3s in the 15 cage. So together, that's all the 1, 2, 3s. So these digits down here are from 5, 6, 7, 8, 9. And so if I look at this row, those 4 cells are from 5, 6, 7, 8, 9. And all but one cell of this cage is from 5, 6, 7, 8, 9. So if this isn't a 4, that would be a 5, 6, 7, 8, 9 quintuple. That doesn't work. So this is the 4. This is a 5, 6, 7, 8, 9. And so this is... this is a 3 now, because of that same argument. This is the other 1, 2. And so it's green. That's orange. That's green. This cell's not a 1 anymore because it sees the 1-2 pair. 4 is just placed by Sudoku into this box, says Sam, and I believe him. These are from 5, 6. Oh, actually, yeah, these aren't 5. So these are from 6, 7, 8, 9. This isn't a 5. So there's a... Oh, I know there's a 5 up here, so this is not a 5. 5 is placed in box 8, has been called. Row 8 now has a 6, 7, 8, 9 quad, so these are from 1, 2, 3. Except I know this one is not... Sorry, I know this one isn't 1. In fact, I know it's not 2. So this cell is 1, 2, or 3, but it sees green and orange, so this is the 3. So that's the 2, and that's the 1. And so that tells me it's orange, because it's a 1, 2 that is not that. Okay, so this is 1 and 3, and so these are 5 and 6. So those being 5 and 6 tells me those aren't 6. This isn't 2. Oh, this is green. I should mark it. These aren't 2. This is just like a frolic, is how I would describe this puzzle. It has been quite cute. Just fun. Very nice. Oh, good point. Where does orange go in row 7? Orange goes here and is a 1 or a 2. Oh, and I've got a 1, 2 pair, so this is a 3. So this is orange. Oh, the 1, 2 pair looks at this, so this is a 3. And this is orange. It's not a 3. Why not row 7, column 6? Uh-oh, did I screw up? Oh, yeah, you're right. Orange could have been... This could be orange. Right. And fortunately, think you're correct about that, regrettably. If I squint, I can figure out which of orange and green is 1 and 2. I guess these are 1. And these are 2. That I think will satisfy some critics. Let's see, so that's a 1, 3 pair. Okay. I've got this 5, 6, 7, 8, 9 quintuple in the column. So because this is a 5, 6, 7, 8, 9 quintuple, that tells me the rest of these are from 1, 2, 3, 4. This is not 6, so it's a 3. So these aren't 3. Nor is this one 2 or 4, so it's orange. This one sees both orange and green, so it's not 1 or 2, so it's a 4. So this one's green. So I guess that means it's a 2, and this is a 1. So this is a 3, and this is orange. And a 1. So this is a 3. This is orange. These aren't 1. Oops. Either that or they're both 1, and a complete surprise. The 3 looks up at this and actually tells me that this is green. So that's a 2 and a 3. I was going to say these aren't 6, but I realized they're not actually pencil marked as being able to be a 6. Oh, this 3 gave me this 6. I was so excited about the coloring, I didn't even bother to fill in the 6. Let's see. Six in column 4. Oh yeah, 6 in column 4 is a good idea. This is not a 6. One of these two is a 6. So these aren't 6. So one of these two is a 6. Oops, sorry, is a 6. We have 8 1s and 8 2s. That's always a good thing to know. Okay, so this cell is orange. And this cell is green. Okay. So we have a 7, 8, 9 triple in this row, so let's fill in the rest of the digits. So we've got our 1 and 2. We need a 3, 4, 5, 6, and then we've got our 7, 8, 9. So this cell is not a 3 or a 4. It's a 5 or a 6. That automatically gives me a 5, 6 pair in the column. This is not a 4 either, or a 6. It's a 3 or a 5. Oh, except there's a 5, 6 pair in the row now. So this is a 3. And that's a 4. So this is not a 4, and that is a 4. So this is the digit that's purple. How does that do us on 4s? We've got an awful lot of 4s, but we also have a 4 here. Is that all the 4s? I think that's all the 4s now. Yep, looks like all the 4s. Okay. This has a 6 in it. This having a 6 in it actually tells me what it is. It's 4, 6, 7, 9, so it's not that. And so if this is 4, 6, 7, 9, it in particular doesn't have an 8 in it. And it doesn't have a 5 in it either. So this is 4, 6, 7, 9, which is cool. I can get rid of this 9 business. This cell sees the whole cage. Well, sorry, it sees every cage except the 4. So this sees a 7 and a 9, so it's an 8. So this is not an 8. There's a 5, 6 pair here. So these are from 7, 8, 9. But they're not 8. So these are 7 or 9. And that gives me a 6, 7, 9 triple, which tells me that this is a 5. So that's not a 5. In fact, it's not a 6 either, because there's a 5, 6 pair in the box. This 7, 9 is the same as that 7, 9, right? Yeah, this 7, 9 and that 7, 9 are the same digit. And so where does blue go in this box? Blue in this box has to go here. So this is, in fact, not a 6 or an 8. It is a 7 or a 9. I can get rid of purple, I think. No, I do want to leave myself this reminder of what's going on with purple. Yeah, so now there's a 7, 8, 9 triple, so this is a 6. And so that's a 6. Not a 6. The 7, 9 pair. 5 in column 4. Ah, yeah, 5 in column 4 goes there. So 5 is purple, so that's 5, and that's 7. And that's 7, and that's 5. And that's an 8, and that's a 9. Beautiful spot to Ransk there. These aren't 5 anymore. They're an 8-9 pair. Let's see. I think I have to uncolor yellow and purple now because I think they're going to overlap with blue, potentially. So this 7-9 needs to go in this cage. It needs to go there. So these are the same digit. Sorry, these are the same digit. So that's not an 8. So one of these two is an 8. Let's see. This is not a 5 anymore. And it's not an 8 either. So in fact, that's a 9 and that's an 8. And this is blue. And since this is a blue-yellow pair, this is not a 9, it's an 8. That's a 9. Let's see. Let's fill in these digits. 2, 3, 4, 5, 6, 7. That's too many digits. What did I screw up? Oh, there is a 2 in the box already. 3, 5, 6, 7 is what's missing. These aren't 3. That's not 3 either, so this is 3. These aren't 5, so that's 5. These are a 6, 7 pair, so that's, sorry, so that's not a 7. There's an 8 and a 9. Oh yeah, I know Jovi doesn't like coloring. This 7 looks down and says that's not a 7. This 7 is yellow. Because there's a blue in the column. Beautiful. So this is blue. So let's see. So this isn't a 9 anymore at the very least. It's not 8. It's not 5. So that gives us a 6, 7 pair in the row. That's pretty cool. Oh, yellow and blue both have to appear in this column. That doesn't do anything. I don't think we could do anything if we knew that blue was 9, but we might be able to. I think I want to just fill in these 2 cells, even though it might give slight spoiler information about the bet cell, but we'll try and be cautious. 1, 2, 3, 4, 5, 6, 7, 8 is what's left. Oh, but not 6 and 7. Sorry, there's a 6, 7 pair already. So this is 5 or 8. And these are 6, 7, 8, 9. That one's not 9. This one is not 7 or 9, because blue and yellow are in the column. Okay, so we've got some 5s there. Let's see. Where does row 7, column 1... go in box 4? That is an excellent question. This digit needs to appear in box 4, and it's not in any of those places. I guess the other way to say it, so that's a very cool way, so it has to go there. The other way to say it is one of these two has to be a 5, and so this is a 6. Either way you do it, that's huge. because it now makes that a 5 and that an 8. Makes these not 8. Let's see. This is yellow. That's the point. This is yellow. And so once that's yellow, this is 6. Sorry, this is 6. So this isn't 6, and so it's blue. And so that's big. This isn't 9 anymore because we've got a 7-9 pair in the column. So that's an 8. So this isn't an 8, it's yellow. So we've got the yellow, blue going on. We've got to get yellow and blue over here somehow. Let's see, row 2, column 9. There we go. Beautiful point from ThoughtBite. This sees yellow and blue. This is why we've been coloring the whole time. So this cell sees yellow and blue, so it's an 8. And so this cell now is not 8, it's blue. It's not 8. So that means this isn't 8, and so it's yellow. And so now this sees a yellow-blue pair, so it's 8. That 5 looks over and makes that a 6, which makes that a 7, which must be yellow because of that. So this is an 8. Let's see, the 7 looks over and makes that a 6 and a 7. So this is yellow, and this is blue. We have to remember. Where does 7 go in row 1, column 5? Okay, so now we have discovered through the magic of this box that yellow is 7. So let's fill in that yellow is 7. And once yellow is 7, that means that blue is 9. And now this cell is not 1, 2, 3, 4, 6, 7, 8, or 9. So it is 5. And there we go. What a lovely puzzle. I really enjoyed that. How could you possibly do this without coloring? I agree with Ranks. It really shows masterful setting how we had no idea what the values of yellow and blue were until the very end of the puzzle. It was a great reveal there at the end. Oh no. Chris points out we made a mistake. We missed a yellow. Oh no, we completed the puzzle before completing the coloring. And this is blue too. Wow, we missed 2. Hopefully there aren't any more. That was a mistake. Very fun puzzle though. Alrighty. Yes, very embarrassing. I feel badly about it. Alrighty. I'm gonna go pick us up another puzzle, and I will be back very shortly. Be right back. Alrighty, welcome back. Thank you, everyone, for hanging out today, by the way. Today's stream has been a lot of fun. And thank you, as always, to our people who support us in whichever way, be it by showing up or by contributing through the Patreon or through YouTube membership. Very much appreciated. Heartfelt thanks to all of you for helping us keep doing this. Poke my noise filter. One moment. I will poke my noise filter. Consider it poked. Hopefully that sounds a little bit better. I have a noise filter that's trying to, in real time, filter out a fan. And so every once in a while sound slightly shifts, and so I have to redo the filter. Alrighty, so this is a puzzle by WildHound007. And so we have normal Sudoku rules. And anti-knight. Anti-knight means that if I put a 2 here, I'm not allowed to put a 2 in this cell. So be wary of that. It's a little bit weird, but we have chat here to help scan. We do need a bet cell. Let's make that the bet cell. So go ahead and place your bets on what value the cell will have. We have the sum of these cells is 40. The diagonal, that's called a little killer clue. Digits along it can repeat, that's perfectly fine. Digits separated by a V sum to 5, digits separated by an X sum to 10. Not all are given. White dots, as you learned if you came earlier. And if you missed earlier, by the way, I opened stream today with a sort of intro to Kropki tutorial to sort of teach you all the, I mean, probably not literally every trick, but I tried to get as many tricks as possible in there. So if you would like help with Kropki puzzles, earlier I did a sort of lengthy tutorial intro to it, and I'll be doing those more often. So other mechanics to come, but you can do that. White dots there. Black dots are ratio of 1 to 2. And then these are arrows, so the digits along the arrow sum to the digit in the circle. Alrighty, so the first thing I see in this puzzle is that along the V's, we know that every digit on a V is a 1, 2, 3, 4. Sorry, I need to scoot slightly closer to the computer. Let me know if this completely messes up my filter. I don't think it will, but if that completely messed up my filter, let me know. So then these are a 5, 6, 7, 8, 9. Now, because of the Thermo business, actually, because these sum to 5, I know that this has to be the 1 or 2, and this has to be the 3 or 4. Little itty bitty Thermo. I guess tomorrow is Bastille Day. That was not why I chose to do the puzzle, but that is a good point. So funnily enough, this cell sees both flavors of 1, 2. So this cell I could pencil mark as being 3, 4, 5, 6, 7, 8, 9. I don't really want to, but I could. Row 5, column 7. No, row 5, column 7. There we go. Isn't this row 5, column 7? Let's see. Okay, so this arrow... 6, 7, 8, 9, because it's a sum of at least 3 digits. I don't see why it couldn't be 1, 2, 3 as of yet. This is on a black dot, so it's 6 or 8. And so this is 3 or 4. So actually, that's kind of interesting, because if this is a 6, then that's a 3, and this is a 1-2 pair. If this is an 8, then that's a 4, and this is a 1-3 pair. So we can write in sort of all of those options right away for there. Let's see. So what's the minimum this can be now? It can't be 3, because that would put 3 1-2-3s in. So this could be 4 with a 1-3, maybe. It could be 6, or it could be 8. I think those are the only options for this. Which still leaves lots of options for this, unfortunately. 4 would break the little killer. Oh, okay. Yeah, I guess this little killer is really worth sort of thinking about, because the maximum that these highlighted cells can sum to is 17 times 2. Which is, if you like, 6 short of 40. So this cell needs to be at least 6, so it's not a 4. So this is a 3 or a 4. If this is a 6, then these are at both 8, 9 pairs. Otherwise, this is an 8. Oh, good point from Sayori. This dot, it can't be as high as 4 and 5, because that would already blow the bank. So these are from 1, 2, 3, 4, which gives us a quad in the column, which is fascinating. So one of these two is a 4. Oh, I do know one of these is a 1. I should have pencil marked that before. So this is not a 1. But this could still potentially be a 1, 2. Oh, right. I noted this, but I didn't say it before. There's always a 3 in these cells. Because if this is a 6, then that's a 3. If this is an 8, then that's a 4, but then this is a 1, 3. So this is, in fact, always 2 or 4. So this is always 1 or 3. Very wise to those of you who pointed that out. Let's see. See, Carl says if row 5, column 1 is an 8, so is row 3, column 3. Let's see, if this is an 8, it's a 4, 1, 3. Why are these the same? Oh, I see. It's because if this is an 8, it puts a 3 up here. Right. If this is an 8, this is 1, 3, and so then this is a 4, and so this is an 8. Okay. So if this is an 8, this is an 8. Oh, but the point is it works the other way, too. If this is a 6, then that's a 3. So this is 1, 2. And so that's a 3, and this is a 6. So if this is a 6, this is also a 6. But now our maximum value is 6 plus 9 plus 6 plus 8 plus 7, or sorry, plus 8 plus 9, but that's not enough. We don't have, we only have at most 2 degrees of freedom, and so I can't do that. So this is an 8 and a 4. Oops, and a 4. And we can bring in Zach to do our dance for the 8. Thank you, Zach. Alrighty. So that gives us those. So, that being an 8 means this isn't an 8, for whatever it's worth. Oh, this can't be a 7 either, can it? Yeah, this can't be a 7 anymore. Because if this is a 7, I'd need these to be 1, 2, 4. But these would have to be the 1, 2. So this isn't a 7. So if this is a 6... Oh, I guess then this could still be a few things. And if this is a 9, this could maybe be a few things. But not so much. I think it's okay if this is a 6. If this is a 6, then that's a 3, and this is a 1, 2. I think that's okay. I know this is a 5, 6, 7. Oh, okay. Smart point from Josh Johnson. What's going on this white dot? Well, it's not less than 4, because I already have 2 of the digits less than 4 over here. It's not bigger than 8. So these digits are from 5, 6, 7 themselves, which actually gives us a 5, 6, 7 triple of all bizarre things in the column. But there's definitely a 6 here, which means there's not a 6 here, which means there's not a 2 here. Which is super cool. These are a 2, 3, or 9. But this one I know is not a 3, because there's a 3 down here. So this is 2 or 9. I think the blue and red are aesthetic only, as best I can tell. I'm being told this is a naked single, but I don't think I see how. Oh, right, because there's a quad, right. This 2, 4, together with these, made a 1, 2, 3, 4, so this is a 9. Okay, so this is not a 9, so it's a 2 or a 3. Good. I suppose it's worth mentioning... Maybe it's not worth mentioning. I don't know. This 5, 6, 7 is very surprising to me. Candidates on X in box 3. Aren't there a lot of them? Like, is there anything I can rule off of it? Row 4, column 2. let's see. Andrew asks what the minimum is for this. Don't know. Does this arrow need to have a 1? Could this be 2, 3, 4? So if this could be... So this can't be 2, 3. This would have to be 3, 4 with exactly a 2 there. Does that break for some reason? I don't think so. So I should probably write in candidates for this. So I think this... Okay, so let's just write in 1, 2, 3, 4. It's not 5, 6, 7. Could be 8, maybe. Or 9, I guess. Maybe this has too many candidates. Yeah, I think this is too many candidates. Maybe I don't want to write that in yet. It's very restricted, though. Oh, right, because of the 40 little killer clue. So if this is an 8 and a 9 and an 8, that's 16 plus 9. 16 plus 9 is 25. Plus 8 is 33, so this needs to be at least 7 always, I think, if I did that right. 8 and 9 is 17, plus 8 is 25, plus 8 is 33, so this needs to be at least 7. And it can't be 7 because there's a 7 in the column. Oops, sorry. So this is an 8 or a 9. I believe that. Okay, Jay is asking if it really can be 8. Because if it's 8, then it makes this a 6, which is going to push this thing down by too much. So if this is an 8 and a 6, that's 14, plus 8 is 22, plus 17 is only 39. So this actually can't be an 8 because it actually eats away too much. It eats away 3 degrees of freedom and we only have 2. So this is not an 8, it's a 9. So these aren't 9. One of these two cells is a 9. Let's see, Naverio says this can't be a 6. Because row 7, column 3, sees everything in column 1 except row 5, column 1? I don't know what you mean by that. By sees everything in column 1. Okay. Okay. I understand now what you mean. Okay. So by anti-night, this sees those cells. It sees that by the box. It's not 1, 2, 3. So this cell is either 6, if that's a 6, or it's 9. And so these would have to both be 6, is Navario's point. And then these can't both be 6 for reasons. Breaks the bottom arrow. Right. If they're both 6, okay. So if this is 6, that has to be 6. But now this is 1, 2, 3, and that has no fill, because this would also have to be 1, 2, 3. That's very complicated. But I agree with you. That is a 9. So what are the ways to make 9? 1, 3, 5, this cannot be 1, 3, 5. 1, 2, 6, it could be. That would make this cell a 6. And 2, 3, 4, in which case I would need a 4 here and a 3 here, and this would be a 2. So because of the fact that there's a white dot here, the only options for this cell are 2 or 6. With this being 4, 3, or this being 2, 1. Good night, Judith. So the box 7 arrow definitely has a 2 on it. I agree with that, because it's either 1, 2, 6 or 2, 3, 4. So this can't be a 2 or a 4, I guess is the point, because this cell sees both of these. So let's just write it all in and then look at it. So it's not a 4. It's not a 3, because a 3 would put a 6 here. It's not a 2, because it sees both of those. It's not an 8, because there's an 8 in the column. So this can only be a 1 or a 6, which makes this a 2 or a 3. Which is very interesting. Let's see, Jay says row 7, column 1, and column 2. Ah, interesting. Okay, so this digit needs to go in column 2. It can't go in any of those places. It can't go there. It can only go there. So Jay's spot, I think, is actually a little easier than the spot we were getting, which is that this digit has to be the same as this digit. It's the only way it works. So they have to both be 2. So that's a 6 and a 1 and a 1. Very good spot to Jay. That places 2 up here. There's no 2 on this, so that's an 8. And so that's a 4. This is a 1, 3. You can get rid of that 1 there, like that. We can look at this now. I guess this still has options, annoyingly. So, yeah, where is 6 in column 1? 6 in column 1 has to go here. This pair is a 5 and a 7. So these digits are a 3, 4, 5, 8. Oh, not 5. 3, 4, 8. So I can't have an 8 on the dot. So this is 8. This is a 3, 4 pair. The 4 looks down and resolves it, so that's a 3 and a 4. This is now a pair. 2, 3, 4. We need a 5. And we need a 7 again. Now this is a single. 1, 2. This is a 3. Okay. This is not 1 or 2. So this is not 3 or 4. Because of how V's work. So that actually gives us a 1, 2 pair in the row, of all things. That's not an 8. Oh, that's not a 4. That's huge. That's a 3. So that's a 2. So that's a 1 and a 4. Okay, so that gets us a lot of good stuff. This 3 sees that that's a 1, so that's a 3. That's a 7. So this is a 5, 6. That 7 sees down that that's a 5 and that's a 7. That 5 sees over there. The 7 sees over there. The 6 sees over there. 1 in box 5 is placed by Anti-Knight here. Very good spot to Sayori. Let's see, what about 1 here? I guess I... Oh yeah, 1 is placed in box 2. Because I certainly can't put a 1 on the 40 diagonal. So 1 is there. So 1 is over in one of these 2 cells. In fact, actually, I know what the sum of these 2 is, don't I? That's 16 plus 9. 16 plus 9 is 25. So these 2 sum to 15. So they're from 6, 7, 8, 9. That one's not a 9, so that one's not a 6. That one's not a 7, so that one's not an 8. Good point. This X is restricted because it doesn't have a 1 or a 4 on it. So it's either a 2 and an 8, or it's a 3 and a 7. The 2 can't go there, so the 8 can't go there. The 3 can't go here, so the 7 can't go here. I was hoping that was going to sort this out with Anti-Knight by looking at this cell, but it does not appear to me that it does immediately. Okay. I think it's probably time to gratuitously pencil mark some things. So we need a 2 in this row. We've got a 3, 4. We need a 5. We've got a 7. We need a 6 and an 8. Let's see. This sees... does it actually see none of those by Anti-Knight? It maybe sees none of those by Anti-Knight. These digits, we've got a 1, 2, 3. We need a 4. We've got a 5. We need a 6 and a 7. We've got an 8, and we need a 9. That one at least is not 4. This one's not 9 by Anti-Knight. The bet cell sees 5 and 8, so the bet cell's down to 2 or 6. Let's see. AFK suggests 1s in box 9. Looks to me like there's a lot of places for 1s in box 9. Is there a reason why 1 can't go on the X? Row 5, column 5 sees the 7. There we go. I love doing Anti-Knight puzzles on stream because then someone in chat will see every scanning error that I make. Oh, right. Okay, so this can't be a 9 is what AFK is saying. So, yeah, so if this was a high digit, it couldn't be 6 or 8. It would have to be 7 or 9. But 7 and 9 in this box are both packed over here, is the point. And so 7 and 9 both see this. So this cell is a 1, 2, 3. It's not a 4 because it sees a 4 there. This is a 7, 8, 9. Oh, there's a Clover. Hey, Clover, how are you? I did several gas puzzles earlier on stream, but I don't think any of them were yours. Not by intention. I think that just so happened I did 2 Sams and a Philip, but maybe one of them was yours. Okay, so 1 in this box goes in one of these 2 cells. Yeah, 1 over here goes in one of these 3 cells. That seems gratuitous to pencil mark. I know 2 is in one of these 2 cells, so 2 is not in either of those 2 cells. It's not there, but that doesn't... let's see, 3 in box 5? Ooh, a big pile of jigsaw puzzles. If you would like jigsaw puzzles, we have some we can mail you. If you want to get in touch in Discord, if you want to do some jigsaw puzzles, we can probably mail you a box of Discord puzzles. Or sorry, not a box of Discord puzzles. If you message us on Discord, we can probably mail you a box of jigsaw puzzles. Jigsaw puzzles are very cool, by the way. Okay. I was looking at 3s in box 5, which were not there. So, not in those places, not there. So the 3s in box 5 are in one of those 2 places. I can place 4 in column 5, I'm being told. Okay, yeah, this 4 damages all of those. That's not a 4, that's not a 4. None of those are 4, and that's not a 4. Oh, wow, okay. Good spot to Carl, which combines with the 1 pencil marks we had from earlier to place a 1 there. Every once in a while, we just have to do an anti-knight for fun. Alrighty. Yeah, that was a hell of a spot, Carl. Okay, so now the 1 over here needs to go in one of these 2 spots. Oh, and now 4 in box 9 is placed. Gorgeous. So that is the 4. So now 4 up here can only go in 2 places. Can only go those. Let's see. 2 in this box is in one of these places, but who knows where. 4 in this box, actually. 4 in box 5 only goes in one of these 2 spots. So let's see. 4 up here, do I know anything? It goes in one of those 3 spots, it looks like. I don't think any of those are exceptionally interesting that I am able to discern. You know, we got 4s over there, 4s there. Where are 4s in this? Yeah, 4s, I guess, go in 3 corners in this box, annoyingly. Dagnammit, you should reward me for gratuitously pencil marking things. Let's see. And one of these 2's a 2. Row 2, column 7 is always a 2. If that's a 7, it makes that a 2. If this is a 6, then this is a 9. That's more complicated for me to see why this ends up being a 2 in that instance. 3 in box 3. Not any of those spots. Not there either. So 3 in box 3 is in one of 3 spots? Am I missing something about 3s in box 3? 2 in column 5 in 2 spots. There or there? Not there, not there. Yeah, okay, so one of these 2 is a 2. I agree. Let's see. Gary is looking at it, row 4, column 5. if this is a 2, then and I need to put 2 in this row, and so 2 needs to go in one of these spots. Why couldn't 2 go there in that universe? I see why if this is a 6, it makes that a 2. C's row 1, column 5 by Knight's move. 2 in box 2 first. Oh, okay, so if this is a 2, then we look at this and say, okay, so one of these 2 becomes a 2. Oh, sorry, so this becomes a 2 exactly, because of that 2. So if this is a 2, that's a 2. And now, where is 2 going in this box? 2 in this box is now placed here. Oh boy, that is something else. Okay. So if this is a 2, that sells a 2. If this is a 6, then that much more directly makes that a 7, which makes that a 2. So this is always a 2 and an 8. So that's not an 8. So where does 8 go in this box? It needs to go in one of those 2 spots. Now 2 in column 5 is not there. It's not there or there. So the bet cell is a 2. Congratulations to those of you who bet 2. How are we doing on 2s? Now we need a 2 in this box, which is going to have to go here or here. The red and blue colors are just aesthetic. Okay, and 2 in... Ah, yeah, where does 2 go in column 8? 2 in column 8 has to go here now. So that's a 2 and an 8. And now, where does the 8 go in box 6? It has to go there. So that's not an 8, and that's not an 8. That's a 5-6 pair. So that's an 8, and that's a 9. And so that's an 8. These are neither 5 nor 6. They're a 7-9 pair. Let's see. 8 now in box 7 is done here. Ah, good point. Thank you. Dog points out, I know these 2 added to 15. So that's a 6. So that's a 9. So that's a 7 and a 9. So these aren't 7 or 9. They're a 4-6 pair. So these digits are the remaining things. They're a 3, 5, and 7. That one's not a 7. That one's not a 5. That one's not a 7 either, so that one is a 7. That one's also not a 3, so it is a 5 and a 3. This is a pair. It's a 3, which I know where it goes, and a something else. A 5, which looks over and gives me the 6 and the 5. So these are a 1 and something. 4, 5, 6. A 1 and a 7. So that's the 1, that's the 7. These digits are a 2, a 4, and a 7. That one I know is not a 2. These aren't 7, actually, so that one is 7. This one's not 2 either. It's a 4, because the 2 looked at it, so that's the 2. That 4 looks at the 6 and the 4 and sorts those out. These 3, 2, 3, 7. It's not a 2. That one's not a 2, so that one is a 2. That one's not a 3, so it's a 7 and a 3. These 3 are 5, 6, 9. That one's not a 9. Or a 5, so it's a 6. So these are a 5, 9. Let's see, that seems to me to be okay on 5s and 9s. And this one also seems to be okay on 5s and 9s. These 3 digits, let's look at them. They don't include a 4, I see right away, so that's a 4. I probably know what this digit is now. I think it's a 3. So to finish this column, I need a 5 and a 6. To finish this box, I need a 5 and a 6 and a 9. Don't know that I see any of that right away. This row, we need a 3, and I know where the 3 goes, so that's good. And we need one more thing, or... we need a 5. That's great. Okay, so that's a 5. So that's not a 5. These are 6 and 9 and something else. And 1. That one's not a 1, so that one is a 1. This is a 6 or a 9, and that's a 6 or a 9. These are 6, 7, 9. That one's not a 6. And it's not a 9 either, by that 9, so that's a 7. This 6 sees that cell, so that's a 9 and a 6. The 6 looks up, making that a 9. So that's not a 9. So we've got our little 5, 6 deadly pattern. We've got a 5 and a 9, and a 7 and a 5. And now we get to look at that 5, and that's going to give us 2 6s and 2 5s. Very nice. The one step in the middle, I'm going to bet there was a different way around the slightly complicated step, but it was a cool enough deduction that I was happy to use it. Fun puzzle. I enjoyed that, Wild Hound. I think this is Wild Hound's debut on the stream. Yeah, an enjoyable collection of assorted clue types. I tend to really enjoy the puzzles that are like, okay, here's like 4 clue types. Let's just throw them together and make things. And yeah, Anti-Night is fun. And Anti-Night, I think, is especially fun to do on stream. I assume that this is a French flag. I can't say for certain, but that is my belief. Yeah, Anti-Night very often gets you some sneaky step involved. Yeah, definitely very bouncy is a good way to put it. Yeah, I did not originally appreciate just how powerful this 40 little killer was. I assumed it was going to be something that didn't show up until the end, but we got there. Alrighty, I'm going to take a quick break. And then I'll be back with another puzzle. So don't go anywhere, and I'll see you very shortly. Alrighty, welcome back. Oh, I'm going to scoot closer. One moment. There we go. Now I am closer. Alrighty, so we're back with a puzzle from Ocaly, which combines a bunch of different things that we've done today. So we do have our Kropki from earlier. They are still here. The green lines are whispers, which means these digits have to be at least 5 apart. And these are between lines, which means that the 2 digits that appear here have to be between the 2 digits in the circles. And just to repeat, I did a whole thing about this earlier, but the black dots mean that the ratio of the digits is 2 to 1, and the white dots mean the digits are consecutive. So, one of the bigger things we learned earlier is that when you have a string of 3 black dots like this, then there's always a 2 or 4 in the middle. So these are from 1, 2, 4, 8. Well, they're not 1, because you can't put a 1 on a between line. Because if I put a 1 on a between line, then I need to put a 0 in one of the bulbs. But if 2, 4, and 8 are the digits on the between line, then the middle one is a 4. And so then we've got a 2 and an 8 here. Okay, so 5 away from 2 would be 7. So, and I can't put a 9 or an 8. So one of these is a 7. And 5 away from 8 would need to be at most 3, but it couldn't be smaller than a 3. So that's a 3. Oh, right, that was a digit. It was a digit. You snuck it in there. I almost missed it. We need a penguin. Fortunately, I have a penguin on standby to do the 4 dance. It's a bit of a tap dance. But his legs are very short, so tap dancing is hard. Thank you, Zach. You are very appreciated. Alrighty, so we've got those. So let's fill in these digits. By the way, we have Ocaly in the house. Welcome, Ocaly. The constructor of this puzzle, by the way, I should say. 1, 2, 3, 4. We need a 5 and a 6. 7, 8, and we need a 9. So whichever of these has the 8 on it has the 9 has a 9 in a circle. So one of these circle digits is a 9. And then one of the circle digits is a 1. I don't know if I really want to try and pencil mark that in some way. Actually, I think I do. Okay. These are the bounding circles of these. I need a 1 in here. And I need a 9 in here. But I think actually I can do better than that. Because I could ask myself, can I have 2 1s in here? And the answer is no, because if I put 2 1s in these circles, I would rule 1 out of the entirety of box 5. And the same thing would happen to 9s if I put 2 9s in here. And so one of these is a 2 and a 7. That one must be bounded by 1 and 8. And the other is an 8 and a 3, and that one must be bounded by 9 and 2. So actually I can fill in that center markily, these are 1, 2, 8, 9. which is very interesting. Oh, bet cell. That's right. We should have bet cell. Do you have a suggestion of a bet cell, ocaly? Oh, because I'm being ridiculous. Garion is completely right. I could absolutely have 2 9s, because I could have the 9s there. Sorry, you're completely right. So my argument was not correct. So I will stand by the fact that there has to be a 1 and a 9 in here, but it is not true to say that I need those. Okay. Okay, so a thing we talked about earlier was that when you have a sort of bent trio of digits like this, you have to worry about the fact that these two could be the same. But in this instance, they can't be the same because they're on a whisper line. So these are actually 3 different digits, and one of them is quadruple the other. And so those must be 2, 4, 8. Row 6, column 8. There you go. Go wild, betting on this. Okay, and so because this is 2, 4, 8, it must be the case that this is a 4. And so these are not 4. They're a 2, 8 pair, and so that means that this must be bounded by a 1, 9. And I bet exactly the same thing works here. So this is a 4. These are a 2, 8, and therefore these are a 1, 9. Okay. I think I want to color my 1 9s. So we're going to make this the purple 1 9 and this the green 1 9. So this is purple and this is green. Just in case that somehow becomes helpful. The yellow candidates were valid, right? Because it's still the case that this is either a 2 and a 7, in which case it is 1, 8, 9, or it is a 3 and an 8, in which case it is 1, 2, 9. So these are still from 1, 2, 8, 9, regardless of any shenaniganery. That is a good point. I keep now scanning for anti-knight, which is not helpful. I suppose I can color the 2 8s as well. Is that more interesting than coloring the 1 9s? Well, no reason I can't do both. We'll make this the orange 2 8 and this the blue 2 8. So that is the blue 2 8. That's the orange 2 8. That's the blue 2 8. That's the orange 2 8. Ah, interesting. Okay, so there's... I think that might actually get us somewhere. I need a blue 2 8 over here, I guess. Oh, here's the point. This sees both blue and orange 2 8. Gorgeous. So this sees blue and orange 2 8, so it's not 2 or 8. This sees blue and orange 2 8, so it's not 2 or 8. This one sees blue or orange 2 8, so it's not 2 or 8. And this one sees blue and orange 2 8, so it's not 2 or 8. And so I can get rid of the yellow coloring, and I can color these in their true colors. Because this is now purple. This is purple. This is green. And this is green. This is green. Try again. We can get rid of the 1 9s in the corners. Thank you, Garion, for catching me yet again from doing something dumb. This is not a 1 or a 9 because it sees both. This is not a 1 or a 9 because it sees both. And in fact, actually, if you ask, where does green 1 9 go in this box? It goes exactly here. So this is a 1 or a 9. And where does purple 1, 9 go in this box? It goes exactly here. Oops. It goes exactly there. So, so we've got all of those things going on. Okay, and so this 1, 9... good spot. Okay, where do 1 and 9 go in box 3 is an excellent question. 1 and 9 in box 3 are pushed into here exactly. So this is a 1, 9 pair. And now we're 1 and 9 in box 9. Again, they can't go, 1 and 9 can't go on the between line. So 1 and 9 are always here. And likewise up here, 1 and 9 are pushed over here. And likewise down here, 1 and 9 are pushed there. So this digit, that's the interesting one. This is a 2 or 8, so it's blue by the column. And so blue 2, 8 actually is now placed into box 9. Blue 2, 8 in box 9 is now placed here. And now blue 2, 8 is on this this string up here. Orange 2, 8 is already in box 2. Oh, this is a 2 or an 8. Got it. Okay, sorry. I didn't see this white dot. This is a 2 or an 8, so this is orange. So this is a 3 or a 7. Of some description. So, oh no, do I want to completely redo my coloring? Because this kind of makes me want to redo my coloring, but I probably shouldn't. Orange 2, 8 in box 6 is an excellent point. So, could I put a 2, 8 here? Well, no, because 2 or 8 is going to be adjacent to 1 or 9 on one side, so I'd have to put a third 1, 9 in the column. So this is orange 2, 8. Likewise, orange 2, 8 in box 1 is placed there. I know blue 2, 8 is up here. So these are from 2, 8 or 3, 7, I suppose I could say. I know orange is over here, so these are from 2, 8, 3, 7. Let's see. Should I know anything about this white dot? I feel like I don't. Oh, where's orange in row 7, asks Fransk. Oh, I don't know that orange is down here. I don't know why I said that. 2, 3, 7, 8. I think orange in row 7 could go there. Right? Oh, wow, that's amazing. Where is orange 2, 8 in this box? Well, it's in one of these two cells, but no, it doesn't work. It's here that I would need it to be. It can't go there. But I think orange 2, 8 could go here. Orange 2, 8 is already in box 1. Because of row 2, column 6. Oh, wow, yeah, okay, so yeah, that's a very clever spot. I was thinking it was because of the 3, 7 pair, but no. If this was orange 2, 8, then this would be, well, not 1, 9, so it would be the 3, 7 that's adjacent to orange 2, 8. Except that's the 3, 7 that's adjacent to orange 2, 8. That's really clever. So This is the orange 2/8. Oh, that was a very cool swish. Okay, so on here I can't have any 2/8s or 1/9s. So I'm choosing from 3, 4, 5, 6, 7. So I always need to use a 5 somewhere in this string of Kropki. Josh is there as well. Let's see. Finish orange. Oh, let's see. Okay, so orange, right. Orange in this box is here. Good, good. And so then orange in this box is here. And so this is a 3/7. I really need to color my 3/7s, don't I? Because these are the opposite flavor of 3/7s. So yeah, so let's color our 3/7s. Our 3/7s are going to be yellow and gray. So that one will be yellow. That one will be gray. So the one that goes on a whisper with orange is gray. So that's that one. That one's gray. That one's yellow. Because it goes on a whisper with blue. What did I do? Bad color? Uh-oh, what did I do? Box 7's yellow is not gray. I thought I defined box 7's yellow to be gray. Because these are different, right? These two are consecutive, so they can't, I should maybe have spelled that out more. These two are consecutive, so they're different than the ones that are differ by at least 5. Okay, I know there's a yellow down here somewhere. Okay, I unfortunately am in this situation where I don't know which 2/8 can go here, or which 3/7. But this is either 3/7 or 4/6. But that's a lot of options. Is this Ocaly's debut on the channel? I thought Ocaly had submitted stuff for the various competitions at least before. I feel like I've done Ocaly puzzles before. I could be wrong. Okay, people are want me to look at 4s. Like over here or something. I'm not quite sure where people want me to look at 4s. Blue 2/8 in box 4. Yes, blue 2/8 in box 4. This can't be a blue 2. Oh, maybe could this be a blue 2/8? If this is a blue 2/8, then this would have to be a 3/7, and this would have to be a 4/6. Isn't that okay? Why can't this be the blue 2/8? Fours in boxes 1 and 9. Ah, yeah, okay, that's cute. So, yeah, the 4 squeezes that, so that places a 4 there. And the 4 squeezes this, which places a 4 here. And so, once that's a 4... Oh, actually, sorry, no, that doesn't do anything. Because the 4 is not... this is not a whisper line. Okay. I was briefly afraid that would resolve some things, but it doesn't. Okay. So can 3 be on the dot in box 4? 4 on dot in column 9. Ah, 4 is on the dot in column 9. That's interesting. In fact, yeah, 4 is just placed in column 9. There we go. That's a 4. So this is a 3 or 5. And so that places the 4 here in this box. Well, this is a very cool puzzle, so I am very delighted to have this be the debut on the channel. Should I ask what this can be? So if this is gray 3-7... No, this can't be gray 3-7. So where does gray 3-7 go in row 1? Or sorry, in row 4? If this is gray 3-7 is next to a 2 or an 8, neither of which can go here. So this can't be gray 3-7. This is gray 3-7. Because I do need to put a gray 3-7 in this row. And that now means this cell has to be a 5 or a 6. Hey, Kodek, how are you doing? So let's see, if this was a 5... Well, this can't be a 5, because if this is a 5, one of these two would have to be a 4, and neither can be, so this is a 6. So this is a 5-7 pair. I'm not your mother. You can bet 3 if you want. So that's a 5-7 pair. That 6 looks left, making that a 5, and that a 6. So now I need a 6 over here somewhere. I mean, it would make a lot of sense to put the 6 there, but I don't think I see it yet. Okay, so if this were a 3, I guess I could ask, could this be... This can't be 2 or 8. So, okay, so that's a good point. Okay, so this cell can't be 2 or 8, which are 2 of the things that are adjacent to 3 and 7. The other things that are adjacent to 3 and 7 are 4 and 6, and it's not a 4. So this is a 6, is the point. And so that means that gray is in fact a 7. So we're starting to mow through these things. Well, sometimes you figure out the bet cell. So green is 1 because it's across from gray on a thing. And so purple is therefore 9. So yellow is 3. Orange is 2 because it's on a white dot there. So blue is 8. So this is not a 2 or a 3, it's a 7 or an 8. So this is a 2 or a 3, and it's not a 2, so it's a 3, and it's yellow. 3 is not next to 7, so this is an 8, which is blue. Da-dee-dee-da-dee-da. That 3 looks down and makes this a 5, which makes that a 7. 1, 2, let's see. We need a 3 for this row. It has to go there and is yellow. For this box, I am sorry I wasted Sayori's cool spot. This is an 8 and is blue. So now this is 8 and is blue. How are we ever resolving these 1s and 9s on the outside? I don't see how it's going to happen yet, but I'm sure it will be great. 3 in box 1 is placed here. Well, I'm told we have 8 8s. We do have 8 8s, so this is also an 8. To finish the 8s. The king of the 8s. So this column is missing a 5 and a something else. And a 6, it looks like, actually. 5 and 6. So I don't think that's resolved yet, unfortunately. So these are 5 and 6. So this is 4, 5, 6, 7. Except it's not a 5, because there's a 5 in the column already. This is a 4, 6, or 7. Let's write out the rest of this column. I believe it is exactly 4, 6, 7. This one's not a 4. So it is a 6 or a 7. Oh, what color is the 7 in box 6? That is a good question. 7 is gray. We should be careful about that. That 7 looks up to this 5. This row needs a 6 and a 7. The 7 has to go here and be gray. The 6 is going to go over here. This digit is now a 2, 3, 4. This digit is now a 5. This digit I should be able to deduce. This digit is a yellow 3. So this digit is going to be 1, 2, 3, 4, 5. This digit is a 6. Oops. This digit is a 6, which doesn't have a color. But it does mean that this digit's a 5, and this digit's a 4, which also doesn't have a color. So that's not a 4. So this column, let's fill in. We've got a 1 and a 2. We need a 3 and a 4 and a 5. We've got a 6. We need a 7. And we've got an 8 and a 9. These aren't 3. That one's not a 4. It's a 5 or a 7. That one's not 4. That one's not 4 either. So the 4 in this column, we're being told, goes here in as many words. So this is a 3, which it's not, or it's a 5. Well, there goes my hope that this white dot was going to resolve the 1-9 deadly patterns. Oh, I'm an idiot. I've been debating this whole time how the 1-9 deadly patterns are going to get resolved while this dot and this dot have been sitting here. So in fact, these are green and are 1s. These are purple and are 9s. These are purple and are 9s. These are green and are 1s. I was like, I was sure it was going to be this dot somehow, and then suddenly that dot didn't do it, which I realize in retrospect there was no way this dot was ever going to disambiguate a deadly pattern that was not anywhere near it. But I was just looking forward with great suspense as to how this was going to sort out. 1, 2, 3, 4, 5, 6. This is a 7 and is gray. So this is a 5 and a 6, and this is a 7 and is gray. 2, 3, 4, 5. This is a 6. This cell is... Yeah, it certainly doesn't add anything to the solve to disambiguate them. Just this whole time had been looking forward to seeing how they were disambiguated and thought it was going to be something, something not that there was just a white dot I had just literally not filled in. 2, 3, 4, 5, 6. This is a 7 and is gray. These cells are a 3, which is yellow, and a 5, which has to go there. And so this is where my yellow 3 goes. So this is a gray 7. So this is not a 7. And this is a yellow 3. And now we have to be very careful and do a quick overview and make sure we have not failed to color anything before we finish the puzzle. So all of our 1s are green, all of our 2s are orange, all of our 3s are yellow. I see there's also going to be a yellow of unknown disposition here. 4, 5, 6, 7s. All of our 7s are gray. All of our 8s are blue. All of our 9s are purple. I think the Betzello is complete. That is a 6. We look in our careful color index and we discover that the Betzel is a 3. Well, it was a small 6 to make sure I didn't accidentally finish the puzzle before I finished the coloring, because there was an embarrassing incident that has been scrubbed from the internet that you won't be able to find any evidence of. But there was an embarrassing colorage incident earlier, so we had to be very careful with that one. Yeah, that was a great puzzle. I really enjoyed that. How did your friends find it? You said that was you said that was intended to be an easier puzzle for your friends. I'm not sure. I mean, it was certainly not like one of the hardest puzzles we've seen on stream, but I would imagine that people newer to Sudoku would struggle with that one quite a bit. But a very cool one. The discovery that 2-8 had the same sort of like, they ended up being linked here and also by whispers was a very cool thing to base the puzzle around. That was a lot of fun. I enjoyed that one a lot. Alrighty. I'm going to take a quick break, and then I'll come back and I will find more puzzles for us to do. Alrighty, welcome back, everyone. Next up, this centering is slightly bothering me. Can I fix this? Maybe I can't. Oh, there we go. Slightly. Let me just slightly. Oops. There we go. That's just a little better. Okay. Maybe it's not. Whatever. We're gonna move on and call it good enough. Alrighty. So our next puzzle, Fibonacci Fountain by Malrog. I believe this is also Malrog's debut on the channel. So we have these magic blue lines, and the rule about blue lines is that adjacent digits on a blue line always sum to a Fibonacci number. So we are told helpfully that 0 is a Fibonacci number. I don't think the adjacent digits are going to sum to 0 or 1, but they will sum to perhaps... Well, they're not going to sum to 2 either, but they will sum to, well, let's write them out. So the way the sequence works is you put 1, 1, 2, 3, 5, 8, 13. And the way this works is that you take the sum of the previous 2. So 1, 1, add together to be 2. 1 and 2 add together to be 3. 2 and 3 add together to be 5, and so on along the lines. It's true. There is a place I can put 2. I can put 2s along the diagonal. Okay, so we have to figure out how to make it work that everything is going to sum to a Fibonacci number. So I'm going to write out the Fibonacci numbers in front of me just so I can reference it. So we've got 2, 3, 5, 8, 13, 21. So the thing I was immediately sus about was 9 in this row. And I was correct to be suspicious of 9 in this row. Yeah, 21 is too big. That was the point. But I needed to go to one that was too big in order to know that I'd gone one. It's like the proverb. It takes 4 wipes to know that 3 was enough. So 9 was the thing I was suspicious about. So the only way 9 works is if I put it with a 4 to make 13. So there's a 9 on one of the 2 ends of this. And then also in this row, I need to put an 8 somewhere, and the only way 8 is going to work is with a 5. So that means that these 2 endpoints, they're an 8 and a 9. And so 8 and 9, the 9 needs a 4, and the 8 needs a 5. In both cases, we have to get to 13. So the 5 now has to be going where? The 5 now has to be going up to 8, right? Because the 5 can't get to 13. The 5's certainly not going to get to 21, but the 5's not going to land at 5 either. So the 5 needs a 3. So one of these 2 is a 3. So one of these is a 3. And then the 4, right, 4 can't connect to 8, because 4 plus 4 being 8 is not going to work. So the 4 can only connect to the 5, so the 4 needs a 1. This is a 1 and a 3. Okay. The 3 can't connect to 8, because that would require a 5. So then the 3 can only possibly connect to 5, so the 3 needs a 2. And the 1, well, it can't use a 2 anymore to get to 3. It can't use a 4 to get to 5, so the 1 needs to use a 7 to get to 8. Oops. And then hopefully there's a digit I can fill in here. 1, 2, 3, 4, 5. There's a 6. And 6 works. So we have our first digit. We have a 6. Because the 6 is here, and we confirm before... Sorry. Zach was pressing into the microphone. before we let Zach dance, we confirm that the 6 here, plus 2 is 8, and plus 7 is 13, and so it works. Oh, by the way, do you have a bet cell, Malcolm? But in the meantime, we can let Zach do his famous 6y dance. Thank you, Zach. It is very cool that this is a thing that works out that you can do. Okay, so I'm now interested in this cell. Because this is a cell where there have to be 3 different numbers I can add to it to get to a Fibonacci number. So this digit can't be very large. So, for example, if this digit were a 5, it's already too big. So this digit's at most a 4. Does 4 even work? 4 would work, because 4 could have a... No, 4 doesn't work, actually. 4 doesn't work for the amusing reason that 4 plus 4 is 8, and I can't use 4 twice. And so the only Fibonacci numbers 4 could connect to could add to are actually 5 and 13, so 4 doesn't work. What about 3? 3 can connect to 5, 8, but not 13, so 3 doesn't actually work either, because I can't use a 10. 2 could connect to 3, 5, and 8, adding 1 to get to 3, 3 to get to 5, and 6 to get to 8. And then 1 could work as well. I believe in you, Zeta. You can use a 10 if you really try. I probably could. The real problem is that when you try and write 10 into a cell, it comes out as 0, 1. But I'm sure we can get that fixed. All right. Row 6, column 1, bet cell, I am told. That is the bet cell. Oops. Place your bets now as to what Fibonacci number this will end up being. It may or may not end up being a Fibonacci number, but it would be sort of sad if it didn't. But 0 is a Fibonacci number, I agree. I think of all the choices you can make for where you start your Fibonacci numbers and how you start your indexing, I think the best way to do it is to say that the 0th Fibonacci number is 0 and the first Fibonacci number is 1, and then go from there. But it's one of those unfortunate things where people sometimes choose to start with 0, 1, and sometimes choose to start with 1, 1, but then sometimes they call the first thing the 0th, and sometimes they call the first thing the first, and so there's like 16 different ways that you can index the Fibonacci numbers, but 0th is 0, first is 1, then everything works out nicely. I mean, as nicely as it's possible for an indexing problem to work out. So, an interesting thing to keep in mind is that 8 and 9 have this problem that they only connect to one thing. So I could never put an 8 and 9 here, for example. But unfortunately, this is sort of a squat little thing, so I could put an 8 and a 9 here. It would just put the same digit there and there. Like, a lot of these are sort of engineered, seemingly, so that 8 and 9 can just skate by. 8 and 9 in this row can only go in those cells. Oh, okay. No, never mind. So let's see. Okay, so if this is a 1, maybe I should just write this in. If this is a 1, then the digits that I'm using here are 2, 4, and 7. And if this digit is a 2, then the digits I'm using are 1, 3, and 1, 3, and 6. Okay, so 1 and 2 are always involved, I guess. That's one of the morals of the story that we have. All right. Yeah, 4 can only go with 1 and 9. Let's see. Maybe I should take a second to pull up. Let me drag Rank's fancy graph over onto the over to the screen on one moment while I figure out how to put the graph on the screen. Wrong screen thing. There we go. Oh, sorry. Puzzle back. I am figuring out how to drop this thing in here. Okay. So, in lieu of the rules, I think it's probably more helpful if I include this picture for you. So, this picture is showing you the possible legitimate relationships between the numbers. So this is exactly like the graph that I showed you earlier for the Kropki thing. But we're missing a couple loops. We'll have to keep in mind that 1 + 1 and 4 + 4 are acceptable. Oh. Haha. Because I downloaded something, and so it popped up a thing at the bottom, and then that shrunk the grid. Good eye, Tristan, for even noticing that. That was a good spot. Okay, so let's see if we can do anything useful with this. Maybe, possibly. I think we'll probably be okay without. We'll remember the 4, 4 and the 1, 1. So yeah, and so you can see very clearly in this graph why it is that this cell's a 1 or a 2, for example. Because if you look in the graph, the only two vertices that connect to 3 different things are the 1 and the 2. And that is that's obligatory here in order to make that happen. So what though am I supposed to do with this? It is not clear to me yet. Well, I can say this one isn't a 6. I can go that far. It's not a 6. Let's see. Okay, maybe I'm supposed to ask where 8 and 9 go in this column. Because 8 and 9 in this column can't go in any of those spots. So there's only 3 total spots for 8 and 9 in this column. Let's see. It's 8 and 9 in row 1. One of 8 and 9 at least has to be in row 1, so it's going to have to go with a 4 or a 5. But unfortunately, like 8 and 9 could even go here. Yeah, the 1 and 2 are only in these cells. I don't yet know what I'm supposed to do with that, but it is true that 1 and 2 are corner marked to these, and it is worth recording it. Let's see. Row 6, column 5. This cell. Okay, so that's actually fairly interesting. Okay, so let's go by this one by one. So can this be 1? Well, 1 connects to 3 things. It connects to 2, 7, and 4. So this can't be a 1 because this can't be. These can't both be from 2, 7, 4. So this can't be a 1. Can this cell be a 2? Well, 2 connects to 1, 6, and 3. Oh no, 1 connects to 1. Darn it, I said I would remember that. Right. If this is a 1, then this is a 1, this is a 1-4 pair, is how that works. If this is a 1, this is a 1-4 pair. If this is a 2, then this is sort of open season. This can't be a 3 at all, because 3 doesn't connect to 3, and 3 connects to 2 and 5, but there's already a 2 in the box. 4, this could be a 4 if these are a 1-9 pair. 5, this could be a 5 if these are a 3-8 pair, I suppose. It can't be a 6. If this was a 7, I would need a 1-6 pair, but I can't do that. If this was an 8, I would need a 5-5 pair, but I can't do that. And if this was a 9, I would need a 4-4 pair, and I can't do that. So this is 1, 2, 4, 5. Okay, SPQ says if I look ahead one step further, this being a 1 doesn't work. So if this is a 1, then these would have to be 1 and 4. And so then the 4 now... right. And so now whichever of these is 1, 4 is also in the box, but so are 2 and 7, and so the 1 can't connect to anything. So that can't be a 1. That's a very good observation, and a very cute reason why. Okay, so this is 2, 4, or 5. Yeah, so if this is a 2... Yeah, that's annoying. If this is a 2, there's lots of options. I guess if this is a 2, this is a 1-3 pair. So... Okay. Here's an interesting point from kuraban. I need to be able to make a 7-long string of digits. And so the digits I put on these two outie sides, they essentially remove that node from the graph. And if the graph that they leave when I remove that node from the graph does not have a sort of string of 7 digits together, I can't use it. So these digits on the outside, they can't be 1, for sure. They can't be 2 either. They can't be 3 either. They could be 4. Or 5. Or 6 or 7. Or I think they could be 8 or 9 as well. But they can't be those sort of middle things. They can't be 1, 2, 3, or 4. Sorry. They can't be 1, 2, or 3. But they could be an 8-9 pair, for example. Or a 4-9 pair, or there's some other combinations. But that's interesting, because it means there's definitely a 1 on the line. And there's definitely a 2 on the line. And 3. There's definitely a 3 on the line. Which has to connect to a 2. So there are many options, but there is some more restriction than it initially seems like, which is very worthwhile to know. Let's see. Josh says the center digit of the line is fairly restricted. So if I walk 4 steps along here and I have 4 to go, where could I be? I feel like I'm going to get a very similar number of candidates. Let's see. Let's see. Jay says it's only 2 or 7. That's right, because it can't be 6. The fact that it can't be 6, I think I had neglected. I believe it can only be 2 or 7. It's very messy. But I guess it's a matter of, like, look at nodes that have 3 things in each direction. So it can't be 8 or 5 or 3, because that doesn't have, those don't have that. It can't be 6. And it can't be 1. So yeah, it is 2 or 7. Okay, I agree with you. This is a 2 or a 7. Right. Okay. Yeah, I agree. Okay, it's not actually as bad to see as I originally thought it was going to be. So here's an interesting observation from... Oh, maybe not. I was going to say, so one of these is a 1, but I don't think that's necessarily true. One of the surrounding ones. Yeah, so 1, 3, 6 around. I agree. These are from 1, 3, 6. Those are the only things that are adjacent to 2 and 7. Yeah, so the surrounding cells are only 1, 3, 6. See, I'm trying to think if anything breaks if this is a 2, which forces this to be a 7, which forces this to be a 1-6 pair, but if anything breaks from that, I don't see it. It doesn't need to always have a 1. The 1 could be further away. If the center digit's a 2, then the sides could be 3 and 6. Will I color the pairs in row 9? I don't really want to, because it's not symmetric. That is my my reason for not doing so. Oh, are you having me write in these where these can be? Let's see. So should I now think about this cell? Is there some restriction on this cell that I'm not appreciating? So I think this could be a 5. Yeah, I think thinking about this is the question. So possibly, maybe. No, I don't think this can be a 1. It's horrible. If this is a 1, then look what happens to the graph. Then I need to have a, well... Sorry, maybe I'm wrong. No, I think I'm wrong. Yeah, 8 and 9 is certainly restricted to these. I agree with that. Oh, let's see. Jay is saying this can't be 1, 2, 3. I agree. This can't be 1, 2, 3. Right. Okay. So if this is 1, 2, 3, that completely breaks the graph of what we have left into 3 separate pairs, which does not work. And so if this can't be 1, 2, 3, then either this is a 2 with a 6, or it's a 7, which has to have a 6. So the point is there's always a 6 at one of the ends of this. So there's no 6 over here. And now whichever side has a 6, it means the other of 2 and 7 is in one of these places. So, because 6 is flanked by 2, 7. So one of these two is 2, 7. So these aren't 7 either. So, because, yeah, one of these is 2, 7. I don't know which yet. I need a 4 or 5 on this line for sure. Because of this line, Jim. If these were 1, 2, 3, this line couldn't be anything. Which I don't think you could see without this graph that Ranksk made us, so I'm very appreciative to Ranksk for making us this graph, because I think it would become literally impossible without it. So yeah, one of these is a 6, one of these is a 2, 7. So there's always a 7 on the line. It's just in a number of spots. Okay. Oh, right. So that means that we do dump into the quadrangle, as Ambrose puts it. So we do need to use 6 and 7. And so the string we get basically breaks that stray connection that is not allowable. So the 1 to 2, I'm not allowed to use 1 connecting to 2 anymore, is the basic point. So if this is a 2, then these are a 3, 6. And I'm never allowed to use the 1, 2 edge. Okay, so that means I can sort of write out the possibilities, although there's still a lot of them. But if this is a 2, then one of these is a 6, and then one of these is a 7, and then one of these is a 1, and so on. That's a mess. Okay, I don't really want to write it all out, because I think there's 4 possibilities for all of these cells, but they are semi-limited. Okay, if this is a 5, asks Doomdiat, doesn't that force 2 2s into box 8? If this is a 5, it makes these a 3, 8 pair. The 3... What's the 3 going to do? Ah, okay, I think Doomdiat is right. If this is a 5, these two are a 3, 8 pair. The 8 has to go with a 5, because 5 is the only thing that goes with 8. But now what does the 3 go with? Well, the 3 can't go with a 5 anymore, because the 5's over there. And the 3 also can't go with a 2, because the 2's already in the box. So, right, this can't be a 5. Okay, I believe that. That is very cool. Okay, is there any chance that this works on the other side if I push it? 4 has the same issue, says Ranks. That would be great. If this is a 4, then these become a 1, 9 pair. The 9 needs to go with a 4. And then the 1... needs to only go with a 2 or a 7, but we've got a 2, 7 pair. Gorgeous. Okay, so can't be a 4. So this is a 2. Okay, that's going to do a lot of damage. Because now that's a 7. That's a 1. Let's just delete all these pencil marks and start again. 1 connects. That is a very cool observation. 1 connects to 2, 7, and 4. Except this one's not a 2 or a 7, so it's a 4. So these are not 4. Those are 2, 7. So now this is a 7. What does 7 connect to? 7 only connects to 1 and 6, so there's no 3. And then the 1 and 6 connect to 2 and 4. So now we can fill in the rest of this. So the 1 and 6 connect to 2 and 4. And the 2 and 4 connect to 3 and 9. And so these are not 4 or 9. It is a 5, 8 pair on the outside. Oh no, 4 can connect with 4. Yeah, we should go back and try 4 with 4. Oops. 5 with 5 doesn't work. 4 with 4. What if 4 goes with 4 in here? Then we'd have 4 with 4. And say 4 with 4 and 1. 4 with 4 and 1. The 4 would then have to go with 9. Yeah, so we're just going to have to write this in. I don't think there's any way to do this. Okay. So the 4 here, if one of these is a 4 and one of them is a 9, that immediately breaks because 9 needs to connect to 4. So the other one has to be a 1. And so now 4 only connects to 1 and 9. So this is a 9 now. And now 1 connects to 4 and 7 and 2, all of which are gone. So yeah, so that does break. Albeit that is definitely several iterations past bifurcating, but we're going to take it. So these are gone. So 1 connects to 2, 7, and 4. This is the 4. These aren't 4. 7 connects, but good spot to whoever pointed that out. The 7 there is connected to 1 and 6 and not 3. 1 and 6 connect to 2 and 4. And 2 and 4 connect to 3 and 9. So these are not 9 or 4, 9 or 4. They're 5 and 8. This 2 can't connect to 2. I do need to make sure I'm always trying to do that. So 2 connects to 1, 6, and 3. So this is a 1 and a 3. 1 connects to 4 and 7 and 2. So the 1 here can't connect to 7 or 2, so it connects to 4. So one of these two is a 4. And the 3 connects to 2 and 5, so that's got to be a 5, because there's already a 2 in the box. So these are, let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are 8 and 9. So these are 1, 2, 3. We need a 3. 4, 5? 3 and 5? Okay. So which is it? Is it 3 or 5? If it's 3, we break, because we need a 2. So this is a 5. 5 is adjacent to 3 and 8. 3 and 8. And so now what's left in this box is 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 and 9 is what's left in this box. That being a 5, by the way, did make that a 3. Let's see. Okay, so 4 and 5 are connected to 8 and 9 and 1 and 3. So these are from 8, 9, 1, 3. 8, 9, 1, 3. I believe. Let's see. these... Okay, 2 and 7. What do 2 and 7 connect with? Neither 2 nor 7 connects to itself. I need to keep reminding myself. Right, okay. So Ranks has a good point. Where do 8 and 9 go in this row? Well, not there, because 8 and 9 don't connect to 2 and 7. So 8 and 9 go outside, and 8 and 9 only connect to 4 and 5. And so then we get a pair here, the Ranks pair, if you will, that is 1 and... Oh, I put 6 when I meant 5. Let me fix that. These are a 1 and something else. 2, 3, 4, 5. A 1 and a 6. And so then we ask what 1 and 6 connect to. 6 connects to 2 and 7. And 1 connects to 4, 7, and 2. It's kind of a mess to include. 8 X-Wing. Rows 5 and 9. Beautiful. Okay, so yeah, there is an 8 X-Wing, so 8 in both row 5 and 9 is in one of these places, and so that means that the 8 in column 1 and column 9 is in one of these two places. So these aren't 8. So these aren't 5. Good spot. I guess this is only, if I really want to write it, it's not actually that bad. It's only 2 or 7 or 4. Okay, do I want to fill in these digits? That seems like this is just going to make this even worse. Okay, so maybe I should look at what these can be, since the 3, 5, 8 is gone. No, I don't think that restricts it enough. We do get a nice little constellation shape, but I don't think that's quite restrictive enough. Yeah, this line is the disambiguator of everything. It seems. Let's see. X-Wing on 1s in column 3 and column 7? In row 1 and 9? Okay, row 1, row 9. Right, okay, so the row 1 1s and the row 9 1s are in these cells, and so that must absorb the 1 from column 3 and column 7. So neither of these can be a 1. So one of them is definitely a 3, because they can't be an 8-9 pair, because that actually gives us a 3-8-9 triple. That's awesome. Great spot, Kuraban. So we can fill in this quadruple. These are a 1, 2... Let's see, we've got a 3, 4, 5. We need a 6 and a 7. These are from 1, 2, 6, 7. Sure. Okay, so Ranks is suggesting we look at what this can be. So it can't connect to 3, 5, or 8. So just imagine that whole portion of your... well, sorry, it has to connect to something that's not 3, 5, or 8. So you can imagine that whole portion is gone. But then it also has to connect to something that's not 4. So, in other words, this can't be 9. It can't be 3, 5, or 8. So let's pencil mark the digits that aren't 9 or 3, 5, or 8, and then let's look at it one at a time. So if this was a 1, I think it could connect to lots of things. If this was a 2, I think it could connect to lots of things. If this was a 4, I think it could connect to lots of things. If this was a 6, I think it could connect to lots of things. If this was a 7, I think it could connect to lots of things. So I think it's possible that 9 is the only digit we lose, but hey, I'm going to take every digit I can. So same argument over here. This is 1, 2, 4, 6, or 7. Oh, right, there's an X-wing. Oh, no, sorry, I can't connect to 1 either. These can't be 1. So let's see. So if we take into account that these can't be 1, because remember, one of those is 1 in the column, then now, if this is a 4, because I can't put a 1 here, I could put a 4 here and a 9. Oh, no, sorry. If this is a 4, I can't put a 4 in either of these places. So, right, can't be a 4. So 1, 2, 6, 7. I agree. I don't see how we're going to use the line that breaks the symmetry. I don't think we know nearly enough about it, do we? No 7 either. Ah, right, because 7 only connects to 1 and 6, and we can't use that. Okay, so these aren't 7s, I agree. 7 would need a 1, and the 1 X-wing does that. If it's a 2... Ah, okay, beautiful. Okay, if this is a 2, I like that. If this is a 2, these are from 1, 3, 6. But that would put a 1, 3, 6 quadruple in the column. So these aren't 2. These are a 1, 6 pair. Okay, that's very clever. So now, let's write out what these cells can be. Because now we've got a quintuple in the row. So they can be 2, 4, 7, and 9. Okay. Which of 2, 4, 7, and 9 connect to 1 or 6? 2 does. 4 does. 7 does. 9 doesn't. So these aren't 9. And now, because those aren't allowed to be 9, one of these is 9, one of these is 9, and one of these is 9, and we get an X-wing on 9s, which rules 9 out of these cells, which now rules the 4 out of these. This cell can be 1. Right? No, it can't. Right, because there's 1s in the column. I will eventually remember that there's an X-wing on 1s in this column. So what are these 2 cells? So these 2 cells are the cells that connect to 1, which are 2, 7, and 4. And the cells that connect to 6, which are 2 and 7. So yeah, these are 2, 4, 7, and those aren't the 4. So these are 2, 7. So yeah, so one of these is 4 in each case, and that is a 2, 4, 7 triple in the column. Sure. 2, 4, 7, almost a 2, 4, 7 triple in the box, but not quite. Okay, so... Oh no, this could be 2, 4, or 7. This has to connect to something that's not 2, 4, or 7, but that's not so big. Okay, so I'm looking at the graph, actually. What can this cell be? It has to connect to something that's not 2, 4, or 7. So it's not itself 2, 4, or 7. It's not 1 either. It's not 6 either. So I think this cell is only 3, 5, or 8. If I look at the graph. And so you can write in the options here. If this was an 8, then this would be a 5. If this was a 5, then this would be a 3 or 8. And if this was a 3, then this would be a 5 or a 2. But it can't be a 2 because there's a 2, 7 pair in the row. So actually, these are both from 3, 5, 8. Which means that this can't be 8, 5. So we get another digit. This is our first digit in a long time. This can't be 8, 5 because that's too many 3, 5, 8s in the box. So this is a 9 and a 4, and an 8 and a 5. This, therefore, is not a 4. That is a 2, 7 pair. This isn't a 4. This is now an 8. So that is a 9 and an 8. And the 9 connects to 4. 4 connects to 1. 1 connects to 2. 2 connects to 6. 6 connects to 7. 7 connects to... Wait, what? I screwed it up. Nope, I screwed it up. What did I do? 9 connects to 4. 4 connects to 1. 1 connects to 7, then to 6, then to 2, then to 3, and then to 5. I don't know why I screwed it up the first time. These aren't 1 anymore. Yeah, I just have to stop trying to think and just look at the graph. I think that is the key to the puzzle. So we now have an 8-9 pair in this row. So the 8-9 pair in the row gives me a 3 here. 3 doesn't connect to 4. 3 only connects to 5. 5 doesn't connect to 1, so that's a 3, and that's a 1, and that's a 4. And 4 is not connected to 8, so 4 is connected to 9, 8 and 9. This 3 comes up here and makes that an 8 and a 3. The 1 looks up here and says that's a 6 and a 1. That 4 makes that a 9 and a 4. That 2 makes that a 7 and a 2. The 1 here actually connects to 2 or 4. The 6 doesn't connect to 4. The 6 only connects to 2, so that's a 4. 4 doesn't connect to 3. It connects to 9. 9 comes over here, makes that a 3. This isn't a 2. Sorry, that's a 7 and a 4. 7 and 4 are both connected to 1, but not to 6. So that's a 1. That's a 6. This isn't a 4, of course. That's not a 4. Or a 9. It's a 2 or a 7. So that's a 9. That's a 5. This is not a 3. That 7 looks over here and makes that a 2 and a 7 and a 2. The disambiguation thing was very satisfying. The 1 here goes up here to make that a 6. This is not a 2, nor is it a 4, so it's a 7. So that's a 2. So this could be 1 or 6 still, actually. Oh, but it's not a 6, so it's a 1. These two digits over here are a 3 and a... something else? 3 and a 6, I want to say. So this isn't a 6. This isn't a 1 or a 2. It's a 6 or a 7. This isn't a 6 or a 7, so it's a 2. So that's not a 2. That gives us a 6-7 pair in the row, which means that this is not a 2 or a 6 or a 7, so it's a 1. So 1, 2, 3, 4, 5. Let's see. So these are 6, 7, 8. That's not a 7. That's not a 6 or an 8, so that is a 7. This isn't a 7. This can't be an 8, because 8 only connects to 5, and there's already a 5 in the box, so that's a 6. So that's an 8, so that's a 5 and an 8. This digit I should be able to figure out in a multitude of ways. I think it's a 2, just by the column. 6 and 2 do indeed add to a Fibonacci number. It's a 7 and a 6. 2, 3. Okay, so this is a 4 and a 6 left in the box. So that's a 4 and a 6. Over here, we've got 1, 2, 3, 4, 5, 6, 7, 8. This is a 5, because it's not a 7 or an 8. So these aren't 5. This one's not an 8 either, so it's a 7 and an 8. 7 connects to 1 and 6. This isn't a 6, so it's a 1. Let's see. This isn't a 1, 2, 3, 4. So I believe this is a 5. So this is 1, 2, 3, 4, 5, 6, 7, 8. This is a 9. These digits are a 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, so these aren't 4. So that is 4. That 1, 3 pair looks over here and makes that a 6 and a 3. These are a 5 and an 8. So that's a 5 and an 8. These are a 6 and a 9. So looks like that. Nice. This 1 comes up here and makes that a 3 and a 1. Scan for coloring real quick. And then this is a 3. Fascinating discovery. I really enjoyed the disambiguation at the end, but also I think this would have been a nicer experience if it was disambiguated immediately, rather than making you do this. Like the keeping track of all the symmetry, I think, was very tricky for sort of like a first go round. Like I think if I was doing this, I would have made the break-in, putting a 9 here and this line down here, and made someone figure out that, oh, hey, that tells me that I know exactly this entire row, and then worked from there. Just to make it a little easier to wrap your brain around at the start, and then be merciless in your follow-up puzzle. Fibonacci Fountain 2. Electric Boogaloo. But that's a very cool idea, and this is certainly a lot trickier than I was expecting it to be when I first looked at it. So neat puzzle. I enjoyed that. I'm going to take a quick break, though, and then we're going to come back, and we're going to do another puzzle. I'm doing good puzzles today. It has been fun. Oh, I'm going to remember to remove the Fibonacci graph. Otherwise, it's going to sit there forever. There we go. It's gone. Let me... All right. I'm going to take a short break, and then I will be right back with more stuff. Welcome back, everyone. Have an irregular killer here. Oh, thank you. Malcolm donates £5 and says, of course, thank you for featuring my puzzle. I make these to be solved, and it's great to get them more visible. Yeah, I know it's always tricky when you're sort of starting out, because now there's so many puzzles and so many great stuff. It's hard to sort of like get enough people to do your puzzles that then they get rated, that then more people do your puzzles. It's a whole thing. But yeah, I'm happy to feature that, and I am betting I will do more of your puzzles in the future. The nice thing about this is I haven't even read the rules yet, and I already have a digit. So we have a regular Sudoku, so we still need to put a 1 through 9 in every row and column, but then instead of boxes, we have regions. So for example, this is the digits 1 through 9. These are cages. Again, they have to sum to this total without repeating. This circle is the sum of these two digits. It's also the sum of these two digits, and the sum of these two digits, and the sum of these two digits. And these digits are in a ratio of 1 to 2. These digits are consecutive. It starts all possible dots are, and then not given. I would not have put those words in that order, but not all dots are given. I was going to be like, wait, there's a negative constraint in this puzzle? But no, there's no negative constraint. Okay. So the digit I see is this, because this region needs a 9 somewhere, and there's only one place it can possibly go, which is here. And so we can bring in Zach to do the much coveted dance of the 9s. Thank you, Zach. Much appreciated. Oh, we need a bet cell. That's right. I'm going to bet FinnishGuy is asleep based on the name. Yeah, the bet cell's the one with a circle in it. Perfect. Let's see. This looks kind of out of the way. Let's make that the bet cell. All given dots are possible. I like it. Okay, so other things I notice. A 7 cage is in 3 is 1, 2, 4. This cage does absolutely nothing. It bothers me. Let's see. Like, there's all these 9 cages, and so, of course, there's lots of interesting options for 9s. I mean, there's so few dots, it seems incredibly unlikely that this was intended to have a negative constraint, but who knows? It does provide the symmetry, that's true. Let's see, I'm trying to sort of appreciate this region. This region looks like an F. Let's see. Am I going to have to do a law of leftovers thing? Like, I see that these two cells are these two cells right away from law of leftovers. These 3 cells are these 3 cells. Okay, I bet that, but down here might be useful. Yes, I think this is useful. So, possibly. Let's look at this region. Where did these 3 cells go in this row? Well, they have to be in the 10 cage. So these 3 cells, I'm going to make them green, they add to 10. So the green cells over here in this 10 cage, they are the green cells over here. Is that interesting? Well, it means that these 3 cells add to 8. Because together, the 9 cages, of course, add to 18. So these add to 8. So one of them is a 1. doesn't unfortunately mean that none of the green cells is a 1. Yeah, so one of these is a 1. Oh, there's another place I can apply the same thing that's even better. Namely, this F also tells me these purple cells are these cells. That's a little bit better. So this is the better F. So I can just write out the 3 possibilities. If this is a 1 and a 2, this is a 7. Well, that's not going to work because there'd be no way to fill this. So this is not a 1 and a 2, which means this is not a 4. So progress. If this is a 1 and a 4, this is a 5. And if this is a 2 and a 4, this is a 4. So this is a 4 or a 5. Well, I did get that it worked for all the F regions, but I didn't realize that there was another one with cages. But yeah, certainly, like, this is rotationally symmetric. Oh, you're right. 2 and 4 with 4 doesn't work either. Because of the fact that all the purples are in a region together, right? So if this is 2 and 4, then I need another 4, but that would mean that this was 2, 4, and 4, so that doesn't work. So this is in fact 1 and 4 with a 2 there, a 5 here. This is a 1, 4, 5. These two need to sum to 4 now, so they're 1, 3. So this digit's a 6, which now makes this a 1, 2, which makes this a 3 and a 1, and this is a 1, 3, 6. There we go. All right, so we're cooking with something now. This 1 looks up here and gives me the 4 and the 1. I think these colors can now, unfortunately, go away. As much as they brighten up the grid, but probably not in a way that is presently useful. Okay, there's a 1 in this F already, so that's not a 1. Oh yeah, I can do it in column 8. Heyo. So these, again, are... Well, I'm going to just get rid of that and say that those 3 are these 3. So this is a 7, is the upshot of that. And these are a 1, 2, 7. So that's not a 1. Oh, the 1 in column 3 also looks down, yes. So that's a 3, 6 pair, so that's a 1. Which means that this 9 cage is a 2, 3, 4, because that's the only way to make 9 without a 1. That's not a 4, that's not a 3. These two need to sum to 8. Without using a 2, 6 or a 1, 7, so they have to be 3, 5. And so that tells me that this isn't a 5, because there's a 5 in the region already. The 1, 2 pair in row 6 actually also does something Andrew points out. The 1, 2 pair looks over here, so that's not that is a 4, so that's not a 4. Oh. Am I crazy? 1 and 4 are already in this region, so this is a 5. So that's a 3 and a 5. Right, this region just looks like this? Yes. So one of these two is a 5. That's not a 5. One of these two cells is a 5. This is a very smooth puzzle so far. Okay, so this is not 1, 2, 3, or 4. So this is 5, 6, 7, or 8. And so that means this is 1, 2, 3, or 4, except it's not 1, so that's not 8. Just to sort of keep track of what's going on with this 9 arrow. Let's see. Row 2, column 1 sees 5. Ah, right, it does. Right. So I need a 5 here in this column. It's not in any of these cells. Jay has pointed out also this 5 sees that cell. So actually, that's the 5, which is awesome. So these cells are 6, 7, 8, 9. That one's not a 6. 2, 3, 5. So even though this cage is fake, this really is a 2, 3, 5, because I do still need to put those over here. Good point. This isn't a 2 because of the triple below it. This black dot is looked at by a 2 and a 3, so it can only be 4, 8. So that 4, 8 looks over and says that's not an 8. This 2 or 7 needs to show up in one of those two cells, but I don't think I know which one yet. Let's see. The 17 cage has a bunch of options. I don't think I want to look at them yet, because I don't think I know anything yet, really. I know it doesn't have 3, 6... I know it doesn't have thing. Yeah, so this cell is this cell, because, again, these two cells need to find a home in column 1. So this is a 6, 7, 8, or 9, is what Ranks is pointing out to me, which is a very good observation. It's not an 8. And so because that's not an 8, this isn't an 8. And so one of these two is an 8. I don't know which one yet. Let's see. So what's left in this row? We need a 6, 7, and a 9, and a 1. Well, this one's not a 9. Unfortunately, I think it could be 1, 6, or 7, which would put 8, 3, or 2 here. I think all of those are okay. This one's not a 7. It is 1, 6, or 9, I believe. Fascinating. Okay. Someone says we've got row 6, column 5. Yeah, so this is a similar situation where 1, 2, 3, 4, 5 are gone. So this is 6, 7, 8. And so this actually can't be an 8 because that would put a 1 here. So this is a 6 or a 7, which makes this a 2 or a 3. Very good spot. I think it was Ambrose who said that a while ago, but row 8, the 1 looks right, so it does. So that 1 knocks 1 out of there. So now that's a 1. Which is sweet. Okay, so that being a 1 means the 17 cage doesn't have a 1 in it. Is that interesting? Probably not. No, there's only one way to do that anyway. This can't be 3, 6 either. Okay, so this is now very restricted because there's a 3 and a 6 in the column. It doesn't have a 1 on it. So this is from 2, 4, 8. And there's definitely a 4 in these cells, for whatever that's worth. Very little, I suspect. Let's see, if this was a 2, I guess there's even options. Regrettable. Let's see. Okay, interesting. So, Ranks is trying to shove 6, 7, 8, 9s into this column. And noting only one of them can fit in here. So there's 1, 6, 7, 8, 9 in here potentially. In fact, there's always 1, 6, 7, 8, 9 in here. There's none there. Oh, I guess the point is this is the 6, 7, 8, 9. Because there's 1, 2, 3, 4 here. Okay, so this is 6, 7, 8, 9. Sorry, I was looking at the wrong thing. Okay, so that means that these are less than that. These are from 1, 2, 3, 4, 5. And this one's not 1, 4, or 5, so this one's 2 or 3. Beautiful. That gives us a 2, 3 pair in this row. So that 2, 3 pair makes that an 8, makes that a 1. Makes that not a 1. Makes these two cells a 2, 3, 4, 5. Great spot, Sayori. A 6, 9 pair. I think I'm supposed to say something when that happens, but I've forgotten what it is. Okay, this is not the 3, 6 arrow, because it's got a 3 and a 6 looking at it. That I should also be looking at. So one of these is a 3, 6 arrow. So one of these two cells is a 6. One of these two cells is a 3. I don't know that that really does anything, but I just want to note it. So these cells are these cells. So these cells are also 2, 3, 5. Oh, sorry. They're not even 5. There's a 5 in this region already. So these are from 2, 3, 6, 9. That one's not a 2 because of that. Or that. Take your pick. Sayori asks where 1 is in column 9. It can go here, but not anywhere else, because there's 1s in the bottom 3 rows. So this is a 1. So it's either 1 with a 2 and a 10. That doesn't work. So this can't be a 2 anymore, because 1 and 2 would only make 3. So that was huge. So this is a 1 and a 3 and a 9. So that 3 bounces over here and goes as a 2 and a 3. That tells me that this is the one that's the 6 and the 3. So this is not 3 or 6. This is also 2, 4, 5, 7, but that's not a 7, so that's not a 2. That's not a 5, so that's not a 4. This is a great puzzle. I really like this. I think often irregulars get a little bit ridiculous if they require sort of too much geometry, but just the right amount of geometry is very nice. And I feel like this is really in the like just the right amount of geometry category. Let's see. Row 6 only has 2 things left, is a good point. And one of them is a 7, which has to go here. So if that's a 7, then this is an 8, which makes that a 4 and an 8. This row only has 2 digits left in it. Let's fill them in. 2, 3, 4, 5. We need a 6 and an 8. Surely I can do that, right? Yes, this 8 tells me that this is a 6, and that's a 9. And so that's a 6 and an 8, and a 3 and a 6. That's going to have done lots of Sudoku stuff. This cage actually only has, this region only has 2 things left in it, which are a 2 and something else. 4, 5, 2 and a 9. So these are a 2, 9 pair. However that may roam. This 6 and 9 make that a 3. Good point. I think both Tony and Ranks were saying that. So that's a 5, a 2, and a 3. The 2 makes that a 6. The 6 makes that a 6. Because, again, these two are the same as these two. So these are not 6. So this isn't 6 either, because, again, these two digits are these two digits. It's a 7-9 pair in this region, which makes that an 8. Now I've got a 7, 8, 9, so that makes that a 6. Let's see. There are probably a million places I could look. Let's choose this one. There's a 2 in this region, so that makes that a 7 and a 2. Let's do that one first. Okay, what about these two cells? What are they? We've got a 1, 2, 3. We need a 4. And we need a 5. And we've got a 6, 7, 8, and 9, I hope. So these are a 4, 5 pair. And so these are from 4, 5, 7. To make that work. Strangely, I seem not to know anything about that. What about this white dot? It's not 1, 2, or 3. It could be 4, 5. It could be from 4, 5, 6. Or it could be... Oh, it can't be 8, 9. Okay, that's great. Oh, could it be from 7, 8, 9? Sorry, there's a 7 in this cage still. Never mind. I think this is very close to forced, but I don't think it's quite forced. Let's fill in... Okay. This is a 2 or a 9 by many ways. Take your pick of which way you would like. Yeah, so it's got a 5 or a 7 on it, I believe, is the punchline. But I don't think we know where it is yet. 5 in column 3. 5 in column 3. We already have a 5 in column 3. So 5 is over here somewhere is maybe the claim. 3 in row 9. Can 3 not go in a 17 cage? Looks like 3 can go in 17 cage. Would make that an 8. Not a 6. Oh, sorry. No, 3 can't go in the 17 cage because there's 3s looking at it. And so 3 in row 9 actually only goes here. That's a good spot. Yeah, there's no 6 on here. So this is either a 5 and a 4, which would go in that order. Or it's a 7 and an 8, which would go in that order. So we can at least pencil mark that a bit. Okay. Yeah, let's fill in these. So we've got a 1, we need a 2, we've got 3, we need 4, 5, we've got 6, we need 7, we've got 8 and 9. Hopefully some of this will help. That's not a 5. At the very least. Let's see, if this was a 2, I'd need 6 and 9 or 7 and 8. I guess I could do that. And I can't do 6 and 9, but I could do 7 and 8. Let's see. This is not a 5 or a 2. this could possibly be anything in the entire world. Unfortunately, I think it can. Let's see. Oh, 4 is on the black dot in row 9, right? We said that out loud, and then we didn't pencil mark it. So, like, that's not a 4, for example, and that's not a 4. So one of these two is a 4 for the column. Oh, so you want to note things like that there's no 3 in here? No 3, no 6. No 5 either. So, so there's always a 7 in this cage is the upshot of that. Let's see, what about this one down here? This one does not have a 6 in it. It doesn't have a 3 in it. So it's either 2, 7, 8 or 4, 5, 8. So it always has an 8 is the upshot. So this always has an 8. The 8 isn't there, so this isn't an 8. Row 1, column 5 is not 4 from the calculator. Oh, right, because the calculator just told us that you can't put a 4 here. So, as foretold, we accidentally discovered what the bet cell is. Bad form, but the bet cell is a 4 because we have a 2, 5, 7 triple. So if you bet 4, congratulations. Sorry for ruining the suspense. So that makes those a 1 and a 4. Let's see. 2, 4, 5 triple in column 7. 2, 4, 5 triple in column 7 indeed. Beautifully spotted, Garion. Makes that a 1 and a 2. Makes that not a 2. Makes that a 4, 8 pair. So that's going to do a lot because that 4, 8 pair is then going to give us a 7 and a 2 and a 4 and a 5. These two are now a pair. They are a 1 and a something. Well, the 1 goes there, which is going to be very helpful. So now that's a 1, a 7, and a 9. Let me fill in what this is. 2, 3, 4, 5, 6, 7, 8. This is an 8. No, not an 8. Bad Zeta. It's a 9. So the 9 there makes that a 7 and a 9 and a 7. So this row is missing now a 2, which has to go here, and an 8, which has to go there. This 2 looks down and makes that a 4, which makes that a 5, that an 8, that a 4, that a 5, that a 2. Let's use the killer calculator to figure out that this has to be a 7. This isn't a 4 or a 5, so it's a 7. That's a 5, that's a 4. That 2 looks down and makes that a 9 and a 2 and a 9. This column is only missing one digit, which is a 9. This region is now only missing one digit, which is a 3, 4, 5, 6, 7. It's an 8. This column is now missing only one digit. 1, 2, 3, 4, 5, which is a 6. And now this region is only missing one digit, Get your bets in now. It is a 2, not a 2. Let's try again. 1, 2, 3, 4, 5, 6, 7. It's an 8. And there we go. Very nice puzzle. I really liked the flow of that one. That one was that was a very neat, a little irregular. I feel like, again, that had exactly the right amount of irregular geometry for my taste in irregular geometry. I didn't have to highlight anything or anything like that, so it was. But I got to use a lot that, like, this L shape had the implication it did, and the placement of the 10 cages so that it interacted with the Fs is very cool, very enjoyable. And I am so much happier doing killer cage stuff now that I have a killer calculator. All right. I'm going to take a short break, and then we're going to come back, and we're going to do a short puzzle. So hold your horses. We'll do one short puzzle to finish up. Good night, Malcolm. Hope you have a good day and a good evening. And I will see you around later. Alrighty. One moment. I'll take a short break, and then I'll be back with something else. Alrighty, welcome back. Let's finish up with this anti-king arrow puzzle by grkles. So we have our arrows where we need to sum these digits in order to get the digit in the circle. Got that. And also it's anti-king, so I can't put a 9 next to a 9. Also known, I think it's Clover who likes to call these no-touchy puzzles. So this is a no-touchy puzzle. So let's try to do this. So right away, I'm looking at this and saying, okay, well, this has to be 6, 7, 8, or 9, because it is a sum of 3 different digits. Now, the slick thing is that because this is anti-king, these 3 digits all have to be different, which means this has to be 6, 7, 8, or 9 as well. This arrow also is anti-kingish, because these 3 digits actually all have to be different because of anti-king. And so those sum to at least 6. And so this is at least 7. And the same pattern applies over here. This is at least 7. Oops. I don't know why that suddenly became green. We won't talk about it. So these are from 1, 2, 3. Because these already sum to at least 6, and I need to not overflow the bank. This is from 6, 7, 8, 9. Let's see. Do I have to add these arrows together or something like that? That sounds this sounds like the kind of thing I might have to do. Well, maybe the easy thing first. One of each of these is a 1. Because they need to sum to 8 or less. So there's a 1 in each of those collections of cells. Does that do me any good? I don't know. If it does, I don't see it right away. Okay, these digits are all different. This digit sees all of these, and these all see each other, and that one through King's Move in the box. So that means that the sum of the yellow cells, which is also the sum of these two circles, has to be at least 15, which means that this cell is also from 6, 7, 8, 9. The fact that this cell is in here is really, really distressing. What's the biggest this cell can be? Oh, but that cell could be that cell. Well, this... I can at least fill in these cells are at most 5. Because these 3 cells need to sum to at least 1 plus 2 plus 1, which is 4. And so, in order to get to a maximum of 9, these have to be at most 5. Now that's going to push up the minimum of these two. Because if I look at what the minimum these all sum to is now, it's no longer 15. Because if these summed to 15, these would be a 1, 2, 3, 4, 5 quintuple. But now both of these two digits would have to go there, and that's not possible. So that knocks 6 out of contention from these things. These have got to be at least 7 now. Okay, so Andrew is suggesting some coloring. So it's not possible that all 4 of these digits are different. But all 3 of these digits are different. So this digit is not different. It shows up on this arrow somewhere else. Namely, it shows up exactly there. And by similar logic, this cell, which may or may not itself be green, I don't know, it shows up on this arrow exactly there. So this cell and this cell are also from 1, 2, 3. I'm just not going to highlight this one because I think it's probably green. But green in this box, at least, I know goes in one of these cells. Right. This 1, 2, 3 here sees this whole thing. So this cannot be a 1, 2, 3 arrow, so it's not 6. Sorry, it's not 6. Let's see. So it is being suggested that I should keep red and remove green. Red has become orange. I'm not sure I see why this has to be orange. That's a good question. Where does this go in this box? So this is going to be purple now. Where does purple go in box 5? Purple can't be on a length 3 arrow. It's not any of these. This is purple. So this is 7, 8, 9. So now where does this go in the box? Now this can't go in any of these places. Oh, no, it could go there. Darn it, it can go there. Oh, this one. This one. Where does this one go in this box? This one in this box can't go there, there, or there. Oh, no, it could go there again. Darn it. Nope. Don't know. Purple in box 8 is over here. Okay. Somewhere in this collection of digits, there has to be a digit that's at least 6. In fact, really, you want this to be 1 through 6, which would make 7, 8, 9, put 7, 8, 9 in the corners. I guess I don't know where the digit that's at least 6 is. So Garian's point is, we had highlighted these cells before. And Garian's point is, if we don't put orange anywhere in yellow, then what happens? Well, then yellow's minimum sum is 1 plus 2 plus 4 plus 5 plus 6, which is 18, which would require these to be double 9, which they certainly can't be. So orange does have to show up somewhere in yellow, and as soon as orange does have to show up somewhere in yellow, it has to show up there. Very good spot. Okay, and now that's going to let me figure out where this cell goes. Because now this cell has to go in this box. It can't go on an arrow of length 3. It's not purple. It can't go there. Green now has to go here. This is now the last 7, 8, 9. This is the 7, 8, 9 that's not green or purple. So I'm going to make this yellow. But now every 7, 8, 9 has a color. So this has got to be yellow, purple, or green. Oh, no, green can... No, green can't be on the purple arrow because green... because it's anti-king. So this cell is not the 7, 8, 9, and this can't be the 7, 8, 9. Is the answer it ranks. It was Garian's point of finding this 1, 2, 3 that sort of made everything work out. So what color is this? It's not purple and it's not yellow, so it's green. Means purple is over in one of those places. Yellow, I guess, is all over the place. The fact that one of these is 7 is very interesting. Yeah. Green can't be 7 anymore. If green was 7, this would be 1, 2, 4. Should make that a 3. Yellow does have to be in row 4 in box 5. I agree with that. Yeah, right. So if green is 7, this is 1, 2, 4, which makes this a 3, this a 3, and this a 3. And now these now have to be a 1, 2 pair. Which makes that the 4. And yeah, both of these see the entirety of that, is the point. And so this could not be 1, 2, 4. So that's not going to work. Oh, I see. Right. There's a much, much, much easier way. If green is 7, it's 1, 2, 4, which makes this a 3. But the point is, this is a 3 on a 7 arrow. So that does not work. Okay, so green is not 7. That is a much easier proof than the proof I found. 8 or 9. Okay, so the only way... Let's see. If orange is 8, can we overflow the... Sorry, if green is 8, can we overflow this thing? It seems suspicious, but maybe we can make it work. I have not done any sum combining yet, other than that. Yeah, I'm trying to decide if I absolutely have to do the whole, like, combine the two greens together thing. So all 5 of these are different digits, right? All 5 of these are different digits. Okay, that does work. Okay. Yeah, if green... So all 5 of these are on green arrows. It's that green arrow plus that green arrow. These sum to at least 15, because they're all different. These 2 digits are different. So that means they sum to at least 18, which means that green has to be at least 9. So yeah, we can just directly prove that green has to be at least 9 once we realize this little plus formation here. We don't even have to exclude that green is 8. We can just directly prove that green is 9. And if you look at what we just did with this little plus formation here, then we actually only could make this work if this is 1, 2, 3, 4, 5, and this is a 1, 2 pair. So orange is 1 or 2, and this is the other 1 or 2. That's not that, and these are all from 1, 2, 3, 4, 5. And now I have my 1, 2, 3, 4, 5 in the box. Also, there's a 1, 2 pair in this column, and this sees the 1, 2 pair. I'm going to color the other 1, 2. I probably am not going to need it, but I'm going to briefly. These 2 see both orange and blue, so they're not 1, 2. So these are 6, 7, 8. To finish the razzmatazz. This can't be an 8 because then it would be on an arrow that added to 7, which sounds bad. Yellow's not 9 either. Okay, so there's always a 3 in these cells, right? Because this is either 1 with a 3, 5 or 2 with a 3, 4. That's the only way this works. So there's always a 3 there. So that gives me a bunch of digits that aren't 3. Namely, all of those are not 3. One of these 2 is a 6. Row 2, column 1. Ah, good point. Ambrose points out this can't be 7, because the only way to make 7 is 1, 2, 4, and orange does not appear on this arrow anywhere. And orange is 1 or 2, so this is an 8. And there's definitely a blue on this arrow. That's worth noting, too, because if you try and make a length 3 arrow with neither 1 nor 2, then it does not end well for you. that way madness lies. So there is a blue in one of these cells, but I don't know which one. It could be that one. Let's see. It doesn't quite let me place blue in box 7, but what can you do? Yes, this certainly is not 5, because if this was 5, I would get a number that was not that. This can be 4 if these are 1, 2, 1. Is there a problem with these being 1, 2, 1? I don't think so. Okay, this is only a 5 if this cell is blue. But I think that cell can be blue. This can't be a 3 anymore. That's a good point. Because these again sum to at least 6. And so this now needs to be only a 1 or a 2. Interestingly, this 8 or 9 can only go here or here in this box. I don't know that that is immediately super interesting, but I am noticing it. Let's see, row 6, column 7 is orange now. If this is blue, right. Okay, so this is crazy. But if this is blue, this is now 4. And now this cell can't be 1 or 2. And so this is 4 plus 1 or 2 is at least 5, plus a number that's at least 3 is at least 8, plus another number. That doesn't work. So this can't be blue, or it breaks this arrow in a weird, crazy way. So this is orange, which does make this orange, because these two are the same. Weird. Very, very weird. Okay, so blue does need to show up in this pentad. So one of these two is blue. This can still just get away with being 4. I was just trying to look and see if I could identify where this had to go in my little plus sign that's a 1, 2, 3, 4, 5 quintuple, but I don't think I can identify where this has to go in the quintuple. I guess here's the interesting thing about this cell. The place it goes in the quintuple is on this arrow. So if this is a 4, it also puts a 4 over here. Is that a problem? I don't think so, actually. I think that's actually okay. Unfortunately. It can't repeat in box 5. Oh. Yeah, it can't repeat in box 5, but how do I know which of these two it is? Oh, it's not orange. Right, it's not orange. That was the thing I was missing. Okay. So yeah, so these two are the same digit. So that means this isn't 5. Got it. Okay. So these two are the same digit, but they're probably blue. Let's see. If this is a 5, then this is blue. It's 3, 4. Blue is 2. Okay, Sayori says to look at row 5, column 6, being 4. And in particular, what happens to the 9 arrow. So if this cell is 4, we know orange is 1. And so now orange is 1 over here. So this is 1 plus 1. And then I need these two cells to sum to 7. Without using a 1, because I've already used a 1 for orange. And so it would have to be 2 and 5. This is the universe where this is a 4. But then that's a problem, because then we put a 4 here and a 5 here, and this is now double 3, which doesn't work. And so if this is a 4, this ends up being a 5, and that breaks this. So this is not a 4, it's blue. Great spot to Sayori there. So this is not 1 or 2. This is 4 or 5. That probably means this has to be blue, because if this is not blue, then it's a 4, and this is a 5, and that's too big. So this is a blue. Okay, so this digit's at least 3. For whatever that's worth. How big can it be? It's at least 1 plus 1 plus 2. It's at least 4. So this digit's at most 4. And it's not 1 or 2. So this digit can only be 3 or 4. Hey, grkles, how are you? Now neither of these things is a 1 or a 2, people are pointing out. So this is a 7 or an 8. In other words, it's purple. Gorgeously. Zig has been treating me very nicely. This has been very pleasant so far. Oh, right. Remember, we said this arrow needs a blue, so the blue has to go here now. Thank you. Oh, it could be 9. You're right. It could be 9. Sorry, it can be 9, I think. This still has to be blue, though. It's a blue one, too. Yes, this could be 9. I don't know why in my head it saw a 9. In my head, this green 9 saw that, which probably doesn't, by most forms of Sudoku. So these are from 3, 4, 5 only. Oh, this can't be a 7, actually, because there's already a 3, 4 in the box. So this is not a 7, because if this was 7, it would need to be a 3, 4 pair, and it can't be. I know one of these two is blue, but I don't know which one. These are from 3, 4, 5, 6, I can at least say. Let's see, where is blue in box 7? Ah, good point. Blue in box 7 is placed here, because this arrow can't sum to 1 or 2. So blue by Sudoku is here in box 7. Good catch. One of these two is blue, but I don't think it does anything. Annoyingly, this can be 4-5. I know this 8-9 goes in one of these two places. But I don't know where yet. It's getting more interesting that it does that. Orange in box 7, Andrew points out, is ruled out of these cells and it's ruled out of the circle. So orange in box 7 is in one of these two, which means orange in box 7 is not over there. It's not there and it's not there. So that's orange in box 1. Good spot to Andrew. One of these two is orange. Okay, so Garian is suggesting I should look at what actually happens if this is an 8. So if this is an 8, then these are 3, 5. And that's a 4. But this is supposed to be summing to 7, and we know that's not possible if this is a 4. So yeah, if this is an 8, this becomes a 4, this becomes a 7, but now the minimum sum is 1 plus 2 plus 1, which is 8. That doesn't work. So this is a 9. So it's green. Great spot. So 9 in this box now is here. 9 in this box is over in one of these two cells. For whatever that is worth, I'll corner mark it. I do have a virtual 3-4 pair in this box. So if I fill in the rest of these... Oh, I know one of those is 1 or 2. These are not 1, 2, 3, or 4. These are 5, 6... Oops. These are 5, 6, 7, 8. So purple is in row 4 over here. That's interesting. So one of these two is purple, and one of them is blue. So this is actually, you can fill this in. This is a blue-purple pair. I know that people don't like me to put blue next to purple, and I deliberately separated blue and purple so that one of them was 7, 8, and one of them was 1, 2. But then reality conspired to make this a blue-purple pair, so apologies to anyone who does not like blue and purple being next to each other. This 3 rules out a 3 from there, which rules out a 6 from there. Which gives us a 3, 4, 5 triple in the row now. So that's not a 5. It's a 6, 7, or 8. And so these are from 6, 7, 8, 9. No, they're just from 6, 7, 8. Sorry, they're only 6, 7, 8. They're not 9. Let's see. Yeah, purple is in one of these two cells. 6, 7, 8 triple in row 4? Right, right. Purple is 7 or 8, so that's the last 6, 7, 8 for this row. So this cell is also 3, 4, 5. That completes our 3, 4, 5 triple here. So these digits are, well, we've got our 1 and 2 and our 3, 4, 5. So these are from 6, 7, 8, 9. Can I rule any of those out? Don't think so. Regrettably. 5 in box 4 is in row 4. Right, this is a blue-purple pair, so none of those are 5. So one of these is a 5. So this isn't a 5. If this is a 5, this would be a 3, 4. What's wrong with this being a 3, 4? Let's see, that 3, 4 is the same as that 3, 4, for whatever it's worth. Nothing immediately to me. Oh, there does have to be a 3 on this arrow, I should mark. There has to be a 3 on this arrow. Otherwise, this arrow sums to 9 already before I add that. So this isn't a 3. Speaking of very, very, very minimal deductions. I was trying to decide if I could color my 4 5s, but I don't think I quite can. Do I have any prayer of doing anything with this arrow as it currently stands? I mean, I know that 9 is in one of these two cells. Very suggestive that 9's going to end up being there, but who knows? I guess when this turns out to be 9, this is not going to be 9, and then I'm going to need to put a 1 on this arrow. 9 only goes 2 places in column 2, right? That's actually surprising to me. But it seems to be true. Oh, maybe 9 can go here. Never mind. Maybe 9 can go there. It's possible. Okay, I know orange in this box is in one of these two cells. Doesn't seem to help me right away. At least not that I'm able to discern. I wish there was some cell that saw all 3 of these so I could rule 3, 4, 5 out of it, but I don't think there is. These are blue and purple. So purple's in one of these two cells. Yeah, 9 only goes 2 places in column 3. It only goes in those places. If orange was 2, it makes purple 8 and yellow 7. So yeah, if orange is 2, it immediately makes purple 8. Makes this a 6. Makes that a 7. But then, right, okay. So if orange is 2, it makes both purple and yellow 8, I think is the way to see it. If orange is 2, then that automatically makes purple an 8. If orange is 2, those two sum to 4, and these two sum to at least 4, so yellow's an 8. So both purple and yellow immediately become 8 if orange is 1. So orange isn't 1, orange is 2. Sorry, so orange isn't 2, orange is 1. Blue is 2. Oops. Sorry, not those. These blues are 2. Gorgeous, gorgeous. Okay. And so now, this is a 9, so it's green, because it doesn't have a 1 on it. This is now forced to be a 3-4. This is a 5. It's not a 5. Okay. So... it still doesn't resolve the 3-4. But does mean there's a 2 over here. It does play... no, I was going to place green in this box, but green's already in this box. This isn't a 9 anymore. As predicted. So this is a green 9. So now this arrow needs a 1, which has to be here. This is the only place for an orange 1 on this arrow. But being an arrow that's not a 9, it requires a 1, so that's the orange 1. The orange 1 is down here somewhere, for whatever that's worth. If this arrow has a 2, it's exactly here. Good point to investigate 9s in column 3, because 9s in column 3 can only go exactly here. Great spot to Tony. And so now this isn't a 9 either. So this is the last 9. Oops, the last 9. So this can't be a 6 anymore, because if this was a 6, this would be a 4, and there's a 3-4 pair. So this is not a 6. This is the other 7-8, so this is yellow. That's big. And so that 7-8 looks over here and says that's not a 7 or an 8. Sorry, says that's not a 7 or an 8. And so this is a 5 or 6. I don't know which one yet. But it gives me an extra yellow in the grid, which seems significant. Pretty sure yellow can't go here, because if yellow is here, this would need to be a 1 or a 2, and it certainly can't be. So one of these two is yellow. I don't know which one as of yet. Right, and this 6, 7, 8 triple in row 5, neither of those two is yellow, so this is yellow. Great spot to Sayori again. So yellow is back to being over in one of these two cells over here. Yellow's down here somewhere. What can this total actually be? It's not 1, 2, or 3. It could be 4. Maybe. It can't be 5. I think it could be 6, 7, 8. Okay, what happens if this cell isn't 1? If this cell isn't 1, then it's at least 5. And so if this cell is at least 5, then this cell has to be a 3. This is interesting. The green 9 arrow is done. This one? row 5, column 4. Oh, this green 9 arrow. I see. Yes. This is a 5. I agree. So this is not a 5. So this is not a 4. Gives us a 5-6 pair. Oh, I knew this a long time ago, I guess. As soon as this was a 2, I knew there wasn't a 5 here. This is a 3-4 pair, but I didn't see it at the time. So this cell's not a 5 or a 6, at least. Add the 2 arrows in box 7. You need a 1. Oh. Yeah, so if these don't involve a 1, then this would be at least 2, 3, 4, and 5. So 2, 3, 4, and 5 is 14. And the question is, can these possibly sum to 14 or more? If they're a 7-8 pair, can't they? Is there a reason they can't be a 7-8 pair? Because if they can't be a 7-8 pair, then I'm missing something. Oh, it's because this can't be 3 or 4. Okay, so what's the actual minimum? It would be 2 plus 5 plus 6. 2, 5, and 6 is 13. Plus 3 is 16. Right, and 16 I can't do without a 9. So yeah, so if you really carefully do this, if you look at this 3-4 pair, then if this isn't a 1, the total of these 2 arrows is too big. So this is a 1. No huge surprise there, but we get our last one over here. Great spot, Ambrose. Okay, so this digit is a 3, a 5, a 6, or a 7. Let's see. If this is a 5 or a 6, then the sum here is 11, 14, and I need to make these sum to exactly 14. So if this is a 5 or a 6, then the sum here is 14, and the only way I can do that is with an 8 and a 6. So this can't be the 6, in other words. Because if this were a 6, it would make that be a 7 and make the total need to be 7 and 7, and that's not going to work. So I can at least knock 6 out of there. This being 7 doesn't work, because if this is a 7, it makes yellow 8, but it also makes this digit 8. So this is not a 7. So this can only be a 3 or a 5. Once this is only a 3 or a 5, this cannot be a 7 anymore, and it can't be an 8 anymore. This is only a 4 or a 6. Oh, I'm being asked to contemplate the nature of 2s in column 7. 2 can't go here or here or here, so 2 goes here. That is a great spot. Oh yeah, this being 5 also breaks for a more comical reason, which is that if this is 5, this digit's 6, and this digit's 6. So this is a 3, which makes this a 4. Good spot. It might have taken a bit before I got there. Let's see. So these are not 1, 2, 3, 4. We need a 5 and a 6, and a 7 and an 8. That one's not a 5. I can tell you that much. So now we can place the 3 in box 1. It has to go here. Thank you, Sayori and Perla. One of these two is yellow. I still don't think I know which one. That 3 sees this by Anti-King. Great spot to Screaming Ice Cube. So, this is a 4 and a 3. Which now, okay, that's finally going to do it. Because that 4 gets us over into this box. So that's a 3 and a 4. So that a 5 and a 6. That 3 now lets me add this arrow and get that yellow is 7. So this is 5. And so purple is 8. So this is 7. So it's yellow. So this cell is a 6. Okay, great. So now this is a 2-8 pair over here. I don't know the order yet, but it is a 2-8 pair. This isn't a 7. Okay, so this row, let's go ahead and fill in. So we've got 1, 2, 3. We need 4, 5, 6, 7 is what is left. So this arrow in particular can't be a 6. It's an 8, so it's purple. You can't put a 7 or a 6 on an 8 arrow. You can only put a 4 or a 5, which makes this a 2 or a 3. I don't know which one yet. This isn't a 5. Oh, it's not a 4, though, because of that 4. So this is a 5 and a 2, which makes this blue. Makes this not blue. Makes this not purple. So this is an 8 and a 2. Not 5, not 5. Not 7. Okay, so what's missing in this column? We've got 1, 2, 3. We need a 4 and a 5 and a 6. And then we've got 7, 8, 9. Yep, 4, 5, 6. So that's not a 5 either. So that is a 5. This, spoiler, not 5. This isn't a 7. Let's see. This column needs a 3. We've got a 4, 5, 6, and we need a 7 and an 8. Well, that one can't be an 8. This box needs a 3, 4, 6, 7. Can be any of them. This box needs a 3, 4, 5, 6, 8. But these aren't 5. That's not a 5. These aren't 6 either. These aren't 8. That's not 8. These are all not 4. Very close to getting somewhere. This isn't a 3 because of that. Good. Oh, this 3 actually sees that, so that's a 4 and a 3. That's big. Okay, so that 4 now is going to shake out all of this. Because that's an 8, so that's a 3. So none of these are 3. That's a 5, 6 pair, so that's a 4. That 5 actually sees that cell by King's move. So that 5 gives me a 6 there. So this is not a 3. This is not a 6, which makes this a 7, 8 pair. Let's see. This 4 sees this 6 by King's move, so that's a 4. So these aren't 4. 4 looks over and says that's not a 4 either. Though I do need a 4 in this column somewhere. Ranks points out this 6 sees that 7. And that now sees this cell, which is not a 6 or a 7, so it's an 8. So that's a 6 and an 8. 8s are purple, we need to remember. This 7 is yellow. That 8 makes this a yellow. It's a 7 and a 6. This 7 makes this purple. Did 8. It's not an 8. This 8 is also purple. We'll try and be very cognizant of our coloring as we move towards the conclusion. Okay, what are these digits? 4, 5, 6, 8 is the answer. These are not 6 or 8, so these are not 4 or 5. This one's also not 8, so it's a 6, and that one is an 8 and is purple. I don't think I can do this 4, 5 yet. Let's ask about this box. This box is missing a 2, 3, 4, 5, 6, 7. These are not 4 or 5 or 6 or 3, so none of these are 2 or 7. These are not 3 or 5, so these are not 4 or 6. That 6 looks over and sees this 4, which sees this 6. That 4 looks over and sees this 5, which sees this 4. That 5 looks over and sees this 3, which sees this 5. That 3 sees this cell is not a 3, so that's a 6 or a 6 and 7. So that's a 3. That 7 looks over and sees that this is a 6, so this is a yellow 7. So this is a yellow 7. Let's see. Are all of our 7s properly attired? Oh, we have a 7 over here that is in need of attiring. Okay, so 7s are attired. 8s. 8s are attired. 1s. 1s look attired. 2s. There is a 2 to attire here, so I have to be very careful. So every box should have 5 colors in it before we move on. Every box has 5 colors in it. Great. Okay, so that's a 7. That's a 2. And we wonder what these digits are. And we remember we didn't give a bet cell, so we're going to make that the bet cell, so we can finish it last and claim that we made a very, very good bet cell. This is a 4. And the bet cell is a 3. Congratulations to Bremster. Excellent. Well, that was a lovely puzzle. Just the right amount of teeth, I think. Yes, it's so close. Frank's almost got there, but Bremster wins the beta cell. Alrighty, well that was a wonderful day of puzzles. If you didn't see it at the very beginning, which probably you didn't, because probably there aren't a lot of people who hang out the whole 8 hours, although some of you do, which I very much appreciate it. But at the very beginning, I did an hour and 15 minutes or so introduction to Kropki. So if you are interested in sort of a tutorial-ish thing about solving Kropki puzzles, I recommend you go back and watch that. If not, it'll get posted to the channel as a sort of like clipped VOD later, so if you're interested. But I am intending to do about once a week a like hour-ish intro where I'll do some simpler puzzles with the mechanic and talk through the basic deductions that show up with that. So if you are interested in making me a 2 or 3 star puzzle which uses exactly one mechanic, I am very interested in seeing it, so you can send it to me. I am happy to look at it, and I might well use it for a subsequent Zeta day, Zeta tutorial day, or whatever, when we do the next mechanic. I don't know what the next one will be yet. It'll probably depend on what puzzles I find that I'm like, this looks perfect. Anyway, lovely hanging out with all of you. I'm going to go eat dinner. So that's all for now. Special thank you to all of you who support the stream by either the Patreon or joining on YouTube. You can do that right now if you want. If you click the join button down below, you can get a green name like Screaming Ice Cube has there. Or if you prefer Patreon, you can go to patreon.com/zetamath. That works just as well. So you can do either of those. And either way, if you support at the appropriate level, you can vote on what puzzles we do. We always do the most voted on puzzle every stream. So you can see what's sort of coming up and voice your preferences. We've been getting a lot of votes lately, which I'm very excited by. So it's neat to see what you are all picking out. And an extra special thanks to those of you who support us at the tippy top levels, which includes Franco, who I see in chat. Hey, Franco. David, Michael O'Connor, Nordy, and Woofer, who've both been around a great deal today. Thank you all. I will see you for my next stream on Saturday. Yes, Saturday sounds right. Bye for now. And by the way, if you're interested in the Outer Wild stream, I'll let you know when the next Outer Wild stream is going to be. It's going to be a little bit just because I have appointments at the other time. So Tristan and I will pick up our terrible exploration of the galaxy, where I will crash the spaceship horribly into planet after planet. But it will be a little bit before then. Bye for now. All it's supposed to